All right. Well, it looks like we're at 9:31, so we'll get started on time. I want to thank everyone for being here and welcome you to this event. We're really excited about it, and I'm Danielle Downey. I'm the Executive Director of Project APIS-M. PAM is an organization that was built by beekeepers and growers for the purpose of honeybee health and vitality. And we get funding from beekeepers and bee clubs, growers of pollinated crops, and corporate partners and grants. And we use that funding to do a variety of things. So you'll see this slide at a lot of research talks. PAM is primarily a research organization. We fund practical research to help beekeepers and growers with things that affect how they do business. Right now, we're at about almost 150 projects, and we expect to pass $9 million in research projects in the next year. So that's pretty exciting. And we've actually funded a lot of this work on indoor storage. We also put forage back on the ground and are approaching $3 million in just putting seeds back on the ground to make the landscape support honeybees with better nutrition. So that's a second component of what we do. And this resources part is what we're going to talk about today. So the resources are not strictly research, but they're really important and needed and wanted by beekeepers to share the technical knowledge and practices that are really working to help people be more effective with their beekeeping. So we work a lot with commercial beekeepers, and this indoor storage concept is really changing a lot of how people are keeping their bees and being successful. And it's also in partnership with pollinating almonds. So much of the work that you'll see these practitioners talking about is wanting to be prepared to pollinate almonds and limit that attrition and become a more predictable product to take to the almonds early in the spring. So the resources include things like this indoor storage guide, which we worked with to produce with Washington State University. This was funded by Healthy Hives Initiative, which is funded by Bayer. And we made this guide to try to capture all of the state of this technical knowledge about the indoor storage of honeybees, because as you all know, there's a ton of questions about how these buildings work. How do we avoid the mistakes that everybody learned so much from? And what are the barriers and what do I need to think about before I invest and get started and change my management to use this new tool? So the indoor storage guide began a couple of years ago with funding from Healthy Hives. And we're now in the second edition of this. So as the science and the state of our knowledge is updated, we will continue to make this guide current, and you can download it and print it or just view it on our website. So the guide was the first product, and we're really excited to bring this event to you. This was a great idea. It was actually the Almond Board that said, hey, let's try to increase adoption and offer an event. And we had hoped to bring you to Idaho and host this event in person. Unfortunately, it's a tough year for that, but the perk is that many more people get to join us. But I do want to point out the structure that we have built into this conference is really intended to be as close to that tour that you could get. So we have films that will be showing that our tours of these facilities and talking to these beekeepers and these experts in building the buildings. And I want you to keep in mind as you're watching this video that this footage was taken last week. So really, we sent a crew there and met everybody there and watched all this happen in real time and produced these videos to give you as close as possible experience of being there yourself. So we're going to transport you to these indoor storage buildings today. We really appreciate everybody coming here together and making it possible. We have research talks in addition to the videos, which are the tour, and then we have panels so that you can hear from the beekeepers themselves how they're using indoor storage and ask them your questions about getting started. So many people made this possible. I'd like to thank the film crew who is part of PAM Communications, Washington State University. Kelly and Brandon really did a lot to go and coordinate with the beekeepers in Idaho and the experts there to make sure that we could capture the footage and produce these videos for you. And the Almond Board of California was really the spearhead to get this thing started and push to make sure we could get it done this year. So thank you all. And before we start, we just want to make sure, we knew that Zoom might give some people a little bit of fits this morning because this is a large meeting and the platform requires that you log into Zoom to use this platform. And so you have emails that we've been trying to prompt people so that they are ready. And if you get text messages or emails from friends that are saying the link won't work for me, are you in? Please tell them that if they have a Zoom account, they need to be logged in. And if they don't want a Zoom account or don't have one, they can email Kelly and she can send them a link right now to use this without a Zoom account. So with that, we are going to also ask you to put some information in, and we've got some poll questions. Kelly, do you want to bring up the first poll? All right, so if you could just click the answer for yourself, and then Kelly will see those coming in. And when she gathers enough input for the questions, then she will show you the answers so you can see who else is at the meeting with you. So it looks like we've got a pretty good spread of folks joining us from all over the place, which is excellent. And indoor storage interests are also, we've got a lot of curious about the research, which is great, and some practical management improvements there too. So very good, thank you. All right, with that, I would like to introduce our first research talk. We've got a research talk from Dr. Gloria DeGrandi-Hoffman. She studies the physiology and nutrition of honeybees. So when we think about indoor storage, she's really the expert that's asking what's happening inside those bees. How does it matter where the latitude is? And that'll put her in a good position to study and understand the climate change effect on indoor storage of bees. So many of you submitted questions in your registration about what is happening inside the bees. And this research talk today should be a great opportunity to get those questions answered. So Gloria, if you'd like to share your slides.
Sure, Danielle, thank you very much. I'm going to pull it up here. I'm hitting share screen, and there we go. All right.
Looks great, we got it.
So far, so good, Danielle. Okay, so let me see if I can minimize that. Just a word before I get started. You know, I'm working from home and so forth, and my dog is right here sleeping right now. But now that I'm starting to give this talk, she could wake up anytime and bark. So I want to apologize in advance for that. I'm so glad to be part of this conference. When you know, we first started to talk about it, it's so important that we're talking about overwintering colonies and cold storage. At least that's my opinion, and because, you know, we're not keeping bees now the way that we used to in the past, and the way the colonies are overwintering and the losses we're experiencing, we know something has to be adjusted in our management practices. So before I talk about our research today, I want to have some acknowledgments to groups that made this possible. Big thank yous to USDA-ARS, who funded all of this research for us. And it's very expensive research. There's a lot of travel involved. And so APHIS was generous enough to find this work important and provide us with funding. Harvest Honey is another group. The Verhoeks, those are whose colonies we've been using for the last, well, we're in our third year of this research now. And they're wonderful partners and collaborators and made this possible. And then our field crew, as you can see, some of know some of these folks, Henry Graham, Mona Chambers, Emily Watkins DeYoung, and Lucy Snyder, were the ones who gathered all the data that I'm going to show you today. And you can see it's a lot of data. And in each of these groups of colonies, we're talking about 150 to 170 colonies within each of the treatment groups that we're going to show you today. So a lot of colonies that they went through and a lot of data that they gathered and to make this possible. So why pursue this line of research in terms of looking at putting colonies in cold storage? And this is what I alluded to before. We've been losing colonies. You average all these together, it's north of 40% of our colonies every year, and most of those colonies are being lost in the overwintering. Not every year, but in many years, in some years like 2018, 2019, the losses are substantial. And we haven't successfully reduced those losses. Well, why is this? Why are we losing so many colonies? Well, as Danielle alluded to, is nutritional stress and trying to get enough forage in the ground so that if you take your bees to California and have them overwinter there, that there's some pollen coming in at all times to keep those bees rearing brood and to keep them healthy. Because we know no matter how good a nutritional supplement may seem to be and how well the bees eat it, there's still problems with depriving bees of pollen. They lose queens, they get diseases, the brood is, they're not making enough brood to replace the bees that are foraging and dying. And so colonies, it's hard to keep your colonies, even at a stable population, let alone keeping those colonies from declining. And you know how it is. Once colonies start to decline, man, it's a slippery slope, and down they go. And you've invested a lot of money in a colony by this point in time, and to see them, be lost, it's not just the rental fee; it's all the money that you put in up to this point. Another reason we lose, and I'm sure I don't have to tell anyone in this group about varroa mites. And varroa mites was one of the reasons that I got into cold storage research. And here's my little story about that. We started to do studies with varroa mite, looking at the effectiveness of miticides and timing of miticides and so forth. And, we developed a population model to track varroa mites and their growth and so forth. And we went out in the field and found that in the fall, we had these spikes of mites in colonies that had, we were earlier, 2 months before that, we couldn't find a mite in a colony. And so, we started to look at the frequency of mites migrating into colonies with on foragers, because the numbers that we were getting, that was a plausible explanation. So we've been doing this research on varroa mites and looking at the effects of mite migration on foragers for the last several years, and published, you can see several papers, actually a lot of papers on this. But you can see that this migration starts in September and continues, and by the time you get into November, I mean, it's not hard to find foragers coming in with mites. And this is a study that we did to see if we could slow down the effects of these mites by feeding colonies pollen patties, putting pollen patties on these colonies every week. And it didn't slow down the migration. The mites went into foragers with mites went into the colonies, fed ones and the ones that weren't fed. And as we were increasing our frequency of mites on foragers, so we're increasing the frequency of finding mites on bees, our mites per 100 bees. Here we were down in July, and you know, I was saying we couldn't find mites on the bees, and August was low. September was looking pretty good, and then we started up this scale here, and you know, I'll tell you, many of these colonies, needless to say, didn't make it through the winter. We also measured virus titers. This Dr. Judy Chen from the Beltsville lab was our collaborator on this, and what we found is that, you know, as these mites went up, so did virus titers, deformed wing virus. That's the black line that you see there. And even this is combined data, because we found that even though we fed the colonies, the fed and the unfed colonies didn't differ in their virus titers. So these migrating mites are just driving this what will be an overwintering disaster, because, you know, colonies that have high virus titers have low chances of making it through the winter and into the next spring. So it was like, you know, this environment is becoming increasingly hostile to bees as we go into the fall, and maybe we shouldn't leave them into the environment. Another area that I've gotten into recently with some other modelers and Brandon is in this team with modelers over at Washington State, is to look at the effects of climate change on colony population dynamics now and moving into the future. And here's why it's important. And this is something that I've been actually thinking about for a few years, and it all started with a warm winter that happened in Pennsylvania. Some of you know this story because I've told it before, but this was really the catalyst. I was talking to my sister on Christmas Day, and she has bees, and it was 60 degrees on her porch in Lewisburg, Pennsylvania. And the bees were up there with her on Christmas Day. And after we got off the phone, I started thinking this probably isn't good for bees. And so, you know, I pulled out my model and started running warm weather scenarios. And the you know, it wasn't good. The way that the population dynamics played out. And here I'll show you why. So I cherry picked a weather scenario from Aurora, Illinois, at the turn of the century, because, you know, when you look at those weather files around the early 1900s, man, they had some cold winters, and those winters, you know, those cold temperatures started fairly early in the year. And you can see our population of bees. This is output from our Varroa pop model. So this is our population dynamics model. These are predictions from that. So we started an overwintering colony in April, and you can see that colony grew under those weather conditions in Aurora. And as we go into the fall, the colony starts to decline because brood rearing starts to decline. And then as we go into winter, you can see that little increase where the last brood cycle emerged in the colony, added itself to the adult population. And these are all just adult bees. And there's this long period here in the winter where the bees are in cluster and you know, maintaining their population. And then spring comes around and they get a little flight weather there around, you know, the end of March, early April. There's a little decline, and then it got cold again, and they were rearing broods. So, you know, bees were emerging, but there wasn't much flight, and so population kicked up again, and then it got warm. And then the bees started to fly, and we had kind of the remainder of spring dwindling there, but there was enough brood in the colony, and the age structure of those adult bees was such that they were able to push themselves out of it. And the colony started to grow again, and everything was great. And bees were doing great in 1904 in Aurora, Illinois. Then we take that same area, Aurora, Illinois, and now we look at the weather in 2006 and 2007. And same thing, they grew real well during the summer, and we're heading into winter. And there was, in the wintertime, after the bees had pretty much stopped brood rearing, that first decline is around the end of November. And the weather was still warm enough for the bees to forage, but there wasn't much brood in the colony. So the colony populations kept declining. And then it finally got cold. And you can see that little shoulder there that started in late December. And so the bees were in cluster. Then it got warm again. And so they flew in January for several days. And there was another decline. And then it finally got cold for good. And they stayed in cluster until, it was, about the third week in April. But they had been flying and foraging when there, wasn't much brood to replace them. And when it got warm and they finally started to fly, the number of older bees that had foraged before had outnumbered the number of newly emerging bees. And so that population started to decline. And when populations get small, they can't rear new brood at rates to replace the bees that are dying. And this is the slippery slope I was telling you about. And so the colony, ultimately died. And I should tell you, this colony, we set up these simulations. There was no nutritional stress. There were no mites in this colony. This was strictly because of the weather that was going on out there in the fall and in the winter. And in working with our colleagues at Washington State, what we're finding is that the frequency of these warmer falls is only going to increase as we go forward and our climate continues to warm. And so this sort of was a wake-up call to me that we're going to have to adjust overwintering, because keeping colonies out and having these warm falls and winters, we're going to have years that we're going to lose a lot of colonies because of that. So as I was saying, we've been doing this research for, we're in our third year now of it, and we've learned a great deal. And the first year that we worked with the Verhoeks, they put colonies in cold storage in Idaho, and they were in those potato sheds. And they had to wait till November to put those bees in those sheds because they had to wait for it to get cold. And, looking at the situation, I thought, if we had facilities that were chilled, it could be better in terms of a population overwintering with a lot of young bees if we put them in early, like put them in somewhere around the middle of October when that last brood cycle was in the sealed brood stage. If we could get those bees to just have sealed brood as they were going into cold storage, so that brood would emerge and you'd have this population of young bees that never foraged before. Now they might cushion some of that spring dwindling like we saw in Aurora, Illinois in 1903. And so first thing that we did was do a comparison of putting colonies in cold storage in October versus November to see if there were any differences. And we put them in cold storage facilities in Idaho that were chilled facilities. The second thing is that the Verhoeks and many other beekeepers who are in more southern latitudes also want to put their bees in cold storage. And, we didn't know much about this. And so we added this to the experiment as well, where there were sets of colonies that were in southern Texas that were going to go up into cold storage, and we were going to do lots of measurements, and we were going to see what happened to them. And I'm going to share that with you today. So here was our experimental design. We had two sets of colonies. One set was up there in North Dakota, the other down there in southern Texas. In North Dakota, we had two groups of colonies, a group that went into the cold storage facility in October, a second group that went in November. At the same time, we were putting the North Dakota bees into cold storage in November. The trucks from southern Texas were also coming up to that cold storage facility. So we had colonies from Texas going into cold storage in November. They stayed in cold storage, all 3 groups, until the end of January, and then moved down to California for almond pollination. So the data that we collected from these 2 sites, Baldwin and Danbury, was we looked at colony sizes before and after they went into cold storage, and then after almond bloom. We looked at the colonies to see what their mite numbers were, what their nosema levels were before they went into cold storage. We also dissected fat bodies out of samples of these bees to see what they look like before and after cold storage. Particularly, we looked at protein and lipid levels in the fat body because we thought that might reveal some clues about whether those bees were winter bees, because winter bees are supposed to have large fat bodies and high lipid contents in their fat bodies. And we thought measuring lipids and proteins, we could perhaps test for relationships between those 2 components and sizes of colonies coming out of cold storage and amount of brood in those colonies coming out of cold storage. So these were our data sets that I'm going to share with you today. So the first thing we did is we went into the 2 study sites, North Dakota and Texas site, and chose our colonies in September. And this came from our first year of study, that we found that colony size in September and mites per 100 bees in September were our best predictors for what our colony size was going to be when the bees came out of cold storage. And I'll share this again with you. The fate of these colonies in cold storage is sealed in September. If you have high mite numbers in September, the probabilities of those colonies coming out of cold storage with enough bees, even if you treat in October and you're in a northern latitude, is low. So that's why we went up there in September and chose our colonies in North Dakota, and also chose the colonies that we had in Texas. If you want to read more about this, you can go to the Carl Hayden Bee Research Center website and just click on the cold storage information page, and you'll see the latest information about our cold storage research and a more in-depth explanation about the significance of September selection of colonies. So you can see we had like 12 framers coming out of North Dakota. The colonies coming out of Texas were about 8 framers. They all had, 3 or better frames of brood in September. They didn't have many mites. The mites were really under control in those colonies, and we measured those both with mites per 100 bees and mite drops. We did have nosema in those colonies. You can see that in October, the colonies, particularly in North Dakota, had rather high nosema levels. Now, those nosema levels didn't get any larger while they were in cold storage, but the colonies that were in Texas, which started out with low nosema levels, had rather high nosema levels by the time that those bees came out of cold storage. So I want you to hold this kind of in the back of your mind, because this is something that could be important in terms of colony sizes coming out of cold storage and also coming out of almond bloom. So we measured the colonies a second time right before they went into cold storage. And the colonies that we put in October were now about 15 frames of bees. So they got a little bit bigger before we put them into cold storage. And the colonies that were we put in November, actually, they lost a little bit of bees between October and November. And so they were 13 framers. The ones in Texas continued to grow. So they were up just around 10 frames of bees. After we took the bees out of cold storage, you can see that, we lost about 4 frames of bees in each of these treatment groups while they were in cold storage. But the largest colonies were the ones we put in October, followed by the ones in November that were from North Dakota. The ones from Texas, as you can see, did not do very well. Post cold storage amount of brood, those queens started to lay while the colonies were in cold storage. And the ones that we put in October had, slightly more, statistically it was significant, but, slightly more brood than the ones that we put in November. The colonies in Texas had that queen had just started to lay as we were close to coming out of cold storage. So there was a delay in egg laying in those bees that were from Texas. If we look at the percentage of colonies that had 6 or more frames of bees that would have been good to rent for almond pollination, almost 80% of the colonies we put in October were 6 or more frames. It's about 74% for the ones in November. But man, we didn't even have 40% of our colonies that were from Texas that were going to be 6 frames or more to rent for almonds. Another interesting thing that we saw was sealed brood, because that's the beauty with working with bees. If you see sealed brood, you can get an idea of when the queen started to lay. And about 85% of the colonies that were from North Dakota had some sealed brood in them. So we measured these in the beginning of February, and if we had sealed brood in, that queen started to lay about somewhere between the 2nd and the 3rd week in January, when those bees were from North Dakota. We only had like about 3% of the colonies from Texas that had any sealed brood in them when we took them out. And this sealed brood is really important because these are the bees that are going to be the first replacements for our older bees that are going to be out there foraging almonds, right? So, we want to maximize sealed brood again to cushion that spring dwindling. So taking a step back now, we're seeing that the bees from Texas and the bees from North Dakota were really different. And they were different at the colony level in terms of their ability to produce brood in cold storage and in their colony numbers after they came out of cold storage. So we sampled bees because we suspected that the bees that were from Texas were going to be physiologically different than the ones in North Dakota. We were pretty confident that we had winter bees in North Dakota because the brood rearing was really on the decline. And of course, by November, there was no brood left in the colony. The ones in Texas still had brood in them. That queen was still laying before they went into cold storage. So what we did is we dissected out fat bodies from samples of these bees. And these are pictures of what fat bodies look like and where they are on the bee. And in winter bees, they store a lot of nutrients that they're consuming in these fat bodies because, they don't have brood to rear. And so they're still consuming resources, but, putting it in these fat bodies that then get mobilized throughout the winter and in the winter cluster to, help keep the bees warm and keep metabolism moving. But, most importantly, to be there to rear new brood when the queen starts to lay again. So if we look at the analysis of the fat bodies, what we found was that before we put these in cold storage, the weight of the fat bodies was similar among our 3 treatment groups, and it was similar, after cold storage as well. The bees we put in North Dakota in November, where it looked, a little bit larger, but those differences weren't significant. If we look at the protein concentration in the fat bodies in the bees before we put them into cold storage, you can see those bees from Texas had high concentrations of protein in the fat bodies, significantly higher than our 2 groups from North Dakota. And if you look at the lipid levels, it's exactly reversed, where going into cold storage, the highest lipid levels were in the ones we put in October from North Dakota, followed by the North Dakota November bees. those bees from Texas had significantly lower fat body lipid concentrations than the bees from North Dakota. You can see when they came out of cold storage, it's kind of interesting. The fat body protein concentration actually was higher than when they went in for the North Dakota bees. And the lipid concentrations was reduced in all of them, and there was no difference among the three groups in the post-cold storage lipid concentrations. But the North Dakota bees in October and November, they were also, showed some differences as well. And so, there's some possible explanations for that. And of course, the first place that I looked was in the weather files from Baldwin, North Dakota, what was going on weather-wise there between the time that we put our first group of bees in October in cold storage and our second group in November. And what I found was that there was flight weather occurring up until October 26th. And they weren't flying 12 hours a day, but they were flying for several hours just about every day until October 6th. And so, if they're flying, they're continuing to burn up resources and continuing to age physiologically because of the stress of flight. And so our age structures in those colonies that we put in October versus November were probably different because of the flight weather that occurred. There were other differences too, and that was what the fat body revealed. Our fat body weights were the same between the October and November groups, and so was the fat body proteins. It looks a little lower in October than November, but these differences weren't significant. But what was significant was fat body lipid levels. They were significantly lower in those November bees. And, I attribute that to those weather conditions over those couple of weeks where the bees were foraging and burning resources. So we went back to California in March after the almond bloom was over. And essentially what we were measuring was how deep was the spring dwindling in these colonies and what they were going to look like coming out of almonds in terms of their chances of bouncing back up from the spring dwindling and becoming, strong colonies and able to make splits from those colonies and when you take them back to your home apiaries. So we measured these colonies, and the largest ones were the ones that we put into cold storage in October. They lost about 1/3 frames of bees, but they came out as 9 framers. That was followed by the bees that we put into cold storage in November from North Dakota. They lost 2.5 frames of bees, but were still a little better than 6 framers. The ones from Texas were 4 framers, and they'd lost 1.4 frames of bees. So these bees, not only did they not look great going into almonds, they did not look good at all coming out. I mean, we had colonies that were 4 framers from Texas, averaging about 3 frames of brood. And so, those were going to be hard to build up and to make into splits when they left almonds. Whereas the ones that we put in from North Dakota, we had almost 5 frames of brood in those in our October group, and a little better than 4 frames in our November group. So again, the North Dakota colonies fared much better than the Texas colonies. So, what do we know at this point? Well, colonies in northern and southern latitudes are really different physiologically in the fall, and that's going to have to be something that we factor in to developing recommendations for putting bees in cold storage when they're from southern latitudes. And this also opened up an area of research for us in getting a better understanding of what's causing the formation of winter bees and how that might be tied to brood rearing in the fall. We also found that there's real advantages to putting colonies in cold storage in October. And there's economic advantages as well, because if you can not have to put one last feeding on those bees or one last mite treatment. That's a real money saver than keeping them out into November. It would counter the additional rental fee for the cold storage facility. So, my last analyses that I did were looking for relationships among the elements that we measured between pre and post cold storage colony sizes and what could be driving this. And here's a little flow that put together. Before cold storage, the frames of bees that you have in the colony and the amount of fat body lipids that are in there is going to drive the frames of bees and brood that you have after cold storage. And it may also affect when egg laying starts as well. It certainly looked that way from our North Dakota samples. And after cold storage, the frames of bees and the frames of brood, the colony sizes after cold storage are going to directly affect the frames of bees and frames of brood after almond bloom. Essentially, how deep is the spring dwindling going to be, and how that will affect the chances of a colony pushing out of that and beginning to grow again in the spring. So our current research this year, we have experimental colonies in cold storage in Idaho that, again, we're working with Harvest Honey, and we're looking at the effects of nosema more deeply. I mean, we have a goal. We had about 80% of our colonies we put in October being able to be rented as 6 framers. And I think we can do even better than that. And maybe the first thing we need to do is get this nosema under control. So we have an experiment going on where we have greater control of nosema, I hope, and see if that doesn't improve our post-cold storage colony sizes. And we're also looking at the role of brood production in the formation of winter bees and trying to get a better handle on that. And because that's going to be key to see if we can put colonies from southern latitudes into cold storage, or whether that maybe is not an option for bees that are in summer and winter in those areas. So I'd like to thank you for your attention. I feel like I've really talked a lot here, and we have a lot of people out there. I'm sure somebody else has something to say. So I'm going to end here and turn it back to you, Danielle.
All right, thanks, Gloria. That was a lot of information. And I think Grace has been gathering some questions.
Yep. Yeah, we have a few minutes for questions. If you guys want to put them in the chat or raise your hand. Thank you so much for your presentation, Gloria.
You're welcome. Feedback.
It's just amazing to me how a month difference going into winter storage makes such a difference. And those pictures you had of the fat bodies were just amazing.
I want to thank Vanessa Corby-Harris for that. She's the physiologist on this group, and yeah, she taught folks how to do the fat bodies. That's her picture of a fat body. So yeah, that's, Danielle, you were saying, I'm a physiologist and nutrition, everything. I'm a wannabe, because actually I'm a modeler, and I get all these people who know a whole lot more than I do to work together with me on this and do the physiology and help with the nutrition, help me interpret things, data that
well, it's nice to have the focus all fit together into a nice picture that you can interpret. So teamwork makes the dream work, right, Gloria?
You got that right. I'm still trying to figure out how to get my screen back again. All right.
I think you should have an option to stop sharing either at the bottom or top.
Okay, I'm going to do that. Okay. Perfect.
And we got a question early on about some of your beginning slides from Bill. He says, it looks like fall feeding increased the mite infestation. Is that population related?
I mean, it could have been. Actually, I'm trying to remember if those mite numbers in the colony were significantly different from each other, but it might have. I'd have to go back and tell you the truth, pull it up and look at it again. But yeah, if the person who asked the question saw that, yeah, yeah, there it was.
And Vera asks, what was the winter survival of the indoor stored colonies?
You know, that's why we put it at 6 frames. And, you know, I also did another analysis that was at 4 frames and, you know, was even a little bit, you know, higher, 4 frames or more. So, you know, what you saw was what I considered the survival, you know, 6 frames. Because, you know, we had in the colonies, you know, colonies that came out of cold storage that had like, you know, 1.5 or 2 frames of bees. Well, you know, that's not 0. They didn't die, but, you know, we were going to need to combine them into another colony. So it was, you know, numerically the same as that colony dying. So, you know, what you saw was what I would consider their survival. And I would say for the ones in North Dakota, if you wanted to go 4 frames, it was around between 75 and 80% of the colony survived over the winter. And it was less than 50% for the ones in Texas that came from Texas.
And kind of related to that, would you say the phrase "what goes in is what comes out" is pretty accurate in terms of survival? Strong colony going in is gonna do better.
Oh yeah, most definitely. I mean, nothing gets improved in cold storage. You know, I mean, it's and actually what goes in, you know, what in terms of what you've measured in September is going to be what determines what you get out. High mites in September, and we've been finding this right along with varroa research and in modeling mite populations and so forth, that the winter bees up in those northern latitudes, you know, are being made in September. And if those bees have a lot of mites while they were developing and you know, high virus titers, they're short-lived bees. And when they go into even cold storage, they're not going to do well. So yeah.
And then going back to some of your current research, we got a question. Could you speak more about the methods of nosema control?
We just put fumagillin in. That was the, you know, we did a laboratory screening of all kinds of things that were out there that for nosema. Was it Honeybee Healthy, Hive Alive? We also had another product that somebody gave us, and we said that we would test it for them, and we tested all of them against nosema. And the way that we did this was that we took newly emerged bees and fed them 100,000 nosema spores each, and then put them in cages on sugar syrup that contained these different hive products, and nothing could beat fumagillin. So that's what we went with in the colony study up in North Dakota this year.
Great, thank you. And we have, can we expect 6 frames of bees with 1.3 frames of brood at the beginning of February for almond season? So I think the assumption is if they had, it was a decent colony going in, when they come out, can we expect 6 frames of bees with 1.3 frames of brood by the beginning of February for almonds?
I think that if mites were controlled in September, and you know you had these low mite numbers going in, even with nosema at levels that we had, our data would would show that it's a possibility.
And so Gilbert asked, what date in October is optimal to begin storing bees inside?
Okay, that's a great question. You know, I didn't go into this much, but you know, it depends on your latitude, and we want to fine tune this. And this is all, you know, going to be a modeling project that we are going to be doing with the group in Washington State, where depending on your latitude, we can get a pretty good prediction of when your queen's going to stop laying, and then count out from when your queen stops laying as to when that brood will be sealed, and there'll only be sealed brood in your colony, and then you put them in. And so if you already have a feel for this, for where your apiaries are, then that's what I would say is the time in October to put them in. Just doing some, you know, simulations without a lot of really, I would call, say, precision in terms of latitudes. And the range was somewhere between the 2nd and the 3rd week in November, or a 2nd and 3rd week in October is where that sweet spot was. You need to fine tune it with the latitude, but that was a window.
Awesome. Thank you, Gloria. And just a couple more questions coming in here. And I'll remind everyone, Gloria is also joining us for the panel later today. So when you were working with the Nosema, were you working with Nosema apis or Nosema cerana?
We assumed it was Nosema cerana because we can't find Nosema apis anymore.
Great.
And but we didn't do the definitive test, so I can't say 100%.
And then what is the dynamic of mite migration versus mite reproduction in brood in late summer and fall? From George.
Yes. Okay. And that's this again. This is an excellent question. And you know, one of the things when we first built our Varroa model was we put in all of the literature values for mite reproduction and so forth. And one of the things that we were surprised with was that as colonies grew, of course, mite numbers grew, but they grew at rates that just did a little better than replacing themselves. You know, each mother mite that went into a worker cell produced about 1.5 mated offspring, daughter mites. They did better in drone brood, but there's not a lot of drone brood in a colony, and it's only in a window of time. I mean, I say there's not a lot of drone brood in comparison to worker brood. And also the bees or the mites seem to congregate in that drone brood. And anytime you get more than one mite in a cell, reproductive rates of all the mites go down. So we you know, programmed in all of these dynamics, and what we found was the colonies can get large mite populations, but it takes several years. And then we went out and we measured it in the field in a commercial apiary. This was about, I want to say about 5 years ago. And we found this spike in mites when we started out actually with colonies with, geez, we couldn't find mites in them because we had applied a miticide while we had packaged bees. We applied the miticide in the package and then put the bees in the colonies. And, you know, we're measuring mite populations, and they're really low mite populations. And we were tracking them with the model, and they were tracking right along with the model, and then they spiked up. And so this mite migration is, if you have low mite numbers early in the year, it's just overwhelming the population of mites in terms of its rate of increase as you go into the fall. I didn't point out that bee that I was showing on that slide. It had 2 mites on it going into a colony, you know, 2 mites under its abdominal sclerites. And so we get mite numbers that you can't explain by reproduction alone. So George, I realize it's a long answer to a short question, But if you've got a lot of mites in the colony in the summer, then you'll have a lot of mites in the fall because of reproduction. But if you don't have a lot of mites in the summer, you still may have a lot of mites in the fall, and that's migration.
Thank you, Gloria. And we'll do one more question for this segment. And then everyone feel free to also keep putting your questions in the chat. We'll pick them up at the panel. How long does the field force live coming out of cold storage? From Steve.
That's going to depend upon its age structure. Those bees that came out emerged late in the during the last brood cycle, and if they emerged while they were in cold storage, they're going to be your longest lived bees. Bees that were foraging the previous fall and maybe clocked in hours of foraging and then went into cold storage or went into winter cluster, when they came out, their longevity is going to be connected to how much they flew previous fall. So there's a whole range of how long that they're going to live, and how deep that spring dwindling is going to be is going to reflect that age range of the bees that went in to cold storage in the previous fall.
Excellent. Thank you so much for your presentation, Gloria, and for answering our questions. And we look forward to seeing you in the panel later.
Thank you.
Okay, everybody. Before we move on to our tour, our film tour, since we couldn't be there in person, we have a couple of poll questions for you, just to find out a little bit more about who's here and what your interests are with regards to indoor storage. So I think, yep, there we go. So are you interested in using indoor storage in your operation? And if you are interested, what is your biggest barrier to starting? All right. So yes, many of you are interested. I think that's why you're here today. Some of you might be interested. Several of you are already using indoor storage. Some of you who are interested haven't started yet. Too expensive. I think we'll talk more about some of the costs later. Don't know where to start, and not sure where it fits into my operation and schedule. So hopefully we can help out with some of that today. What we're going to do next is play the first of 4 videos touring indoor storage facilities. So this first video is all about the buildings and the HVAC and gives you kind of a good introduction to indoor storage. And so I'm just going to load that up right now. Let's see.
If you want to take some shots of what it looks like outside right now, that'll give you a pretty good idea of what it looks like in Idaho in the wintertime, and sometimes what it looks like in the Central Valley in the wintertime. And that's pretty hard on bees. I don't know if that's the cold that kills them, but the wet, the high humidity, the moisture. We could get them in here and hold them at 38 to 42 degrees and keep them from basically being soaked all winter.
We first experimented with storing bees indoors in the late 1980s or early 1990s. We found an indoor building that we could put the bees in, and we didn't know much about it. We didn't understand the needs for ventilation, and we lost some of the bees just because I think oxygen deprivation was too tight and we got too much CO2 in there and killed some of the bees. So it was a learning process, but we got serious about it in the late 1990s, started storing almost all of our bees indoors, and so we've been doing it for more than 20 years now.
My career is farming, mostly potato farming, and so I had spent 20 years around storages, and a big beekeeper out of Texas found us and asked us to build him the first storage that I was involved with. Not everyone wants or can or wants to afford their own building, and so that's how we've kind of tailored our business is to build big enough buildings that we can lease out space to beekeepers. So we're storing on the facility, we're storing, if you count the beekeepers' bees that owns the own building, there's 150,000 hives on the facility.
In the early 90s, Dad rented a apple storage, stored for a couple years indoor, and I was pretty young then. All I had to do was sweep up dead bees, that was my job. Then we stored outside in California for a while, stored outside in Idaho for a while, and then decided to build this building in '06, and this is basically, this building will hold about 7,000 hives. It's just uses ambient air to keep things cool. Kind of got a little bigger after that, built another building, and then a couple years ago built a refrigerated building, and so got 3 of them that we store indoors.
We stole the technology from the potato industry. Potatoes and onions in Idaho have buildings very similar to these. They try to utilize as much outside cold air as they can. There's big fresh air doors that bring fresh air in when it's cold enough, and when it's not, the refrigeration turns on and the air is just circulated. It's through the bees and back through the refrigeration evaporator coils. And
we've learned from our own experience. We've learned from other people's experience. We've shared information back and forth. People have tried different places and different things for storing the bees. We have learned over the years what the best temperature is to store them at. Did you feel how much warmer it was when you came in here? It's 24 degrees outside, it's 42 degrees in here. And we like to keep it at 42 degrees. That's the temperature where they do the best. They consume the least amount of feed, and we have the least amount of attrition.
And there's temperature probes in there that we pull out into the bees and stick in different spots. If it gets extremely warm, 60 usually, inside temperature, we've got misters in the ceiling we'll turn on. Like up on the ceilings, those little black deals hanging down, that's the misters. That's basically, if I can turn those on and they'll put a fine mist, like a greenhouse type mister, or like you've seen at a dairy, run them for about 2-3 hours, and that'll drop the temperature down into the high 50s, and that'll hold them, kind of calms the bees down and will cool them. I don't like to run them more than about 2-3 hours. You can create a mold problem in the buildings if you run too much moisture in there, but it does help to kind of calm them down. This is the original bee storage we built. We built this in 2006. It's basically designed toward positive pressure, so basically you're sucking in more air than you're letting out. In theory, that's based off, there's other beekeepers in this valley that have built buildings or retrofitted buildings to do that, and you basically shouldn't have any hot spots. That was the theory. So you're pushing more air and then you're letting out.
With all the small exhaust boxes with the positive pressure, you can kind of guarantee where the air is going. If you have exhaust there, that's where the air has to go. So you're positively pressuring the building, but if you know that you have bees and everything here, you have exhaust there and there. So you know that air is going to be moving in those directions. Where if you did a full sweep, you just did an intake and an exhaust, it'll migrate slowly, but you would have pockets in the corners and potentially where, in the sides, that could get hot because you're not guaranteeing where the air is going.
This is the bees in the stacks. They haven't been touched yet. They've been in here for 70 days. Ventilation comes from the middle, and we'll put those tubes in, very similar to what they do with potatoes. Those tubes are perforated, and so air comes out all the way through. We get good ventilation, good circulation. All of the return air gets sucked up through this side over here and back through the system again. And then it blends with outdoor air to control temperature and oxygen levels.
It's kind of like taking a shower. You've got it takes both hot water and cold water to create an exact temperature. And so we do the exact same thing here. We utilize the heat from the bees and then the cold air either from the refrigeration or from outside, but you mix the two to get that exact 40 degrees.
We're getting about 45 degrees on the outside versus about 35 on the wall, which tells me that there's a lot of heat coming from that hive.
So this moisture and the frost that's on these coils, that's
coming out of it.
bees breathing, right? That's
Yep.
coming out of the hives.
That's right.
That's that moisture.
Yep. Just you got a drain in the middle of the floor.
Yeah, that's a lot of.
Yeah, a lot of water.
A lot of bee breath, yeah.
I'll show you where it comes in later, but the air up above is the bees, is the return air coming from the bees. So this is where we measure the CO2, the level of CO2 coming off the bees. And it's using the bees as the heat source to mix with the cold. So it's turning the refrigeration, cycling it on and off to mix with the heat from the bees to get the right temperature. When it's cold outside, these fresh air doors act as a mixing valve. So it closes off the heat coming back from the bees or opens it up depending on how much you need, and then it exhausts it out another part of the building. Once these open up, the exhaust dampers open up and push the heat out. We're right on the other side of the bees now. This is our plenum, we call it, our air plenum. So now it's bringing that air that's the right temperature through those fans and forcing it down this hallway and then pressuring it up. So there's slits in this wall where it goes out to the bees, and those have all been sized to match the airflow. It's a little bit like a balloon. When you blow on the balloon, it goes all the way to the end of it and then pressures up backwards. So the air coming out of this fan actually hits the end of that wall first, and then it pressures everything up, and then it all goes out evenly throughout the strips, the slits. So there are bees to the top of the ceiling. It's pretty crazy. Yeah.
The refrigerated building, the reason we built that was for some other things that we were going to try to do that didn't really have anything to do with winter storage. It was more about getting bees to go broodless in the summertime to treat for mites, and we have played around with that a little bit.
So, concrete air floor, the air comes into this underfloor cavity and comes up basically through registers, kind of like this in the floor. There's small little slits where all the air comes up across the entire concrete floor. So air is coming up right through this little register right here, and they're evenly spaced across the entire length of the floor, width of the building, and length of the building. We specially sized these ducts to where when bees come through here for cleaning, there's enough space for a person to come in here and clean out the duct tunnels at the end of the season. This pretty much guarantees you're gonna have air evenly throughout the storage, but it comes with a price tag.
But that air floor is the best. In Boise, one bee storage has been put up that way. It's extremely expensive, but it is probably the Cadillac, right? It's probably the very best way that you could move air. It allows you to stack things any direction, any way you want, anywhere in the building, and the whole entire floor it moves air.
Across all these storages, the main thing is making sure airflow and oxygen is available at all times. So even if there's a power outage, we have generators for backup power, making sure the fans continue to run, always providing oxygen to the bees at all time. Other redundancies, again, if one fan were to fail, the system does not shut down. Just that fan would be down, and we will just run on the remaining amount of fans. Alarm callouts are sent out via text message or email. Nick gets alarmed, I get alarmed, and we'll jump on it service-wise as soon as possible to get things back up and running.
So this is this backup generator. So we can run 100% off the grid if we have to. I think we can get 48 hours. We got fuel capacity for 48 hours. This building we designed so that each corner of the building has its own air system and backup generator. And even at that, you'll recognize there's multiple fans, multiple compressors within the refrigeration units, just so that if any time we ever have any kind of a breakdown, we've got lots of equipment. It can run, it can limp along, even with 30% of it out of commission, it can still maintain what we need it to. So overbuild because we're storing a lot of bees in there.
You have to look at what you have during the time of year. I mean, if you're never going to have cold enough air to try and bring in, then you're going to have to size it refrigeration to manage that 18 watts of output per hive constantly, because that's the only sorts of cooling you're going to have. You can't rely on potentially, oh, we might get it, 10-15% of the time. Well, if that 10-15% doesn't ever come up, the building is slowly going to keep warming up, and eventually you're gonna have a bunch of dead bees. Here again, wintertime, we're having, ambient temperatures that are gonna help supplement that. So you're not gonna have to base an entire refrigeration load off of just what's inside. We're gonna have Mother Nature help balance that out. Southern California and the hotter areas, if we're not getting below 70 degrees, okay, well then we're not gonna get a lot of outdoor runtime. Maybe a little bit at night we're gonna be able to supplement, but it's probably gonna be almost exclusively refrigerated to be able to maintain 40 degrees to get your hives broodless and get them to a point where they're not eating a lot and they can be managed easier inside the storage. So that's regionally, it's very different. I mean, it's very different from this side of the state, southwestern Idaho, to southeastern Idaho, and going, just across the Montana border. It's very, very different in terms of what temperature does.
Another point too, if you're building a building, talking about power, make sure you have enough power to run the building, because it takes a lot of power to run these things. You can't be way off, and make sure you talk to your power guys before you get too carried away, especially on a refrigerated building. It costs a lot of money to bring power across the highway. I know that.
Hi, everybody. Welcome back. Hope everyone had a nice break. So that first video was more about the buildings and the HVAC. This next video really goes into the preparation needed for the colonies before going into winter storage.
Beekeepers that are used to keeping their bees outdoors, say in California or Texas all winter, have an opportunity to feed bees that are too light for winter. They have opportunities to fix queenless issues. But if the beekeeper is storing indoors, they have to do all that work ahead of time, right? So there's no chances to fix colonies that are too light in October or fix queen issues. So the colonies need to be heavy, they need to be well fed, the mites need to be under control months before they arrive in the storage.
My operation, shipping bees to almonds, begins in October in North Dakota. And as soon as the temperatures are in the 50s and lower in the daytime, we start gathering up the hives and shipping them to Idaho, where they'll be prepared to go into our cold storage facility. And in those preparations, we'll do last-minute feeding, and we'll do culling of weak and dead colonies so that we have just good live colonies going into the sheds.
These are some bees we just brought in from North Dakota. They arrived last night. We're just kind of doing one quick pass through them, giving them one last mite treatment, pulling out anything that's bad that they may have missed or went bad since they last looked at them in North Dakota. These particular bees have been fed 4 to 6 times, I'm not exactly sure, with syrup and protein patties. Been treated for mites starting into August. Treated up, got them clean. We're doing one last mite treatment on them, and then just basically going through anything that's lights, getting in one last feeding. Right now it's cold and cloudy. It's supposed to be 60 and sunny here anytime, so they should take that last gallon of syrup. But these bees are basically ready to put away. It's just making one quick pass through them to finalize and make sure they're good, and these will go get put away in a couple weeks. These will probably be the last bees that we put in storage. They're the first bees out of North Dakota.
We put the bees in storage for 2 reasons. The first reason is to get them out of the winter, out of the cold weather, keep the hive as large as we can, as many bees in the colony as we can, because we want to take them to California this time of year and set them out for almond pollination. We want the hives to be as large as possible when they do that. It's kind of against nature to have a large hive of bees this time of year, but that's what the almond growers need in California. They need large hives of bees to pollinate when those trees start to bloom the 1st of February. And so that is the first reason why we put them into storage. The second reason is that we can control how much feed they consume. If we keep them at the optimal temperature, we're able to reduce the amount of feed that they consume, and thereby saves us some money and keeps them from starving to death during the winter.
They're breaking everything in half right there. If they see something that's a problem or whatever, they're going to pull that in. They're feeding the light ones, so if that box isn't really, really heavy, they're going to feed it. So to give it an extra gallon of syrup right at the end, kind of a last, make sure we kind of even them up. We predominantly feed the Pro Sweet, or that type of a blend, like a sucrose fructose blend. We don't see a huge problem with that. That's what this is. It usually does not ferment in the hive. So I mean, if they don't eat this, whatever we're putting in them now, I think they're going to eat it just fine. But if they don't consume it, it'll be fine when it gets to California. You do got to be careful. If you're feeding like a 1-to-1 sugar syrup, it could ferment over the winter. That could be a problem. Corn syrup that's been diluted too much could create a problem. It also has honeybee healthy in it. The last round we always feed around to honeybee healthy. I think that kind of maintains the integrity of the syrup if they don't get it ate, so you're fine there. Protein, this is NutriBee. I'll give him a plug, he'll like that. Usually whatever they don't eat, whatever's in there, as soon as they hit the ground in California, they go crazy for it. They're not really brooding now. It's kind of slowed up for the season, but we haven't seen a huge problem with having like a half a pound left over going through. As soon as they hit the ground, if you crack them open, you'll see it in there. You come back in 4 or 5 days, it's gone. They just really go crazy for that protein when they start brooding heavy right there.
Unfortunately, the Varroa survive in the cold weather as well. We try to get good control before the bees go into storage in the fall. I think we achieve as good a control as we're able to with the tools that we have at our disposal at this time. But we still have loss from Varroa. I would estimate that most of the loss that we experience in winter storage is due to Varroa or the viruses that the Varroa have vectored into the hives.
Varroa, we've hit them pretty hard, aggressively for Varroa starting in August. This last deal we're putting on them right now is kind of a final cleanup with oxalic. The idea is they're not broodless. We wait as long as we can in the fall to give them that, because the oxalic only kills the Varroa on the bee, but it's kind of a last treatment. We also will hit them about a week after they hit the ground in California. We'll hit them again with oxalic to try to, because we can't really get them when they're broodless. They're actually broodless when they're in the building. And then Nosema, boy, that's a lot. That one, I'll touch lightly on it. We've had some really, really high Nosema counts on some really, really good hives of bees. I guess my take on Nosema is if your bees are really, really healthy and really well fed and don't have any other problems, they seem to be able to handle a considerable amount of Nosema. We haven't used Fumidel for several years. It's probably been 5 or 6. Whenever they took it off the market there for a while, we kind of had to quit using it and we never went back to it. We'll see. Come January, maybe it'll bite me. Requeening, we do all that in the spring. We start in basically April, May, June. little bit into July, but we try to get everything requeened. Brood wise, I would guess, I don't know, I'd have to go look at them to see what they have for brood coming out of North Dakota, but I mean, they're probably 3 to 4 frames still, pretty good size frames of brood going in. I don't know if that's ideal or not, but we kind of pulled the pollen sub away mid-October, kind of felt like we'd raised enough bees and kind of try to slow them up a little bit, or they kind of slow up on their own. As soon as it starts getting cold, they just kind of quit, but it's kind of damned if you do, damned if you don't. You know, you want them broodless so you can get rid of some of the mites and they winter better, but then, you know, that maybe 1 or 2 more frames of brood wouldn't be a bad thing to make sure that we get to where we want to be 1st of February.
Pollinating almonds is not a January and February job. It's a year-round job. We start planning for 2021 pollination in 2019. And so we're preparing for the shipping and the receiving and all of the intricate details of managing those hives more than a year out in order to be able to do it effectively.
Ideally, I pretty much want to see them pretty full of bees. I mean, with a solid box of honey on them. Ideally, if you had two frames of honey in the deep and a solid box of honey and 12 frames. I mean, I think these will max at 14 is what they can, they're a deep and a medium, so they can max out at 14 frames. I mean, I don't know if I want them. Well, when I hit the ground in California, I kind of like to see them fuzzed over. It's just a lot easier if they're better. It just makes my life a lot simpler if they're all really good. Then what we generally see is, this is what I'm gonna see the 1st of February when I unload these in California. I mean, I'm not gonna say, to say that they're all gonna be perfect, no, there'll be 1 or 2. We'll lose another, 5 or 10 out of this load for sure. Just, they might smash a queen today, who knows. But that's basically what I want to put in the almonds, and that's what I'll put in the almonds. What I have here is what's gonna go in the almonds. We have 456 hives here, 1 semi-load. We're bringing about 20 trucks from North Dakota. That's of our own. We store about 80 loads total. Most of the lesser hives have been culled out of these back a month ago. I mean, there's always, no matter what we do, these guys are going to go through these, and I guarantee it, we'll haul them to California. There'll be a couple more show up, but it should be a really small percentage. There's no advantage to me of hauling a bunch of poor hives to California and trying to rent them. And then the other thing is we have time in the wintertime to get that equipment cleaned up and ready to go. And then the other thing is kind of peace of mind. If I know that I got my bees are all shined up and ready to go, I'm going to put them in there, I'm going to get a paycheck on those, and I know I've got X amount to make up. We don't have a very bad winter loss, but our summer loss can be pretty extreme. I mean, we've culled aggressively to get to here. And so, we usually figure from what we say put into a honey flow on the 1st of June to what I rent in the almonds is probably 25% loss, but we're only losing about 5 to 10% over the winter. Basically, if those rent, they're gonna make me $220. If they don't rent, they're gonna cost me $300. That's kind of how we look at it. In my mind, when these guys get done, I'm gonna rent 95% of these. So if I was just gonna say, well, I think we're gonna rent 70%. We might rent 80%. We hope we rent 90%, but I'm pretty confident we're gonna rent 90+% of these. And so I kind of can make a plan to go, I can feel comfortable. We're going to hold back 10% to make sure we cover our butts a little bit and make sure that we don't short somebody. But I really don't want to be thinking, well, I don't know, it could be 60, 70% will rent and the other 30 or 40% might, and 30% of them, it's just not, we're not going to make any money doing that. An indoor storage is not going to fix your bees. It's just going to maintain a good hive of bees so that I can put these bees away in 2-3 weeks and pull them out just like that. That's what I want to put in the almonds. That is a pollinating unit. We can't really get them any better than that. And so, but basically what I'm going to use the indoor storage for is to maintain that. I'm not going to go in there and build bees in the storage. It's just a place to put them. I know if I put them in there, they're going to come out looking like that.
All right. So That closes the video portions of today. I'm going to hand things over to Danielle, who is going to run our panel. Danielle, are you ready?
Ma'am, I think Kelly was going to try to get our panelists so that we can see them. And in the meantime, I will introduce the panelists. So some of them are familiar faces. Gloria is joining us again for the panel. Brandon Hopkins, who's also a researcher at Washington State University and studying more of the practice and how this stuff looks on the ground, whereas Gloria's looking more inside the hive and at the individual bees. So we have 2 researchers, and then we have 3 beekeepers who are successfully using these practices in their operations. We have Buzz Landon, who's in Northern California, and Bryan Ashurst, who is in Southern California. So a lot of this, we've talked about the climate and how that makes a difference in all of the choices that you're making and how successful and how you use it. And then we also have Nick, who's been the star of the videos and did a great job on that. Thank you, Nick, for the tour of your facilities. That was a pretty intensive film shoot, and you did a great job. So thank you. So first, I would like to, we have over an hour for this panel. So I think it's worth each of you introducing yourselves and talking about your business so that we know what business model you're working in. And tell us how you use bee storage and how that relates to kind of where you're located and what you've learned. So let's start with Bryan, just because we haven't heard from you yet, and you are in Southern California.
Yeah, so based in Southern California, way down south, down by the border. So our business is mostly pollination. We do that primarily here. We do run bees in Montana also. So we have that as a for the honey making side of things. Our operation down here, though, it's hot. It's really hot here. We have to shade all our bees. So we looked at cold storage as a way to actually work bees and keep things going. It's nothing in the summers. It gets 120 degrees, and so it's hard on help, and it slows things down. So we use the cold storage a lot for bringing bees in, doing work with them. You have a controlled environment. It's better for your health. We can store bees in there if we need to. We don't hold for winter. We just do a brood break and to pull our honey, make divides and all that in our cold storage. So that's kind of how we do it. But yeah, so right now I'm done with my cold storage for this time of year. Everything's empty. All the bees are in the field. So we're having to feed and all that because our bees fly every single day. And the cost to keep that room cold would be prohibitive. We can't mix outside air. It's still warm here. Like today, it's going to be in the 80s. So it's still warm here. So we're all complete refrigeration when we do it. Anyway, that's kind of how we run our operation.
Thanks, Bryan. That's really different than how most people are using cold storage. I'm sure we're going to have a lot more questions about that. Let's go to Buzz, who's in Northern California. Welcome, Buzz.
Yes, good afternoon or morning. I'm up in Northern California, up by Orville, and I'm a pollination guy. Also raise queens and sell packages and nukes, raise nukes for sale. And then I also run out to Wyoming for honey in the summertime. So we've gone to utilizing the building. I do overwinter in the building. This is my second year starting in it, and things are moving along. Always trying to figure new things out about how people are doing stuff. And I've also used the building in a lot of other ways. It's been interesting. You know, I knew I'd use it for making up the mating nukes, but I didn't realize how much this last spring I overwintered the hives for the almonds, and then come March, when I started to make up the mating nukes, the building ran all the way till June, just in the different operations that I was doing. Everything from making up my own increase, dumping packages in there, to shipping bees out to go out of state to make the timing work right on the trucks. It really has made the work crew a lot happier because they're not out late at night loading trucks to head out of state. Now it's just me. I typically do it during the day, and they're out working in the field preparing for the next load. And I load them up about 2 o'clock in the afternoon, and that works out timing wise for them to leave my place to where they're going. So that's been beneficial. We also store the packages and nukes in there when people are coming to deliver. So that helps when they're coming timing wise. It's not some weird hours. And everybody likes to go home and sleep at night. So it's been beneficial.
Great, thank you. Nick, we've heard a lot about your operation, but if you want to just recap it for the crowd, that would be great.
Can you hear me? Are we good?
Yep.
Okay, good. Yeah. Basically, we run bees, start out in the buildings in January, go to California with everything, ship 2/3 of them to Texas after California, the other third back to Idaho. We use the building in Idaho to dump packages in, use it to ship bees to North Dakota in the spring or Montana. Basically, then produce honey in Texas and North Dakota, a little bit in Montana and Idaho and Oregon. But basically, predominantly just use it for winter storage is all we're using the buildings for, other than a little bit of trucking, being able to get the trucks to arrive on time without the truck drivers having to drive all night. Basically what we do. Almonds are the only thing we pollinate.
All right, great, thank you. Brandon, will you tell us a little bit about your focus of your research and the interesting questions that you think are happening right now?
Yeah, sure. The focus of our research with indoor storage has been looking at sort of these different ways to use the storage. A lot of that generated by folks like Bryan and Buzz and Nick, using the indoor storages at times other than winter. So the potential to use them to cause a brood break for Varroa control. We just completed a project working on storing or banking queens indoors during the hot summer months, and using the potential for carbon dioxide buildup in these buildings, both for Varroa control and looking a little bit at whether or not the bees do better sort of on a physiological, nutritional level with higher levels of CO2 in the buildings.
Great, thank you. I think we're going to have more questions about the potential for mite control too with buildings during this panel. And to you, Gloria, say a few words about your research.
Well, I gave a long talk, so you kind of get the idea of where I am with, I think cold storage, like I said, I'm so glad we're having this conference because, I think moving forward, it's going to become a necessity to a lot of beekeepers to successfully overwinter their colonies. Listening to Buzz and Bryan and Nick, it's so creative how you're using these facilities in other ways as well. So thank you for that. I'm really learning a lot. I knew I would, being at this conference, yeah, I think my ideal situation for a colony is that they go into a cold storage facility in October, and that we get plants on the landscape, fall flowers with the nutrients that they need to overwinter. And they're going into those facilities with fat bodies with enough lipid and protein and such in them, but also be bred in those colonies. And they're not burning it up because those plants are blooming too early, and the bees are using those resources before they go into winter. So I think another area of research that we're interested in our lab is the whole nutrition side of this, and to find plants to improve that timing for getting real pollen into those colonies to overwinter.
Great, thank you. All right, so I think what I'm going to invite the panelists to do is, if you have interesting questions for each other, feel free to kind of wave and unmute yourself and ask. I think some of that discussion could be interesting. We've got questions coming in from the chat, and if somebody would like to unmute themselves to ask a question, that's we can probably work with that too. First question that we've got coming in is, Buzz, Nick, and Bryan, have you tried to use the indoor storage for brood break after almonds for varroa control?
I'll go ahead and take it. I have not after almonds. After almonds, I want to start making splits and getting my, my next crop of bees ready to go. So not after almonds. Before almonds, yes. We do that in, well, starting in July, really, but let's just say August, September, but not after almonds.
I have not used it either. We were just too busy doing the package and nuke production at that time to really put hives in there for a specific brood break.
Yeah, we have used it. We did it in April a couple years ago. Did get them to go pretty much broodless. We were trying to do two things. One, to get them mites under control, but the main thing was to keep them from swarming. We had some bees that were getting ahead of us. It worked pretty good. I wished I would have put them in a little sooner. We were probably a little too late getting them in. We should have put them in before they got as big as they did, but we did get them to go pretty much broodless. I think Brandon did some studies on some of that stuff. He can probably give you the numbers.
Yeah, and I think I'll be sharing some of that stuff in my talk tomorrow morning. But again, I mean, I think that was an area that was really driven by the beekeepers, and I think a really creative use of these buildings. And it's something that, the timing really has to be worked out. And again, it's so regional and dependent on where the bees are coming from and what you want to do with them. It makes it really specific to each operation as far as whether that's really an option for you. We also tried it with some folks, not because they did apple pollination, they couldn't do that sort of brood break or go indoors after almonds, but they wanted to try to go indoors after tree fruit pollination in Washington, because there was a period of about 3 weeks between the end of tree fruit pollination and the shipment of those trucks out to North Dakota for honey production. So there's a few different times where that could be an option, and I think some of those fine details still have to be worked out as far as that potential for varroa control.
So you'll be talking more about that, Brandon, but I recall some of your research thought the sweet amount of time was 18 days. Is that right?
I think, yeah, it seemed to be about 18 to 21 days is sort of a sweet spot, especially like what Nick was saying, in order to take that swarming behavior out of them, to really get them to not produce swarm cells. Because with Nick, we had sets of colonies in there that were for 12, 14, and 21 days that were taking out those different time points. And then we came back and looked at them to see, how many swarm cells they made, how many of them swarmed after that period of time. And so the bees at 12 and 14 days still produced I think it was, I'll have the information tomorrow, but around 30% of those colonies still produced swarm cells or tried to swarm even after that period of indoor storage. But at 18 days, none of the colonies produced swarm cells, right? It knocked them back enough so that they did not attempt to swarm.
Does that stick with the same temperature, Brandon, of 40 degrees or so?
Yeah, that was 40 degrees, or 40 to 45.
We have a question about, how do you know how much honey and food to have on a colony when you put it in a building? How do you decide that?
We just try to get them as full as possible. We like them about 105 pounds for a 1.5, 110, 115 for a double. Heavier is better.
I'd agree with that. Obviously, I'm not holding them as long as they are, but just to do our 18 to 21 day brood break, we sort the hives, because good bees in, good bees out, which has been said today. Even in a short term, you're gonna you're going to put poor colonies under pressure. So you might as well not even bother putting them in there. So we filter everything out before it goes into the room. And we only put the good bees in there, and that includes the weight. We check everything for weight. And, you know, they're just decent weight, 100 pounds maybe on a deep and a shallow. But you just, because you want them shutting down and really doing nothing. And then if they do that, they'll come out with decent weight still. But as soon as they come out, we start feeding them again to not only stimulate, but to also put on any weight that was lost in that 3-week period.
Yeah, that's a good point. I do think for Bryan, they probably consume a little bit more food maybe than the bees in the north, just because those bees have gotten ready, you know, they're ready for winter and they're shutting down the brood production. I just know that the stuff we've done with the brood breaks, they consume a lot more food than, you know, on a weekly basis than the bees that go in October and November for winter. And I can't remember, you know, I think people have come up with different numbers, and Nick, you might know, but a pound a week or something, is that what they consume?
That's a rough idea. 1 pound a week. A bigger hive could consume more. The other thing to think about too is I like them to be a little heavy going in the almonds. We put them directly in. If we get a week or 2 weeks, we can't get back to them because it's muddy. I don't want them starving to death. That's a sad, sad day when you see a 12, 14 frame hive starved to death. That's your fault, not mites, not anything else.
All right, we have a general question. As a beekeeper in Wisconsin that doesn't ship to California, when is the best time to put hives in storage?
If I could jump in with that, if you know your bees and you know when your queen stops laying, and they, you know, you just have sealed brood in your colony, whenever that might be, that's when I would put them in cold storage. And if you don't pollinate almonds or anything, I'd think about taking them out when the hardwoods bloom.
I think that's one of the, you know, great things that Gloria is doing in her lab. So you kind of think there's really no, once there's no forage for the bees, there's almost no point in them being outdoors with the, you know, temperatures going up and down and then being rained on. And, you know, people have seen bees where they get a warm day and then really cold nights, and they, you know, that cluster gets off the food and you can lose colony, you know. So there's lots of things that can kind of go sideways being outdoors when there's no forage and the bees are flying for no purpose. So I think that's great. This stuff, you know, Gloria's been doing, showing that bees do better kind of the earlier they go in. So
George asked Brandon, what's the realistic mite drop from CO2 in a building over and above regular mite level drop over winter?
So the kind of the best we've seen is about 75% sort of mortality. So 70 to 77%. Compared to a natural mite fall over that period of time of the 60 or 70 days that they're in storage is around 45% of the mites kind of just are dying naturally. And so, you know, and I'll cover this a little bit tomorrow too, but the thing to consider is that, again, these storages are never going to be a hospital. You know, this was a interesting idea and really driven by some work out of Canada from Rob Curry's lab, showing that the mites were more susceptible to high levels of CO2 compared to the bees. But even if let's just say we figured out the most optimal conditions for CO2 and could kill 100% of the varroa mites, you have to consider that it's really too late to be using that as an option for controlling mites, right? Like, all the work Gloria talked about today is those mite populations really need to be cleaned up by the end of August. So I think it's a good option for, you know, there's always going to be a few mites, and every chance we get to kill mites is great. But yeah, I think that we could kill some and come out of storage a little cleaner is great, so that when we go set bees in these large staging areas in California, they're not spreading additional mites around. It's good, but It's certainly not gonna, it's not gonna prevent mites from doing damage because it's already have a high level of mites, to try to kill them indoors. But, it's a way of rotating compounds and killing mites maybe that whatever chemical treatments missed in August. So I think it still has some potential. It's not going to fix it though.
Anybody else want to comment on mites in your practices with the buildings?
I would like to hear from someone else. I will just say, in case I forget, is that I do think an area of interest with the CO2, I mean, we've been a little bit focused on varroa mites because they are such a problem, but it might turn out that letting the CO2 go up a little bit in these buildings might actually have other benefits other than, killing varroa mites, which is the, maybe the bees are a little bit more metabolically efficient, consuming less honey. It seems like there's some preliminary data showing maybe the bees are coming out a little bit healthier in the terms of fat stores or protein. So there is that potential as well. And the potential for greater efficiencies in the buildings if you're not having to vent out your very costly refrigerated air just to get the CO2 levels down. So I think there are some folks that are allowing those CO2 levels to rise a little bit higher than they have in the past.
Yeah, I will say that we don't worry about the CO2. We have CO2 monitors and they've never gone off, but I know it's high in there. You can smell it when you walk in there. The ambient temperature in the room, well, the temperature is good, but the air quality is starting to deteriorate. It's like we're below sea level here. But it is like you're at 7,000 feet when you measure the air, what is it? Not quality, but the air measurement. We take a tool in there and checked it. And once it hits that 7,000 feet measurement, it holds right there. We don't seem to have a problem. But yeah, you can't really breathe very good when you're in there because the air quality is being pulled out and being hampered with. Bees seem to do fine with it though. They never seem to show any kind of issues with that. And again, the CO2 monitors have never gone off, so it's never got into dangerous levels, but we know it's up.
Buzz, Sue is asking if you can comment on using cold storage to introduce queens, II queens and summer dearth.
Yeah, I've been utilizing that also. When we did some II queens, we put the startup colonies in there and introduced those, kept them nice and calm and quiet, and didn't have to worry about the other nuisances outside in the summertime out here when it's hot and dry and bees can get robby, and that just really helped with the introduction of those queens. And it really helps making up increase too. We've done packages, we've done other ways, making up divides. Bryan obviously is doing that, I think, all the time in his building, and it's it's really hot outside. It's even hotter down where Bryan is, but the crew does sometimes not like to work in the building because it is kind of cool and it's generally dark and such. But they do admit it is nicer to get it done in there than outside and worry about all the problems.
So can you talk a little bit more about that advantage? I mean, why do you want to shake packages or make those divides in the building rather than outside? I mean, I know it's hot, but what does it do for the bees or the quality of your?
Well, if we're shaking packages or dumping the packages in there, we can do that right in the middle of the day versus, you're always waiting until sundown. Well, you have so much work going on. You're never stopping your work during the daylight hours, but now you're up at night dumping these bees, trying to get it done. You have the drift factor. These bees, they tend not to drift because they've honed in on that pheromone on that queen. They're just more relaxed. We can take care of the feeding, all that stuff in there, and then we just stack them up. And a couple days later, we just haul them out to the location and let them fly early in the morning, almost like what we do for making up our mating nukes.
Yeah, I find it very advantageous doing that. We make the package. Basically, we have a room that holds the parents. We bring that out into a screened in room. Our work, most of it is in a screened in room. So the bees aren't just tearing up everybody around the warehouse or town here. But the bees are pulled up into the top super. We smoke them up, through a cleaning scooter, pull the bees off, blow them in or shake them into shaker boxes. That shaker box is put into another, now it's going into the cold room. And inside there, we have these pre-measured rings. The queen's already placed into the hive body, the new starter hive. Pour the bees out, fill that ring up. That ring is how many pounds of bees we want in there. Lids put back on, put into a colder room now, and it's held there for 2 days before it's trucked out and placed. And just like Buzz said, they're used to the queen. You're not worried about drift is bad. Drift went way down when we did that. And again, we don't have crews working night and day. Everybody does everything in the daytime. Everything's here at the shop. Everything's is controlled. We get more done because we're not driving around from place to place. In our operation, the most important guys are your truck drivers because they're the ones that are doing all the movements. So they're bringing in the parents at night and switching out with the new package hive, the new hive to start. And then the old parent hive has to be pulled out. So you have another truck pulling those out. So it's kind of a little bit of a dance, but you can knock out so much faster by this controlled environment.
So Bryan, that kind of raises a question that's come up in a few different ways and about the economics. So it's a very dynamic tool. You guys are all using it a different way in very different conditions. How do you see it in your mind about the advantages and disadvantages, and also where you're hitting that profitability mark? I mean, Bryan, it sounds like some of your benefits are keeping people happy, not just like preserving bees. And so if each one of you could talk about how you see the economics and where the tipping points are and just how you've made this decision in your own operation, that would be great.
Well, when we started, the original plan was just for making up our spring packages. And that was where it started. And now the room is used almost all year because we found, back to the economics of when the guys get here in the morning, there's no truck to load. It's walk out there and start working. So you immediately are getting started on your workload. You're also controlling your break times and all that, which is an economic advantage to me, but it's also a comfort for the help because they have these preset times and nobody's deciding, hey, should we stop at after the next stop? It's just everything's under that controlled environment. Then with that, you on the economic side of it is when they would do work in the field, let's just say they could get, on supering when we bring because I'll bring this packaged colony hive bodies, a full single, back to the coal room to super it even. Instead of hauling all our supers 100 miles away to the coast where we have these things, we just bring that operation here, the bees here, and they stay now in the Imperial Valley. They got to come here anyway. So they'll go through that. And when we did that in the field, you can get 600-700 done a day. Through the coal room, we can do like 1,400 a day. So you can just knock it out so much faster. So we're not even having to work as much as we used to because we can do so much during the week. You're not having to worry so much about Saturday work. And if California, with our overtime rules and all that, trying to eliminate some of that actually saves money. California is a unique deal because our labor laws are so restrictive that you have to think of that as in your economics of it. So for me and us here, it is getting more done, more accomplished, and that's how it works. Other uses for the room, like I said, have come up all year long. One is the brid break. One is like Buzz mentioned, we load all our trucks now outside the room because it's not big enough to put in, to load inside because they're chambered rooms. But we'll load it outside, trucks pulled in, the trailers pulled in, trailers dropped. I don't have to have a crew come in the evening after working all day. Hey, we got to tie trucks tonight. No, the guys that work at the warehouse, they'll tie it in the morning. And then in the evening, as soon as the light goes down, big truck backs in, hooks up to it, and is on the road. So it just sped everything up, and that's how you're saving money. The room has saved us money. It's expensive to build, but once in time, it'll save you money.
And Bryan, just on that note, how big is your building?
We have three 25 by 50 rooms, because we're chambered rooms. 3 25 by 50, and then attached to that is a 30 by, I guess it'd be 30 by 80, and then our screened in room is another 50 by 50, actually, no, 50 by 80. So the whole facility itself is like, 112,000 square feet or something like that.
And Nick, how does that compare to what we saw in the video?
As far as the size of the buildings, or
Yeah.
the building, we've got the big one's 100 by 150. The refrigerated one's 100 by 100, and then our original building 75 by 100 feet. So they're 7,500, 15,000 square feet, 10,000 square feet. But we don't do a whole lot of bee work in them. We still do most of our bee work outside, but we do dump packages indoors if we're shaking packages, and that's about it. Everything else we're still doing outside.
And what are the economic triggers for you when you think, is it external temperatures that you think about that costing more money to use the buildings, or how is your economic equation?
As far as, I guess I'm not quite sure. Why don't we use it more for working bees? Is that the question? Or?
No, I'm just wondering, when you think about investing in the building, where do you win and where do you lose throughout a year with all the dynamic things that happen?
I mean, the original building we built was for our own bees, to store our own bees only in the wintertime, and that was it. And the economics was so we didn't have to, well, we've done it several different ways, but we either had to go to California. Nobody wanted to go to California all winter long. They all like to be home for the holidays and get a little break. And then if we left them outside in Idaho, you could get snowed in, mudded in, couldn't get to them. It was a huge problem. The woodenware, I don't know if anybody's touched on that. Like we're probably gaining a couple of years on our pallets, boxes, and lids by storing them indoors in the wintertime, because if they come out drier than they go in. As far as economics go, that would be the less travel, better bees. That's the main economics. We're trying to rent a lot of bees in the almonds, big hives of bees in the almonds. And then I guess that'd be about it for economics.
Is anything to add?
Yeah, I think when I was figuring out whether I wanted to put up a building or not, I went through some of those economics of between the woodenware, the health of the hives, the strength of the hives, the number of colonies, the savings in feed. You added that up, and it paid for the building. In a quicker notion than what I thought it would. So doing all these other things, I feel like I've hit a little gold mine of utilization for that. And it's made life easier for me and the crew, just logistics. And as California is making, like Bryan talked about, making things more difficult for labor laws, it's helped. And it keeps the crew happy too, and we don't have to worry about rainy days out in the field when we get rained in often here in Northern California. So it's beneficial for that.
You get less trucks stuck.
Yeah, less trucks getting stuck. Less time sitting in the cab waiting. Oh, this storm's going to blow over in a little bit. You just get and it's just more efficient because all that stuff's just right there. The hives are stacked in a line where you'd never have that in a yard, because you'd have a whole bunch of other situations that would be bad, but everything's just lined up and can go at it.
Gloria, a question for you. Your mite infestation.
Oh, excuse me. I'm sorry, Jay. I just wanted to follow up on what Buzz and Bryan and Nick were saying, and about your question that a beekeeper that we worked with, who had his bees down in Texas, was talking about the savings in not having to worry about fire ants and cleaning pallets. He would normally, if he wintered in Texas, take those bees off of the pallets, put them on clean pallets, and then put them in the trucks. Either that or have to power wash all of the pallets. And when he, took them right from North Dakota and put them in cold storage, he didn't have to spend any money doing that anymore. I'm sorry, I didn't mean to interrupt you. Excuse me.
No worries. We have plenty of time. So George wanted to know about your mite infestation graphs that peaked in November. Is that in Arizona, and northern areas would be earlier?
Yeah, those were in Tucson, Arizona, and I think that the mites, because we still have bees flying in November, and actually they're still flying to a degree in December. When I looked at, I was telling you I was looking at the weather in Baldwin, North Dakota. Boy, once November hit, flight was over, and so there's no more bees flying, so there's no more mites migrating around colonies. So I think they would, in places like that, they would. The peaks would come sometime in October. I think they're really driven by how long flight weather goes
on. We have a technical question, and it came up during the video, Nick, so you might have to answer it, or if you don't, it could be asked to Anthony tomorrow. Is 18 watts per hive the heat output while they're at 40 degrees, or is that the max output during the drawdown period?
That would be a great question for Anthony tomorrow. I have no idea. Probably depends on if they're mad or not. I don't know. I don't know. Anthony could answer that.
Okay, good for tomorrow.
Yeah.
So I guess I'm going to open it up now a little bit for you guys to think about the people. We've got nearly 100 people here who probably would love to hear your advice. They'd love to hear your biggest hopes for indoor storage and what your prospects are. Maybe if you have a good story about your biggest mistake. Anybody want to share some advice or some high level thoughts as people consider this? Another thing I want to ask tomorrow, and if you have any ideas about this, is how big and how small does this scale? You guys all thought about your own operations for your buildings, but can a smaller beekeeper make a go of this? Or I think Tenny has some really huge buildings that we'll see in those videos. Can they get bigger than that? So anything top of mind for any of you?
If you're a small guy, we first experimented with just reefer vans. So you could always go that route if you're small. I get an electric cooler. I wouldn't want to have to go out and put diesel in all the time, but you could always start with a reefer van and see how you like it and see if that works for you before you invest in a building. Building's a lot easier. I will say that though.
And I will say, in that indoor storage guide that we have on Project EPSM's website, the folks at Hive Tech Solutions have sort of these modular containers that are like the size of a refrigerated cargo van. That could be an option for these smaller sort of things, and they're kind of set up for that. I mean, Danielle mentioned something about big mistakes. I mean, we've been trying to use these refrigerated cargo containers for these smaller experiment. I mean, these bigger than incubator, but not 5,000 colonies in a room, and they're not quite designed for that. I mean, they have these big blast chiller fans. It's not exactly set up properly for bees necessarily right out of the box, and so we have to kind of build our own sort of air diversion stuff. It's kind of loud in there. I think it's not necessarily ideal for bees. What we have set up as far as a refrigerated cargo container, it's a little tough to deal with, whereas the Hive Solutions modular, so it's in the chat there. Hive Tech Solutions have options for these smaller sort of containers.
I don't know. We have Hive Tech here, like Brandon was saying. I don't know. Would it be okay if they said something and filled us in a little bit about the modular storage units? Do we have time for that?
Sure, we do have time. I think there's also a lot of smaller beekeepers on here who would be interested to hear that. So if
Kim wants to jump on here.
Yeah.
Oh, hey, everybody. Yeah, thank you for bringing us up in this. We've been working with Brandon and Gloria and just been fascinated by the work they're doing. We've got modular options that go for small commercial beekeepers. They run from about 16 colonies up to 98. And so we've designed them specifically for the heat output, for the carbon dioxide output. They're monitored and we can deliver them on site. So we're looking at being a part there. Great. Being a part of the solution for small scale commercial keepers.
Yeah, thanks. Yeah, and like I said, yeah, they're sort of quieter, and that the ability to monitor and the alerts and stuff is really important. So I mean, with the cargo containers that we have, we've had some problems with that. And I was going to mention, you know, the major mistakes. I mean, or things that can happen. And this came up, I think in that video Anthony talked about the redundancies in the systems and the backups, and backup generators and all that stuff is super important. And this ability to monitor allows you to sleep better at night, remotely monitoring it. So I've had to go out to the cargo containers at like 1 a.m. in the morning, to check the conditions, to find out that they're really okay, but the monitoring systems were incorrect. Power outages where I had to call a local beekeeper to like race out there and open the doors on the container because we did not have backup power systems. And having, and I think Anthony or one of the other videos will talk about this a little bit, but whoever you kind of are working with, you need that sort of support system, so you need to have a technician close by that understands the system and can troubleshoot things when they go wrong, because something's going to happen, whether it's a power outage, a fan failure, a condenser, air conditioning failure, something will go wrong, and you need somebody locally nearby, so that can get there to fix it.
So Kim, I think that was your slide. Is that thing, I don't see an extension cord. Does it plug in or is it freestanding?
Yeah, there actually is an extension cord. It runs off of a 110, but yeah, it goes out towards shore power. We are working on an option that's got solar embedded in it, and also one that's got a backup generator. So we do have a gas powered backup generator as an option. Yeah, because that does happen. We've had to deal with power outages and then equipment failures. So we monitor all that with a data combination. One thing that I'll bring up about it is that, so much is the regional variation about when bees go in and when you take them out. So what we're really working on is letting the beekeeper decide when that happens in terms of, when does your queen go, stop laying, and then what's the forage in the area. So we're really trying to meet the regional differences across the US and maybe out in holding yards as well.
That's great. I'm glad you were here and able to talk about that. I think there's probably a lot of interest in that in this crowd.
Oh,
we do
thanks for the time.
We have a question. Do any of you rent space to other beekeepers?
I do not.
I do, but we're full.
I've leased out a little bit of space to some other beekeepers.
Gloria, do you think pollen subs are sufficient to prepare bees for storage, or do they need field collected pollen?
Well, the gold standard, of course, is field collected pollen, particularly fall pollens. We've done a lot of research on seasonal nutritional needs of honeybee colonies, and the nutrients that are available in seasonal pollens really seem to match where the colony is in terms of its yearly cycle. For example, those spring pollens have amino acid and fatty acid compositions that are supportive of brood rearing, while the fall pollens have amino acids and fatty acids that support overwintering in terms of amino acids that can shuttle nutrients from the fat body into the hemolymph. They encourage hypopharyngeal gland growth when that queen starts to lay. So if you can mix seasonal pollens in with your protein supplement, mix in fall pollens, I think that's a real plus. But if you have natural pollen where the bees are collecting it and bringing it in, I think that's the gold standard.
Tim asks, say he's describing a scenario, if you go into storage mid-October and there's brood present, how much refrigeration is required? And is it difficult to keep temps at 40 if you have brood present?
So, okay, I'll speak to that. Even though I don't hold them, ours are full of brood when they go in because we're trying to stop them from doing that. So I figure it's 30 to 36 colonies per horsepower or ton. Again, we're fighting pretty hot weather outside. But that's kind of how I figure it out. Because if you overpower, you put too many bees in there, they're going to overpower the horsepower you have. The whole idea for me is overcome them. So put as much horsepower into the room as you can and that you can afford and manage, because you want to break them. The bees will fight that cold weather as long as they can. Maybe that's more with the brood thing, I don't know, but they will fight that cold weather as long as they can. And so you got to make them finally give up and say, okay, it's cold, we're just going to hunker down. And once you get them to there, then you can actually maintain that 40 degrees pretty easy. So we're constantly fighting that because our doors are opening and shutting all the time because we're bringing bees in and out so much. So yeah, we overpower the rooms to overcome the bees. And yeah, so for like a 25 by 50 room, I think I've got 26 horsepower in one. One's got 30. So yeah, we're trying to put a lot of tonnage of air in there to keep them down. And I will say this, something else we deal with is our evaporators are inside the building. So you're constantly having to fight bees that get into the evaporator and plug up your lines. So we have them all screened in so that we try to keep the bees out. But you got to keep those lines clean. So every time we have a break, we take everything apart, clean everything back up before we start a whole new round of stuff, because bees will they find a way into everything and they'll plug up stuff. And so, yeah, that 1 a.m. Alarm going off isn't fun when you realize it's just your evaporator line is plugged up and now you got to go out there and climb on beehives to get to that thing. But it happens. So.
We got a great question from Doug about, does USDA have low interest loans available to build these things? Any comments on innovative financing?
I actually looked into that when I was building mine, but it came with a lot of complication and timelines that were kind of hard to get a project done if you wanted it done in the next couple of years. So I moved on from that, but there is a program available for that.
Okay, we'll see if we can find information on that program. I think that would be interesting. We'll see if we can dig it up for tomorrow. What is the maximum amount of time bees can be in storage?
I think that depends on how large the colony is, how much food they have when they go in there. I mean, bees can be confined, for example, in natural settings, from maybe the beginning of November, sometimes until the end of March. I know I kept bees in Michigan. They were under the snow for a good part of that, and we didn't really start to get flight weather till maybe early April. And so they were in cluster. We were still going down into, we were still in the 50s, going down into the 30s at night. So they can stay in there for 5 months at the most, 4 or 5 months, and they were fine. They had lots of brood when we opened them up because we fed them a lot before we put them in cold storage. I mean, before we put them in, put them to bed for the winter. They were outdoors, but yeah, I mean, you'd open them up, they'd have 2-3 frames of brood, sealed brood, whole deal.
And Gloria, if you keep them in there longer, do you need the temperatures to be cooler?
I don't know.
Sustain them longer? Okay.
I don't know if the 42 would. I mean, we've had some conversations about this at the lab about that, having that constant temperature, what a real plus that is in terms of the metabolic expenditure of the bees, that they maintain that homeostasis and they just have to expend energy to maintain it, as opposed to it getting colder and cluster getting tighter and then getting warmer and the cluster expanding. I mean, all that costs energy. And so without any data, just as an opinion, I think, keeping that temperature at 42, like folks have been talking about, is probably all you need to do.
We have a question about renting space to others. What does that arrangement look like? What is the cost and the liability? What does your contract say? Let's start with Nick on that.
Okay, cost, we charge $10 a hive for non-refrigerated, $15 for refrigerated. Liability, to my understanding from my insurance guy, says I can't insure your bees in my building, but you can insure your bees in my building. So I don't have any insurance on the bees. I have insurance obviously on the buildings. Contracts read that I will basically maintain the buildings at standard operating procedures, and basically we keep a backup generator on everything. So if there's a problem, we've got power for that. So I don't know if that answered all those questions or if there's any more questions. As far as basically the bees show up on your truck, your semi, they show up, my guys unload them, put them in the building. You send your truck back pretty much on a prearranged date, and we load them onto that truck and they go to California. I think that answers it all.
Yeah, anybody else?
I'm pretty much the same as Nick, but I'm dealing just with, last year I dealt with 2 people, now I'm just down to 1. So I'm not really out to lease, just work with a small select few.
Buzz and Bryan, what are the pros and cons of making new colonies inside storage?
Well, for me, it's speed. It's we can do it faster, and it's more. We do it all in the daytime. We don't have to go out at night to make packages or anything like that. So I think that's the biggest pro. The biggest con is probably, you got to truck everything in and truck it all back out, but you have to do your equipment too. So that's how I look at it. I'm sure there's a little more mortality because we are a little bit rougher, you could say, but are not enough to make us change because it's minimal. Yeah, I'm very happy with the setup. I don't know how to. For me, there's no cons. It's worked out so well. So that's how I see it. But yeah, it's a better controlled environment for your health, for your bees, and it creates uniformity in your system.
Yeah, I'd say it's just even more uniform in the bees themselves. You really iron that out, and yeah, we're making quite a few 5-frame nukes a day in there, putting the cells in, and then we're taking them out to their mating yards to get mated and going, and it's worked really nice for that. Otherwise you try to make up so many out in the yards and the bees are just going crazy, and you had a bunch of bees in the box, but these ones found a hole and they drifted out, and that was happening quite often. That stuff's all gone with making them inside.
Kim asks, she says, we get a lot of questions about whether or not cleansing flights are needed. Any comments on cleansing flights?
I like to see the bees right before they go in. If it's been really bad in North Dakota, we'll set them on the ground in Idaho for a week and let them do one last cleansing flight, especially if they've had some port, like the October was really good this year in North Dakota, but if it's been bad and rainy and cold and they haven't flown and we have feed in them or have fed them prior to the last time they flew, I like to set them on the ground and let them get one last cleansing flight before we put them away, if possible.
Yeah, I think that's something that could be looked into a little more. My opinion would be that, they probably need some cleansing flights, after they're done eating, say, the pollen supplement and things like that, right? 'Cause, there would be concerns about them needing to go to the bathroom after feeding on the pollen substitute versus natural pollen, probably. But I think the important thing is that they know that it's winter. So by October, as long as they've gone through some weeks of really cold weather, they go out and do their cleansing flights and they get ready for winter, before they go into storage. So they're ready to do that. And like Gloria said, in Canada, they keep them indoors for 4 or 5 months in some cases with no flight. So they seem to be able to hold it.
Yeah, I'd be curious too if we have any information about what viruses do in a building. George has his hand raised. Go ahead, George.
So I don't know what I'm seeing in California, but I've driven by some yards where trucks had been unloaded, and I know the beekeepers that have those yards had bees in buildings. And if the next day is a pretty nice day, a flight day, it looks to me like all holy hell is breaking loose, and that there must be some incredible drift going on. Is that, or is that me just driving by and not really asking enough questions?
No, I think, George, I think you're spot on. It's chaos. Everybody's trying to, all the bees are trying to reorient, like say they just, think about what we're doing. I'm trying to think like a bee here. They were just in the dark, and now, and it was cold, and now they're on a truck, and now they're dropped in the middle of an orchard, and it's warm enough for them to fly, and it's light, and they're trying to take cleansing flights like Kim was asking about, and they're all trying to orient, and it has to be, I would guess, a great shuffling match that goes on. Especially the hives are close together too.
And I think I'll let that Nick could probably speak on this a little bit too. But I think there needs to be a shift a little bit in how you do things if you're not used to doing indoor storage. So I think them coming off trucks and going straight into the orchard or in smaller staging yards when they come out is necessary, and spreading those pallets out more than you normally would has got to be a practice for folks that are doing indoor storage, because that drift is an issue, and it's kind of a known issue for a while that is a bigger problem straight out of storage. And so I think if you're going to move into that practice, you have to plan on changing your practices a little bit, coming off of those trucks, either spreading them out further or going straight into an orchard where you have smaller sets of hives rather than these large compact staging areas.
Gloria and Nick, just from your previous talk this morning, Gloria, about the bees when they're put in October, they had more brood coming out. Do you find that decreases the amount of drift happening when they have that brood there to help hold them, or is it still pretty crazy?
I don't know. I don't know about that. When buzz. That's always been. When you're making splits and you put brood in the splits to reduce the drift and have the queen in there. But I don't know when you drop them out of cold storage and put them in a holding yard, whether the amount of brood in there would slow that drifting down. I don't know.
My experience with holding yards and pulling bees out of a winter storage is pretty brutal, unless you like to see some really small hives and some really, really big hives. But ideally, if you can put them directly in the orchards, right off the trucks, works the best. Spread them out that way. We do have to hold a few back. We try to put like 100, 200 in a corner of an orchard somewhere. Spread them out as best you can. And I don't know if there's anything to it, but if it's possible, if you can face the entrances north and south instead of east and west, seems to help a little bit with drifting. But yeah, if you put them out in a big flat with a couple semi-loads, it's ugly, ugly, ugly. So ideally, if you can put them right in, it saves a step too. It's a little more work going through them, but usually they hold really nice if you can put them directly in the orchard.
Doug had a similar question. I think that answers it, Doug. Feel free to unmute and ask if not. And we have a question from Stefan. And I think we'll talk about it tomorrow too, but the question is double deeps versus deep and a halves, the capacity or any benefits to storing in singles versus doubles or 1.5.
I will just say, the beekeepers know better than I do, but there was some early work in Canada. I can't remember now off the top of my head, but they looked at this, how well bees did going into storage in Canada, and it was 2 deep, standard 10 frame boxes compared to these 1.5s like you're talking about. And I think the best sort of survival and condition of the colonies coming out in that study was that they did best where they had a big, strong single deep, and then they threw one full, super on, a shallow super. So the configuration going into that would have been what you might call 1.5s, and those did the best. So I think that's probably about what they need to consume is a nice big heavy super if they're 10, 11, 12 frames of bees. So I think the singles, there are people that winter in singles, and then like in the Northeast, I think there's some folks that do that, and they even do it in 5 frame nuke boxes. People have been successful at overwintering those indoors. And so, but I think it's just my guess would be it's a little riskier, right? I mean, to have both enough space for brood and have enough honey stored with only a single deep makes it hit or miss. And if you've got thousands of colonies, you might not be able to afford that sort of bell curve, that the risk of having some too light or some not have enough brood and too heavy. And so I think that's why the 1.5 or 2 deeps is probably safer.
Go ahead, George.
So coming out of the Pacific Northwest, one of the problems that we have with outdoor wintering is that when we get to the almonds, we have a really, depending on the season, it's worse or better, but we have a huge drop off in population. The bees look great in Oregon and we get them down there, and 2 weeks later, our clusters are a fraction of what we thought we had. I'm wondering if overwintering indoors helps with that. Do you have less of a drop in population as the old bees die off and the young bees haven't replaced them yet? This is, of course, an issue if you're being inspected. If you're inspected the day after you get them off the truck, you're in good shape. But if the inspection comes right at the beginning of bloom, 2 weeks after you put the bees in, all of a sudden your bees don't look all that good. So I'm just wondering if you feel like overwintering helps with that, or it really isn't, that's still an issue.
I think one thing that the cold storage has, and that's a benefit for that, is that it more or less freezes your age structure in your colony, so that when you get a little later into the fall, where the bees are either rearing less brood or aren't rearing any brood at all, but you still have weather where bees are flying. Now you're shifting the population into older bees, and that translates into a deeper spring dwindling when those bees come out and go into almonds. I mean, that's one of the challenges with pollinating almonds, and there's so many challenges, but those bees are flying and going after a nectar and a pollen source. It's highly attractive and abundant right during the time when the population is on the decline, because it's in the spring dwindling. There's not enough brood to replace the bees that are foraging and dying. And so I think what cold storage does is, like I say, it freezes that age structure that you went into the fall with. They rear some brood in cold storage to help cushion that spring dwindling. And then the depth of the spring dwindling is just going to be a function of what that age structure was when they went into cold storage. But at least with cold storage, you have a little bit of control over it, where outdoors in some areas, depending upon how warm it is in the fall, you don't have any control over the age structure of the colony going into almonds.
Yeah, I think, Gloria, some of the questions, I think people may make a mistake and think that you're keeping the bees warmer in cold storage, but actually it sounds like what you're really doing is guarding against ups and downs and keeping a very steady, predictable state, right?
Yes, that's a great way to put it. Great way to put it.
Yeah, that's interesting, because that's one of the differences really between sort of this US practice versus, this originating mainly in Canada, was more of a protection against the, harsh, cold winters, right? So it was more to protect them against the cold. But in a lot of ways, especially with the work Gloria's been doing, is we are kind of now protecting them from the warm falls or warm winters in some cases. And that, George, your question kind of reminds me, Steve asked a question during Gloria's talk about the longevity of that field force when they come out of storage. And I've gotten this question from almond growers in the past, and they're concerned with that spring dwindling, that all those bees coming out of indoor storage are going to be old bees, and maybe there's a lot when they come off the truck, but that they're all going to drop dead after a few weeks because they're all, technically old bees because they've been in there a long time. But I think, with Gloria's work and those figures showing that when they come out of storage, they might be, by the number of days, they're old bees, but physiologically they're not old bees. And so it seems that spring dwindling is lessened, is less of a problem for the indoor storage than it is for bees that have been outdoors, because of all the reasons Gloria just mentioned.
So Brandon, you're describing what we hear called the fly and die effect.
Yeah, and that's one thing. That's the great thing about the indoor storage, is that you don't have that fly and die effect, which also includes the flying and spreading of diseases and spreading of mites and all those other things too.
Yeah, we did have several questions come in about diseases and virus and any concerns indoor. I think we've addressed mites. Anything left that we didn't cover?
Yeah, I don't know if this, the teaser to get people to come back tomorrow is that'll also be in the talk a little bit too. So I was fortunate that Kelly just put together a figure from some work we did with the Bee Informed Partnership over the last couple years, comparing indoor in California versus colonies held either outdoors in Idaho or colonies held outdoors in California for the winter. And so one of the things we looked at in addition to mites was viruses. And so it seems that, the concern kind of comes both ways. One is that with all those bees, especially if you saw in those videos, you have tens of thousands of colonies stacked on each other, and the bees are being kicked out of the hives above them, and the air is pushing all this sort of dust around. Some people might be concerned that there's viruses floating around in the air, viruses from hives stacked on top of another, dropping virus infested bees into the hive below them or something like that. What we saw and what I'll show you tomorrow is that is not a concern, and that, I think you could probably imagine that in the case where bees are able to fly outdoors in California and they're able to produce brood and grow mites and rob each other, that's a much bigger issue than any kind of bees dropping dead on top of a hive in a building. So the viruses are not worse in a building for sure. The spread of virus does not seem to be an issue in the buildings.
I think we're all pretty sensitized to virus spread these last weeks. Okay, well, we're getting to where we've covered a lot of the questions. This is, having Bryan and Buzz here and talk about how they use storage in California is a unique opportunity. They won't be on the panel tomorrow. The others will probably be around tomorrow, and we'll also have the HVAC specialist so that you can ask your technical questions about these buildings. I think if you have any thoughts about if you knew then what you know now, what you've learned from indoor storage, what would you do different? Would be a good question. And if anybody has a burning question that we didn't answer, now is the time. Doug Hauke says, anybody ever think of adding ozone to the air?
Yeah, that's a good question. And you saw in that video, a lot of this is based on potato storage and onion storage, which in some cases they do use to reduce mold and some other problems in those storage buildings. But they use ozone to kill insects, and so you'd have to be real careful. It could be dangerous. You don't want to kill your bees, and ozone could definitely do that at certain levels. But I think there is that potential, and there's some USDA work out of Logan that used ozone for sanitizing stored comb and things like that. So I think there's probably some of that potential out there.
All right, the crowd's getting quiet. Any thoughts for each other? Anything else to add before we go?
Yeah, I would say I think we're all finding different ways to use cold storage, and I think that beekeepers need to investigate how it can work for them, because there's more opportunities than just winter storage and more uses. I think that you need to always keep in mind it's not going to cure all your problems. It's in fact, it'll expose your problems because you're going to put them under certain stresses. So you have to do your work before going into the room. It's a tool, it's a management tool, but I think 10 years ago when we built our room, there's a lot of things I'd do different now, right? I'd build rooms bigger, I'd change configuration. So put good thought into how you want to use it. And yeah, I think it's still the future for bees. We got more thought to be put into it, more uses to be thought of. But I think that definitely, if you're interested, keep checking into it, because I think it's a great tool for managing your hives.
Great. Well, we really appreciate you joining us and sharing what you're doing with indoor storage, especially I think that we've just expanded everybody's notion of how it can be used and the many possibilities. And thanks, Kim, for talking about these smaller units. That was really helpful too. And we still have time, so I don't want to cut anyone off, but our questions are quieting down. And I'll just plug, while we're still all here tomorrow, we have another panel, and Brandon's going to talk about his research on some of these practices. And it'll start at the same time tomorrow. So if there's nothing else, then that concludes our day. And I want to thank everybody for joining us.
Thank you.
Thank you.
Yeah, thank you all.
All right. Good morning, everyone. I think we still have some folks filtering in for our second day. Okay. Just a reminder, everybody, as the participants, please mute yourself so we don't get any background interference for the speakers. And also a reminder that this forum is really meant to be an educational opportunity for all of us. So if you have any questions, big or small, please enter them in the chat function, which if you move your cursor will be towards the bottom of your screen. And we had a really great conversation yesterday afternoon. So we're hoping that the same will be today. So don't hesitate to ask questions, anything that wasn't 100% clear or things that are on your mind to help you understand whether indoor storage is a good fit for your operation. So to introduce myself, I am Josette Lewis with the Almond Board of California. I never knew when I took this job several years ago that I would spend a very significant portion of my time working with the beekeeping community, but it is a partnership that we take very seriously for obvious reasons in the almond industry. You guys are as much a part of our success in almonds as we are in the growing and processing of almonds. So it has been my pleasure to learn much more about honeybees and to work with many great researchers, beekeepers, and organizations devoted to the health and prosperity of honeybees and the honeybee keepers as well. So I was really pleased that we were able to launch this. Sorry that we can't be in person. Maybe I'll see some of you down next week at the California State Beekeepers Association. But look forward to the return to in-person conferences in the next year. Hopefully you found yesterday informative. I thought the discussion that went for over an hour is an indication of how people are really thinking through indoor storage as a tool that might be a significant shift in their business operations, but one that can have a variety of different benefits, whether it's for varroa control, cost containment, ease of management. So we all have lives in addition to our jobs. So I thought that was really great, the volume of questions. I was really struck myself in listening how much those commercial beekeepers who have shifted to using this approach, it's really about rethinking quite a few parts of your operation. It's a management change, not just one component of your operations. It's a little analogous in almonds to the shift towards self-compatible varieties, which still need bees, by the way, or to off-ground harvesting, a journey that we're on right now that will change many, many parts of the operation, not just the harvesting part itself. So I think yesterday was a great opportunity to really dive in with those who have implemented this and some of the researchers. Today, we're going to shift and talk a little bit more about some of those infrastructure logistics, the facilities themselves, and how those are designed and managed. So really look forward to the conversation. I think we have a pretty good number of folks that have made it back from day one, so I suggest we go ahead and kick it off. Our first speaker today is Brandon Hopkins with Washington State University, probably familiar to all of you from yesterday and from being at the center of this research. So I will turn it over to you, Brandon. And again, as he's talking, really encourage any of you that as questions arise, please type them in the chat and we will circle back to Brandon with those questions after his presentation.
Well, thanks a lot. I guess I should know how to use this by now. Can everyone see my screen?
Yes.
Is that working? Okay, great.
Yeah, perfect.
Yeah, thanks for the introduction and look forward to talking about this some more today. I'm going to be talking about, for some of you, will be a bit of a review, some work that we've done in the past, and then there's a number of slides and a couple projects that are new that we haven't really presented to anybody yet. And so I'll get started with a bit of an outline. So if you were here yesterday, you heard about the use of these storage facilities at times other than winter. So I'm going to start by talking about the use of these facilities during the wintering period. and then talk a little bit about our work in using these sort of refrigerated indoor bee storages at times during the spring and summer seasons, and actually in the fall too. So some of these questions are kind of about when did people start using this, or when did this indoor storage occur? This is an article from the American Bee Journal from 1902, where beekeepers writing in and asking about a safe method of wintering bees to protect his colonies. And he's losing 30% of his colonies each year. I can't remember now. I think it's in Iowa or something like that. And so the response is, for this beekeeper to try using cellaring, or basically, indoor wintering in a root cellar kind of situation, or using these chaff hives with the special lid. So it's kind of interesting that even in 1902, and the temperatures are the same, the recommended temperature for these cellars was to try to maintain between 42 and 50 degrees. So very similar to the work we're still doing. And there's a publication out of Canada in 1926. Here's a couple of images taken from that publication where they're carrying these hives into a cellar in Ottawa. And here they kind of are stacked up in the cellar. So this indoor wintering isn't anything new. I think a major shift is the purpose for the indoor wintering that we use now. And, obviously the refrigeration and the advanced systems and things like that we have to keep the bees in probably optimal condition for this indoor storage technique. So we saw, in that video, and we'll have videos today. This is one of those modern refrigerated facilities with, before they put the bees in. And here they're looking at the ventilation test using this purple smoke bomb, if you can see that purple smoke in there. And so it's kind of impressive with the number of colonies stacked up in there. And you'll see much better videos later today than yesterday. And this was just kind of struck me. So this is data from CDFA from the inspection station. So as these trucks come into California for almond pollination, they register where they came from. And so this is the number of colonies and the individual states in which those shipments originated. And when I saw this, I thought it was amazing because, I'm pretty sure Idaho does not have 300,000 registered colonies in the state of Idaho, right? It's got to be much less than that. And so for this number of colonies to be coming out of Idaho into California for almond pollination, it has to be because of the large number of indoor storage facilities positioned in Idaho. And so Kelly Kulhanek did a great job of putting together this figure, which is in the updated indoor storage guidebook on Project DeepSM. And so we did the best job we could with the help of Greg Schved and all these beekeepers. So calling them and finding out how many colonies are stored indoors, how many different beekeepers. And so this is probably short a few beekeepers and a few colonies, but this is sort of the first attempt at looking at the numbers of colonies that are stored indoors, the number of facilities in each of these states. And so you can see Idaho being a major one. Our best guess based on the beekeepers we talked to is around 420,000 colonies are stored indoors in the state of Idaho, which is really pretty impressive. I mean, that's, if you consider almonds need somewhere around 2 million colonies for pollination, that's 25% of all the colonies, pollinated almonds are coming out of indoor storage facilities from just the state of Idaho alone. Pretty amazing for sure. Our interest at WSU came from in 2014 when we had a Washington beekeeper who started storing his bees in an old tree fruit storage facility after some heavy losses in his normal practice, which was taking bees to California in these large holding yards from November until almond pollination. And so our initial look was just an observational study. And we looked at sets of colonies. I think it was 60 in each of the groups here. So CA is not California. I should relabel this at some point, but so this, and I don't know if you can see my cursor here, but so okay, good, thanks. So that's a controlled atmosphere room. And so that's something I don't know that we've talked about a lot yet, but that's the style of facility they use for storing tree fruit a lot in general. So this is more like a sealed vault of a room where they can control the gases. So for apples, for example, I think they lower the oxygen level to something like from normally 18 or 20% oxygen to like 2% oxygen. And that's how they keep the apples from over ripening and can, we can have fresh apples year round because of that. So this is controlled atmosphere room, but not maintained like that. It just has a lot less ventilation, say, than a standard refrigerated room, which they also had at that same facility. And then outside here in Natchez, Washington, and then the California holding yard. And so the kind of main thing to look at here was really the frames of bees. So we assessed these colonies in October and then looked at them at the end of January when the indoor stored colonies went down to California. And so the strength of those colonies was significantly greater in the colonies held indoors and really even outside in Washington where it's cold. And so hopefully you heard Gloria's talk yesterday, and this concept of allowing the bees to have a cold winter where they're not flying is really important. And I think that was the result here, in that the outdoor temperatures in Washington were around the same temperatures as the indoor facility. And so the bees in the California holding yard were significantly weaker than the colonies indoors. And so that was kind of our first entree into indoor storage. And then I hope that I say this enough, or saying it often enough, but a lot of these ideas, are really coming from the beekeepers. And one of the things I miss most about these in-person conferences is that it's really where I get probably 90% of the ideas for research and things like that is coming from beekeepers and discussions during these conferences. So one of these was after our work there, is the beekeeper was telling me that his bees were so much fatter coming out of especially he felt the controlled atmosphere storage rooms, but in general, he said the bees are so much fatter and healthier coming out of indoor storage. And I thought that was ridiculous, because you can't just look at a bee and say that one bee's fatter than another. And so I kind of set out to prove him wrong, and that you can't tell me that the bees are fatter coming out of storage. So one of the things what we did was we painted these aged cohorts. So we merged thousands and thousands of bees in an incubator and painted a dot on their thorax. We did this every day for about a week. And then we placed all those painted bees into these colonies in late fall. And then they went to these different locations. So we had a pallet of colonies, all with these marked bees in, that went to California for the winter. And we had a pallet of colonies that went to these different storage rooms in the controlled atmosphere and refrigerated. And we had a pallet of these colonies that went and sat outdoors in Washington. And then what we did is, then at the end of that, we collected all of the painted bees that we could find in January after the winter storage. And so this is the head protein levels. And if you saw Gloria's talk yesterday, they found this sort of similar results in comparing bees in Texas versus indoors in North Dakota. And that the bees, in fact, were healthier in that they had greater protein levels when they were stored in these cold rooms versus outside. And they had, after greater lipids, especially in the controlled atmosphere facility compared to the California holding yard, they had significantly greater lipid levels. So they were fatter, and that beekeeper was right, and I was not able to prove them wrong. So I thought that was very interesting. And I'll come back to this, or would like you to kind of remember this controlled atmosphere facility having this greater level of lipids, because I think that's really interesting. as far as the CO2 discussion, which comes up all the time. And whenever people are storing bees indoors, there's always questions about the CO2 because it's, and for good reason, it can be concerning with those levels rising while the bees are in these great big rooms. And so I didn't put it up here. So while we were doing this, and because this beekeeper had this controlled atmosphere storage room, he was very concerned about the CO2 rising, so much so, and because there's very little ventilation in that style of room, every night he would go to this facility and open the doors on the controlled atmosphere room to allow greater venting because he was concerned that the CO2 was increasing. But because we saw that, healthier sort of bees, he thought the bees were better coming out of that room. We thought there might be something to that ventilation issue and the rising CO2 every day while the doors were closed. We looked in the literature, found a paper from a group in Canada who I'll talk about in a couple other instances as well. But Dr. Curry's lab had some papers in cages, small little cages with a couple hundred bees that they had under these different ventilation rates. And so they were showing that higher levels of CO2 in these cages were increasing varroa mite mortality, which was very exciting because beekeepers want to be able to kill varroa mites every chance they get, and we were seeing these high levels of CO2 in this indoor storage room. So we've been working at this for a number of years now to see if this has the potential as a mite control option. And in single deep colonies in a incubator, so not a large controlled storage or refrigerated storage facility on a commercial scale. So these are incubators the size of your refrigerator at home, a little bigger. We had colonies, single deep colonies set up with sticky cards, and we ran them for 62 days at 4 degrees Celsius and collected all the mites that fell. And afterwards we applied a sort of a shock treatment of a miticide and collected any remaining mites. And what we found was at 8% CO2, so which is 80,000 parts per million, so really pretty high, 75% of the mites died during that storage period, compared to the control. It was about 45% of the mites died during that storage period. So significantly greater varroa mortality, but not 100%. And most people would consider or would want their sort of varroa efficacy treatment to probably be more up in the 90 percentile. But this is something we continue to test and try to see if we can increase that mortality level, and if it's possible on a larger scale. So we had that really basic observational study early on that showed the bees had greater strength as far as frames of bees. They seem to be a little bit healthier in their physiology in indoor storage. And so with a grant from the USDA and partnering with the Bee Informed Partnership and their group, we had this experiment that went over the course of two separate seasons. So from 2019 to this year, we looked at 120 colonies, 2 different operations. So what we did was we split each of these 2 separate operations into 3 treatment groups, where 20 of the colonies were, so they call them sheds a lot, I don't know, potato sheds, but these is an indoor refrigerated facility, or temperature controlled facility anyways. So 20 colonies went indoors for the winter, 20 colonies stayed outdoors in the north. So either in, and this is, this is in outdoors either in Montana or outdoors in Idaho. And then a set of colonies from each operation were shipped down to California in November and stayed outdoors in California. So we kind of have these 3 treatment groups, 2 different beekeepers, a total of 120 colonies. And we did this twice, 2 different winters. We looked at the queen status, brood pattern, frames of bees, frames of brood, tracked mortality, obviously. And we took Varroa samples, nosema, and virus samples and tested for these 7 different viruses. And so I should say, so we did this at 4 time points. So all of these metrics were measured at 4 time points. So pre-treatment in August, that's pre-Varroa treatment. So that's before they treated for Varroa mites. Then again in October, after they completed their Varroa treatment regimen. And then when they came out of storage and were shipped to California, they were all sampled and assessed again in January. And then a follow-up in late February, March during bloom. So you'll see a number of these figures, and it's kind of a lot going on, but the left is the 2019-2020 winter season, and on the right is the 2020-2021 winter season. So these are these 2 separate years. It's a new set of colonies each year, right? So it's not the same set of colonies tracked for the full 2 years. So it's a new set each time. And I think you'll see it's definitely one of the reasons why these kind of studies really need to be repeated and how different things can be from year to year. So this is the Varroa levels. And so in that first year, there's really no difference in the amount of Varroa. I mean, in this treatment, in the group that ended up going to California, there was significantly lower level of mites to begin with. And so for whatever reason, this set of colonies, the treatment between, whatever Varroa treatment between pre-treatment and post worked really well in this group. And they had significantly less before the winter even began. But by the time they got to post-winter and follow-up, there's no differences in Varroa levels between the group that wintered indoors versus the group that wintered outdoors. And then in the second season, it was much more consistent. All the colonies after treatment were even, really low mite levels across the whole study, really. One of the sort of these pros and cons of working with really good beekeepers is that for this kind of thing, you like there to be lots of mites so you can see differences in your treatments and all that. But these beekeepers did a really good job of controlling mites. And so that's great for this post-treatment. And then it is interesting, though, that the group that wintered outdoors in California did have significantly higher mite levels than the stuff wintered indoors. And so if you kind of ignore the fact that even the significantly higher group is only 0.6 mites per 100 bees, and most people would be very happy with that number. Another way of looking at it, though, is that these levels are 3 times higher than the levels of the bees that wintered in the building or outdoors in California. And this is most likely, right, to just the brood production or also the mite production being in California over the winter. But if you kind of took this and went with more like, 1 mite per 100 bees instead of 0.25 mites per 100 bees, and 3 times that would be more like 3 mites per 100 bees. So this could easily be a big issue if your starting mite levels were higher than in this case. This one, to me, it was almost, maybe just because the mite levels are so low, but this was a question I got a lot. And I think there's a lot of concern about this and the virus, and the question about viruses came up yesterday. So I'm excited to show you guys those slides next. But the nosema issue was always a big question, especially because of the concern about bees not being able to fly out and go to the bathroom, right? Take those flights. And that question came up yesterday as well. And so some people were really worried that with the bees stuck in their colonies, not able to go on these cleansing flights, that might be an opportunity for nosema levels to build up in these indoor colonies. And so in both years with our nosema results, the colonies wintered outdoors in California had significantly higher nosema levels than colonies stored indoors. So for a lot of folks, this is sort of opposite of what I've heard people's concerns are, and that nosema might be higher in indoor wintered facilities, and it's opposite of that. Nosema in these studies were higher in colonies stored outdoors in California. Frames of bees. So this is kind of, there's, very little to no difference in the frames of bees, whether they're stored indoors or outdoors. And there has been some concern. I mean, I think if you're going to draw something from this, it might be that concern about not having much brood in colonies coming out indoors and them suffering maybe more from the spring dwindling issue. I think Gloria covered that really well yesterday, and that concern about the spring dwindling issue is a bigger concern for colonies stored outdoors than it is really for bees stored indoors, where you have that age structure is maintained and you have like a lot of young, healthy sort of nurse bees, these winter bees coming out of the indoor storage facilities. Yeah, and this is the brood pattern. No differences here, which is great because it shows that the differences observed are due to the conditions, not because you have some colonies with better queens or better brood patterns, stuff like that. And this is the brood area. They build up great coming out of the season, out of the storage. This figure on the right shows the greater amount of brood here for the post-winter for the colonies that were stored in outdoors in California. And that's probably the main reason for that increase in mite levels for the outdoor in California, is this larger amount of brood. Okay, so this is I know this looks messy. I'm going to throw up these kind of crazy slides here at first. And I didn't put them all up there because even 4 of these figures is too much, but we tested for 7 different viruses. I threw up here these 4 real quick. So this is prevalence. So this is whether or not that particular virus showed up in the sample at all. And so this is just kind of the spread of these different viruses you get. So Israeli acute paralysis virus just has a really low prevalence in these colonies across these 2 years. So about 25% or so of the samples had Israeli acute paralysis virus at all. And like Kashmir bee virus, it was almost absent entirely in these samples. But something like black queen cell virus was like across the board, every single sample had black queen cell virus. And I was kind of surprised this on the top right corner, you have deformed wing virus. I thought this would be much more like the black queen cell virus. It's somewhat ubiquitous. This could be, and I could be wrong, but I've heard that this deformed wing virus is being a little bit displaced by this Varroa destructor virus, sort of a cousin of deformed wing virus. But it also could be a little lower because if you remember those mite levels being really low, the Varroa mite levels really low often results in low levels of this deformed wing virus, or low, prevalence anyways. And then this one I thought was interesting. So the prevalence across the board for all groups climbed dramatically for this lake cyanide virus. And I'm sure if we had Michelle in this talk, we could ask why that is. I don't know, but it's interesting for sure to see how it climbs in all 3 treatment groups. So this is the amount of virus. So versus the prevalence. So those other figures were the prevalence. This is sort of the amount in each sample. And this one, again, is kind of difficult to assess. It's kind of all over the place. Kashmir bee virus only showed up in the outdoor groups, but remember that prevalence was so low, it just wasn't. So this is probably one sample that was actually found in, and the levels were relatively normal. So for some of these, okay, yeah. So the point of this was, so it's kind of up and down depending on which virus you're looking at as far as the levels. So what I asked Kelly to do when she did this assessment was to just sum up the total amount of viral copies here and look at it for the 3 treatments so that we could look at it all at once. And so this is overall viral abundance. So just adding all 7 viruses and the amount that each of the samples have and combine it into one figure. So we can kind of just look at overall abundance. And so there was no difference in overall abundance at that post-treatment, that first time point. After the winter storage period, the colonies, both indoors and the colonies outdoors in California, had significantly greater abundance of all viruses measured compared to those held outdoors in Idaho and Montana. And then again, the outdoor in California had significantly greater overall viral abundance than the colonies held outdoors in the northern locations, Idaho and Montana, but no difference between those and the indoor. So basically the concern about virus buildup in these indoor facilities is sort of unwarranted, and it doesn't appear to be a problem for viral buildup, which is great because it's also what was found from this group, again, Rob Curry's lab. Dr. Curry in Canada did this work looking at both nosema and two of these viruses that we also measured, the black queen cell virus and deformed wing virus. And so in this case, there was a significant drop in deformed wing virus for the indoor group. So here's the fall, this dark black bar in the fall, deformed wing virus, and then in the spring, a significant reduction in deformed wing virus. Compared to the outdoor group, you have it, somewhat level or an increase in in the deformed wing virus. And the same for the striped lines here, this black queen cell virus. In the outdoor group, a significant increase in black queen cell virus and a smaller increase in the indoor group. And the same with what we found too is that nosema levels in the outdoor group, this bar here, increased in the outdoor group, and nosema indoors decreased. So, from this work, basically have varroa loads increase faster in California after the treatment, and that's most likely just caused by brood rearing. You have higher nosema loads in the outdoor group held in California, and in general, the virus levels are higher in the outdoor group, outdoors in California compared to outdoors in Idaho. I said we measured mortality, so it was just very low, working with good beekeepers. So the overall mortality was below 10%. It's great. Okay, so switching gears here a little bit. So that's kind of the end of the indoor wintering compared to outdoor wintering and for the health of the bees. And so now I'm going to talk about a little bit of the use of these buildings at times other than winter. And hopefully if you were on this yesterday, you heard some uses from the beekeepers in California and Idaho that use these facilities at times other than winter. And they can be valuable, but it's highly, highly dependent on each operation's sort of management style and practices. And so one of those things is this taking advantage of this broodless period. So the ability to control the temperature and the light allows you to have some control over the brood rearing in these colonies. And so my interest in this came from this ability to manipulate this and the idea that varroa mites, when they're reproducing inside the capped cells, the capped brood, they are really difficult and in most cases impossible to get to with our chemical controls, with the common chemical controls. So all except for formic acid, as far as I know, do not kill mites inside capped brood. So we have to get them when they're on the adults. And so our choices for that are either these sort of long lasting strips, like these apivar strips, the formic acid, these other things, the coumaphos and fluvalinate or Hopguard that last a really long time, or you use a flash type treatment like oxalic dribble. But the problem, the problem with those is that it takes repeated treatments. And so what they've been doing in Europe quite a bit is this idea of queen caging as a method of reducing the amount of brood or removing brood entirely. It's just very labor intensive, but it works very well. So if you can get rid of the brood, say with queen caging, for example, compared to treating while there's brood, all of these miticides are far more effective when there is no brood present. But this queen caging is not feasible when you have thousands of colonies or tens of thousands of colonies. And so the interest here was whether or not you could just put bees in a cold refrigerated space with no light and reduce that brood ring to a point where you could get effective control. So for us, what we've been using are these refrigerated cargo containers. I'm not sure that, I don't think they're as good as these large refrigerated buildings as far as the air condition, the climate control conditions. But what we were able to do is do this at 2 different time points. So one time we were able to do this successfully in the fall, and then we were able to do it successfully in the spring. The fall treatment worked really good. And again, and I'll probably say this a bunch more times, but it's really highly dependent on the operation. So if your business model is making honey in North Dakota or Montana or South Dakota, this might not work for you because maybe you're making honey until mid-September or something like that. And there's not time between honey production and preparing your bees for winter to put them in a storage facility for 18 days to cause a brood break, and then treat those colonies and then feed them and build them back up in preparation for winter. But if your business model is mainly around pollination and you don't make a lot of honey anyways, and your pollination season is done in August, this could be a very effective control strategy for you. So that was this, for this one, that was the case. Their last pollination was, I think, canola in this case. And I should say too, is it's not the entire operation. So this may not be something where you do the whole thing. This was a large set of colonies involved in canola pollination. And we were able to put half of them indoors and half of them remained outdoors. And they performed their normal Varroa treatment for the control, the group that remained outdoors. And they used a single application of oxalic acid for the group that went indoors for 18 days. So once they were broodless, they treated them. And this was the mite levels in October after an August brood break. Yeah, and again, so this idea of early season, so the spring brood break came from beekeepers who were interested in trying this. And so we followed a large set of colonies after almonds. They were trucked up to Idaho. For this beekeeper, it worked for them because they generally came up to Idaho. There's not a lot of forage right after almonds in southern Idaho. The bees sit around waiting for dandelions to begin blooming, those kind of things. And so they thought that might be a good time to treat for mites. And so you can see in this case, the outdoor group had pretty high levels of mites coming out of almonds. And so I think that's another thing to consider, is this kind of used as an integrated pest management approach, and that you ideally would sample and know whether you had much of an issue, because this is a bit extreme to take your colonies into this cold, dark period. They're ramping up, producing lots of brood, and then you put them in a cold, dark room for almost 3 weeks. But if you came out of almonds and your mite levels were too high for your comfort level, it might be, an opportunity to try something like this. And so in this case, it was very effective. They were able to get them mostly broodless in 18 days, and a single application of miticide provided excellent control for this group that went through this period of indoor storage immediately after almonds. They were concerned about weight gain and weight loss. They did consume a lot of food. It was almost a pound or 3/4 of a pound
per day in storage coming out of almonds, which is compared to colonies that go indoors for the winter. We heard yesterday was closer to like a pound per week. So these bees being held indoors in the spring that aren't, preparing for winter consume a lot more resources. But they built up fine. It didn't affect, 2 months later, didn't affect their ability to produce honey and to gain that weight back. So I will say, and I don't have it here. I figured I had too many slides as it was. We tried this same indoor story in the spring with another beekeeper. In this case, the timing for them was better after apple pollination. And it was not as effective. It was harder on the bees. I think the bees were a little lighter after almonds compared to this set of colonies we used immediately after almonds. So I think within each operation, if this was of interest, it needs to be done kind of really carefully at a small level. The bees need to be very, very heavy, well fed, and so basically that later after apple pollination, we did not get as good an effect. It was much harder on the bees. The bees did not come out as well as this brood break immediately after almonds. So it's another good reason why these sort of studies need to be repeated over and over. And there are big differences in each individual operation. You heard from Nick Noyes yesterday. I thought, really brilliant idea of using this cold storage as a management strategy to really help with the amount of bee work compared to how much labor you have. So the idea there was, can we put some portion of our operation in these buildings to slow down the swarming behavior so that you can get your work done? So it's a lot of labor, a lot of effort to control swarming, to shake and make packages or to make splits. And sometimes that work is difficult to get to every hive, and then you can lose hives to swarming because you just can't get around to them in time. And so the idea here was, can we slow them down in order to increase our sort of labor to hive ratio and get the work done? And then when we're ready, we can bring this certain portion out of storage and focus our efforts better. And so what we found here is that, and we looked at the timing, like how long do they have to really be in storage in order to slow down the swarming behavior? So a large set of colonies that stayed indoors, this is after almonds, for 12 days, 45% of those colonies within the next month all either swarmed or had swarm cells in preparation for swarming. When they were indoors for 14 days, 33% of the colonies had these swarm cells that were trying to swarm. But when they were put in there for 18 days, we didn't find any attempt from those colonies to try and swarm within a month after being in that cold storage period. Let's see. Probably gonna run out of, I'm just checking the time here. Yeah, we'll go through this quick. So this idea again is just going through these seasons and how these things might be used. So I saw this really great presentation on banking queens in the winter, and I'll show that slide here in a second. And then when I asked commercial queen producers, they said really the tough time for them is in the hot summer when it's 100 degrees or so in California. It can be difficult to bank queens. And that's when this supply and demand thing that I just made up to represent, and someone could probably argue or tell me how this could be better, but you have this supply, is really low at the beginning as queen producers are gearing up and making queens, and everybody wants queens early to make their splits and to fix problems. And eventually the queen producers, get fully ramped up and they're making lots of queens. And then at some point that demand drops off because
beekeepers are making honey and they're not doing their requeening. All the splits are done, all the packages are done, but you have, thousands, tens of thousands, hundreds of thousands of nukes from that ramp up. And so you have maybe a surplus of queens at this time of year in the summer when it is very, very hot and difficult to maintain banks, and the forage is reducing. And so it's a difficult time of year in this sort of June, July, August to bank queens outdoors in California is the idea. So I'd just seen this paper, this work, and I saw that Andre was on this yesterday. I was hoping he'd be here today, or maybe they could chime in if they want to talk about it. I thought it was wonderful work, super cool. This was indoor, this is banking queens indoors for the winter, not the summer, but they had wonderful success. So this number at 15 degrees Celsius, they had said like 86% survived from November to April, which is a huge time span. And I thought it was genius. Most of us store indoors at 4 degrees, and the much, lower survival. And so this warmer temperature for queen banking seems to be a major factor in the survival, and 86% is fantastic for that long a time period. And so that's what our work was kind of based on or inspired by that work. This just shows this average temperature, and there can be, I know at one time there was like a week-long span where it never got, the highs were all above 100 degrees, so it can be very hot during this time of year. It was a rather big experiment. It involved 2,150 queens across these groups. It's a little bit messy here, but basically we took 50 of the queens and used them as unbanked controls. So we installed them in nucleus colonies and left them as these unbanked controls. Then we had a group in Northern California maintained by the queen producer with replicates of 3. So 3 banks with 50 queens each, 3 banks with 100 queens each, and 3 banks with 200 queens each. And then we tried to replicate the best we could those same banking conditions, and we moved those banks to these indoor temperature controlled rooms, and again had replicates of 50, 100, and 200. And those were held at 15 degrees Celsius, inspired by that work of Andre. And then at different time points, we sacrificed queens, right? So after 30 days, we sacrificed 10 queens, and these were sent to Tarpey's lab for analysis. And then from each of these, so 10 queens from each bank, so for the banks of 50, that's 30, went to David Tarpey's lab for analysis. So spermathecal dissections and weighing the queens and measuring the thorax and all those things that are done by his lab there. And then we also at the end of it sent these queens to a queen producer who installed them late in the season, in September, October, into nucleus colonies to monitor their egg laying, their brood production. And I'm running out of time here. So this was the overall result. I won't show you all the laboratory analysis of the queens, but indoors, in these different banking rates, it was around 75%. For the outdoors in California, there's very little difference, which is great. And it's really what we're trying to do, not to do better than the banking practices, but to show that it was a viable alternative to banking these queens outdoors. So I don't think that this is something everyone should do, is go start banking their queens indoors, but more of an option for particularly harsh summers where the temperatures are really bad. This might be a viable way to bank your queens. I do think it's important to note the variability in survival for the outdoor groups is much greater. These box plots are much wider, so the indoor storage is maybe a little bit more consistent. And it was very surprising to me to find really very little difference in the banking rate. So I would have guessed that the banks with 50 queens would have done much better than banks with 198 queens. But that was not the case. in any of the groups, outdoor or indoor. The banking rate seemed to have little or no effect on the survival of queens, which I thought it's great because it's much more cost effective to bank 198 queens per bank than it is to have lots of banks with 50 queens per bank. This was really great work, and I have to thank the students who worked on this, Anna Webb and Stephen, and the postdocs that helped too. It was a lot of work and really great. And the folks that funded this work that I've talked about, Project APSM, the Almond Board of California, great supporters of this, USDA, the Washington Tree Fruit Research Commission, and these beekeeping associations. And yeah, here it says Stephen and Anna, who did the work on the queen banking, and Kelly was throughout this whole project, the virus stuff. She did all those figures, has been hugely helpful in all of this work. So yeah, with that, hopefully the time is okay and I'll take questions.
Great, thank you, Brandon. I've been following your work pretty closely, and I have to say I learned some important new things today, not the least of which is that about a quarter of the bees that come to almond pollination, those beekeepers are already using this technique, which is great to see, because from everything I've heard of the last 2 days, there's few downsides other than cost, obviously the facilities themselves. Open it up to questions. First one is, did the banked queens go on to lay?
Yeah, they did. And they went down to Southern California and they did great. So we couldn't, I should have put that slide in there, but there was no difference that we could tell in the performance of queens that were banked indoors compared to the performance of queens banked outdoors.
Great. I also just wanted to offer up, I did see that Andre was on the webinar today. I don't know if you want to unmute yourself and add anything on queen banking.
Yeah, put him on the spot there a little bit.
Well, he can jump in later than if he wants. Another question, in the graph comparing mite mortality in two bars, one was 8% CO2 and the other was control. What was the percent CO2 in the control?
Oh yeah, that's a good question. So it was, we were trying to have it just be atmospheric. So basically it's really high ventilation. And I think the highest it got up to was 0.5%, but generally it was around like 0.18 or something like that. So really low.
Yeah. Great. Rob, do you have a question, or maybe you can mute yourself? I noticed you must be unmute now.
Yeah, I had a question. How long were the queens banked for, and were you guys adding sealed brood, or how were you guys maintaining those banks, and how long were they in there?
Yeah, that's a great question. I kind of blew through that. So that's another, I think, really important point about us trying to really just have the queens be, survival and the health and all that of the queens be equal to the outdoor banking, because the outdoor banking is well established and they're really good at it. But the outdoor banking, part of that, like the trouble or cost associated with banking, especially when it's hot, is that those outdoor banks have to be maintained all the time. So they're being fed syrup, probably, most likely some pollen supplement, and you're having capped brood added to those banks continuously during that outdoor storage period. What we did was we wanted the indoor banking to be completely hands off. So we made up those banks and then they went into the storage, and the idea was to not touch them or disturb them at all. We did have to disturb them, but once a week we went in to check mortality. And so I think one thing is they certainly would have been better off if we weren't messing with them once a week to go open them and pull the frames and check that. We were also weighing them when we went in there once a week as well. And I don't know that it was necessary or helped, but I freaked out a little bit after a couple weeks because they were getting so light. I added some food to each of those, some honey to each of those banks, just because that was a very nerve-wracking experiment for me. If the folks on this call know what a queen is worth, and we had 1,000 queens in that building, that was very scary for me. And the thought of walking in and finding all those queens dead was causing a lot of sleepless nights. So I added food to them. I don't even know that was necessary. And the length of time that they were in there was, I should know, I think it was 8 or 9 weeks. It was,
a pretty long time. Normally you would be adding frames of sealed brood so you have the nurse bees to feed the queens. And I wonder, if you just added more sealed brood, if your percentages would be higher as you would do if you were doing it outdoors. But I understand the experiment. I'm just thinking of ways
and that's great. And I appreciate that. And that is I think something that if this is a strategy someone wanted to pursue, we'd have to look more at that. Again, I mean, part of this was sort of the idea of decreasing sort of labor and stress on the rest of your hives. And so the ability to just put them away and have them ready. I do think that there are things that we could have done to make those banks better. I think the amount of food that they ate was incredible, and the amount of pollen that they ate was incredible. So I saw George had a question about the makeup of those banks. So those banks were made up from full-size queen right colonies that were on canola, and they had huge amounts of pollen stores in the hives to start with, and then we tried to make sure they had as much pollen when they went in, and they had eaten and consumed every single bit of stored pollen that they had in those hives. So it made me think, it made me realize how much pollen and protein, and that's, they weren't rearing any brood while they were in there. We gave them, so the whole bottom deep of those banks was stuffed with as much brood as we could put in there, especially at this capped brood. So like you said, Rob, to give them as many nurse bees as possible, knowing that we weren't going to add any more. And so we stuffed the bottom deep with as much brood and as much of that pollen as we could. So basically 3 or 4 of the frames, the outside frames, were the biggest, best pollen frames we could get. All the rest of the frames were brood in the bottom. The top deep had the frames of queens, and then the other frames up there were the biggest, heaviest honey frames we could find. So basically the top was queens and honey, the bottom deep was brood and pollen. And that's one reason the banks with 50 queens I thought would do much better. The banks with 50 queens only had a single frame of queens, and they had a lot more honey. The queens with 198 queens had, it took 3 frames to hold all those queens. So they had a little less food, but they did just as well. So I don't know if that answers your question a little bit, but.
Thank you.
Yeah.
We have another question about the queens, which is the queen clinic information back yet from Tarpey? And can you speak to that if you have any more data?
Yeah, I'll speak to it. And I already felt like this talk was overwhelming with figures, and so I left those figures off. But yeah, so those results are back. The only real difference we found, which wasn't much of a surprise, was in the weight of the queens, right? So the banked queens weighed much, much less than, say, the unbanked control, which I think is a known phenomena and when the queens are not laying, they kind of shrink up, their ovaries stop production and they get smaller. Other than that, there was no effect, say, like, one concern would have been like sperm viability or something like that, or the number of sperm stored. All of that stuff was equal across the treatment groups. Some things like you just wouldn't, that are more results of queen rearing, not necessarily these banking practices, like the head width and the thorax width, and I think really even that, the percentage of spermatheca filled, like how full are the spermathecas, is really a result of the mating, not necessarily the banking practices. So it was nice because we had a huge sample size and there was no difference in that, in those sort of morphometric conditions.
Okay, I'm going to just take one more on queens and then I'll loop back to the Varroa question again. Another one on queens is, will the queen producer collaborator be adopting more banking? Have you heard from any folks who sort of really just specialize in the queen breeding side of it and aren't general beekeepers? I mean, they're not doing honey or pollination services.
Yeah, that's a good question. The person involved in that study certainly will, I mean, is very interested in trying this again and pursuing it a little bit more. I don't know, how widely adopted it would be. And like, this was very new and we haven't really presented it much to industry to much of a level at all. I think this is only the second time I've talked about it, and the student wrote their thesis and things like that on it. But yeah, I think part of it is there's not much in the way of storage capacity where the queen producers are, so it would probably take a bit of investment. I only know of one, and I haven't talked to that person about whether they would try something like this with their facility or not. But I think the first step is to kind of show that it has potential or is a viable option, and then folks will have to decide if it works for their management practices or for their regime. I will say we tried this with I mean, that's why I mentioned how impressed I was with that work in Canada, because then with this success we had in the summer, we followed it with our own indoor wintering of banking indoors, and we failed miserably. We had terrible success, and I was surprised that the collaborator even answered my phone calls after that.
Well, maybe that's just to jump in here. We saw yesterday that there is this smaller scale units that are being sold now. So that might be an opportunity for someone who's just a queen breeder.
Yeah, those like Hive Tech solutions would be perfect for these queen banks. Because even if you had thousands of queens, you're not talking about maybe 20 banks. A 10,000 square foot building might be a little much.
Okay, one more queen question. What was the temperature indoors, and is that any different from the normal temperature that you are looking at for hive storage? Yeah, so that was 15 degrees Celsius, which I think is 55, 52, something like that, Fahrenheit. And which is different than normal sort of indoor wintering, which is more like 40 degrees Fahrenheit. So it's a bit warmer. That's probably, in part why they consume a lot more food than we would normally see. My guess would be it provides a looser cluster of bees, which allows them to move away from the cluster to get to the pollen sources and for them to rotate through feeding in taking care of those queens. I was struck that maybe that's another case where doing some economic analysis would be useful, given that you had some benefits as well as maybe some trade-offs around the indoor storage for. Yeah, and we kind of discussed that a little bit with the student. It would be pretty simple to do. And I think what you'd find pretty much based entirely on the labor cost, would be much more cost effective to do this storage indoors if you didn't have to do, and you're not adding brood, if you could just make the banks and put them in there for 2 months. If you took that as labor savings, I mean, the hard part is like,
your folks sometimes they have other work to do, so it's not like you completely get rid of that labor, but I do think
Maybe, just deploy it to maybe a more critical part of the management at that time.
Yeah, exactly. Yeah, you could put more of your labor force on feeding the full-size hives or treating for varroa mites or doing other things for sure.
I'm sure most beekeepers will say labor is a huge constraint, not only because of cost, but availability. So, so circling back, could you talk a little bit again about the varroa treatments that were administered before the hives went in for winter?
Yeah, for sure. I mean, I can talk a little bit about it. We'd have to ask the beekeepers for sure. We didn't put any constraints on, especially for so I guess I started immediately thinking of the Bee Informed Partnership project. In that case, we didn't ask them to treat with anything in particular. So they did sort of their commercial practices. I know it involved a late season oxalic acid dribble treatment. Other than that, I don't know what they did beforehand. And we could maybe ask one or two of the commercial guys that are on this call or on the panel, maybe. Actually, that would be a good panel question to ask about that.
Okay.
For the brood break stuff that we had control over, for the fall treatment, for example, we were using oxalic acid dribble treatment for that sort of single dose. So when they were broodless, we put on a single application of oxalic acid in syrup.
Thanks. Could you recap sort of what the CO2 levels were that in that spring treatment, I think is when you talked about it, where it had the impact of reducing varroa levels?
Yeah,
so what the level was and how long they were in there. So if you optimized either of those two variables.
There you go. And I haven't optimized them. So the CO2 that killed varroa mites was 8%, which is 80 parts per million. And that's 80,000 parts per million. And so that is like a deadly amount for a human, right? Mm-hmm. So I think I had those numbers, but for like working conditions, I think it's like in an 8-hour period, you can only work in like 5,000 parts per million. And it's, risk of collapse and stuff, I think at like 2% or something like that. And so 8% is, you're pretty much dead if you walked into a building like that. And the bees seem to be able to handle it fine. The condition, so I didn't talk because this is more of a broad overview, but they found in a natural cluster, I think it was even Tom Seeley or someone who did this, in a tree, if you put a CO2 probe in the middle of a winter cluster, that CO2 level is around 6% CO2. So the bees can handle really high levels of CO2 naturally. And in a hive sitting outdoors in the winter clustered up, that's what that percentage is. And so that's why my real interest in the CO2 now has really shifted from mite control more to just that physiological state. Are they more metabolically efficient, consuming less honey? Are they, burning less of their fat reserves at that level closer to a natural cluster CO2? So if your whole building was at 4 or 5% CO2, are the bees kind of more at home at that sort of level?
Just that brings up an interesting question logistically about how you would manage any labor that you needed to do if the CO2 levels are so high. I mean, you really can't have people going in there, right? Because so you have to, there's a little bit of management on the people side of that.
For sure.
Okay, a couple other things. So just for the folks who want to get in touch with Andre Rousseau, who's also done some work on queen banking, he's having some difficulty with the audio. So he put his email address there in the chat. So feel free to get in touch with him. And let's see. And then another question here. How long does it take for a colony coming out of almonds to go broodless? So I assume this is a question of when you were to put it back in cold storage, that spring brood break.
Yeah, and I should preface this in that there's some variability, and I don't know exactly what that is, if it's the genetic background or what, but I say broodless, these beekeepers say broodless, but there is, I think I shared that figure, I just didn't highlight it real well, but there is a little bit of brood in these hives even then. I'll share it just real fast just because I happen to see it here. So if you can see that, so this is where we've measured it very precisely. This is centimeter, square centimeters of brood. So this is that spring one. So after almonds, after being in the dark for 18 days, they still have 600 square centimeters. So I don't know exactly, it's like softball sized patch of brood or so in there. But they're, compared to this orange graph where there's 6,000 square centimeters, you're talking about, 6 frames of brood or something like that compared to a quarter frame of brood. It's a lot less. So there's a lot fewer places for mites to hide with this. What we're calling a brood break is not perfect, and it's not across the board, right? So I just want people to know that, right away, that you're probably not going to get them perfectly broodless. It's just less brood. And it's so 18 days seemed to be what it took. So, and I think that could be optimized. So I think 18 days is enough where I think they start probably eating eggs right within the first few days, because of the lack of food coming in, and it's dark, and they probably are freaking out, and they probably eat a bunch of the eggs in there. And then you could probably even wait another day or two. So you could probably bring them out, let them fly for a day or two, and then treat. So it gives a little more time for that cap brood to hatch off. And then, but I think it takes at least 18 days. And I would be very concerned going much beyond, say, like 20 days, because they consume a lot of food when they're in there at times other than winter. In winter, they're ready. They consume whatever, a pound a week or something like that. When you put them in at times other than winter, they're consuming like a pound a day. They drop weight real fast.
Yeah. So I'm going to use my moderator prerogative to ask one more question, actually, to the entire group. I was really struck yesterday and today that timing is very important. So timing of where you are in the country in terms of when you would put bees into storage for the winter. Also timing of this spring brood break versus pollen, compared to pollination or honey production, and then the late summer brood break as well. So there's a lot of kind of management timing to consider here. I was also thinking where your storage facility is versus where your bees are also determines how practical a spring or a summer brood break. If you're coming from North Dakota and your bees are coming out of almonds, how practical is it to get them back and then take them to wherever you would go next? So I guess the question to everybody is how, if there might be an opportunity to try to pull together the research to date and better understand kind of this logistics and management across the season, depending on, several variables in terms of where you're coming from, where you're going to, and whether you're balancing pollination and honey production. If that would be a sort of useful part of guidance going forward that we could consolidate.
Yeah, and I would love to hear other people's opinions too. I'd never thought about it like that, but the first thing that I thought of when you were saying that is like it almost like some kind of decision tree or something like that, where you could put in, like your route, your process, and you could, I could imagine it being some fancy decision model support tool where you have it knows where these facilities are located, and you put in like your track and like, what your pollination route is and all that stuff. I bet someone smarter than me could do something pretty cool with that.
Yeah. it's there's definitely a lot to think through there, and that might be an interesting thing to talk further with some of the folks who've already started using this approach.
Yeah.
So if you got any thoughts on that, please enter into the chat in terms of the utility, sort of really practical, how do you manage this throughout the year? So what I'm going to do is we have another another poll and some winners to announce from that poll, and then we are going to do a video. So I'm going to turn it over to Kelly to do the poll. Here's your chance to win a fun prize, and then we'll go to another video and take a break. Oh, sorry, take a break first and then go to the video.
We're doing a video before and after the break.
Okay.
Yes.
I'm not tracking my piece of paper here, but over to you, Kelly.
Okay.
You know what we're doing.
Thanks, Josette. Yeah, hi everyone. I'm Kelly Kulhanek. I'm Brandon's postdoc here at WSU. So I am going to do a couple more polls and some videos and some prizes. But first, we did just want to take a minute to highlight some resources we have for sort of non-commercial beekeepers regarding indoor storage and overwintering. We had a lot of hobbyist beekeepers register for this event and express a lot of interest in indoor storage, and also just, smaller sideline beekeepers. So I just wanted to share that we do have resources that sort of apply to other beekeepers in this less commercial space. Just a second. There we go. So we had Kim from Hive Tech Solutions talk a little bit yesterday, and I know Chelsea's on here today, but they do have these like modular cold storage units that are available for rent that hold a smaller number of colonies. So that's kind of a really cool option for people who kind of want to get their feet wet with this. And there's a whole article about it on the Indoor Storage Guide on the Project APISM website. And then we also have a whole article about wintering strategies for backyard beekeepers. And, sometimes indoor storage just really isn't applicable, but there are lots of other ways you can support your bees over winter. So we have a whole article on this as well with this great video of Danielle and Pam talking about overwintering. So just wanted to take a minute to show you that those are there, and the whole rest of the guide is on there too. There's a lot of great information in there. And much of the stuff we're talking about in this conference will live there as well after today. So you can check back there for more resources. So with that, I will put up another poll while we get our prize winners together. And this poll is like a little bit more of a pop quiz style to see if you've been paying attention to, to the talks the last couple of days. Let's see if we've learned things about indoor storage. So which of the following is not a use of indoor storage? And then when storing colonies indoors, it's possible to enter the buildings as often, or it's best to enter the buildings as often as possible, true or false? I'll just give everybody a few minutes to answer that. Okay. So yes, this first one, this last statement is not a use of indoor storage to fix colonies that were weak in the fall, right? We've heard from these beekeepers and researchers over and over again that indoor storage is not a hospital, and what you put in, you get out. So really important to make sure those bees are looking really awesome when they go into storage. And then, yes, the second one is false. It's really best once you put those bees in indoor storage to leave them as alone as much as you possibly can. And, disturb them as little as possible. And with that, I will play our next video. So this video is about actually putting bees into storage and what the process of loading these huge facilities looks like.
Most of our beekeepers are coming out of North and South Dakota. A few of them are coming out of Wyoming, Montana, one out of Minnesota, and a few local beekeepers. This is the halfway point between here and California. So since they all have to wind up in California, this is a halfway point that doesn't create a bunch of extra freight costs for them. All of our beekeepers are going to pollinate almonds. That's very specifically tailored to them. It's a very niche, I don't know if you want to call it a market, but anyway. Each of the different beekeepers all have a different schedule, you know, and they all do their work at different times of the year and finish, but for the most part, we start October 1st and have everybody out the door usually by about the end of the first week of February. We receive bees for about 5 weeks coming in, and it usually takes us about 4 weeks to get them back out. Well, it's a Tetris game once we go inside. So it's just a Google sheet, and this building is so big and we have so many different beekeepers coming in and out that I have to have a plan as to who's going in when and in what order and how am I going to get them out the right way. This first section is 19,000. This blue section is 73, 2,100, 8,500, 2,800, 6,300, you know, so. We take care of everything. They just deliver the bees here. So the trucks show up and we have a big crew, lots of forklifts, but we handle everything on the truck. So the truck drivers pull their straps and we do everything else. So it's full service. They just send them and we send them back out when they're ready to go. This year we've got 7, running 4 forklifts at a time. So we've got kind of a ground crew and a forklift crew, but we all interact and are right there. Truck pulls in, everyone jumps off and starts pulling bungees and straps. And this year we've done more trucks than ever, but we've been averaging 12 to 15 trucks a day. The record's 18, but it takes us about an hour, anywhere from a half an hour to an hour to unload a truck. And so when you add that up, that was a 20-hour day to get 18 trucks in. We don't inspect the bees, we don't weigh them, partially in part because we don't have time. It's just in and out as fast as we can. But the other thing is that the beekeepers all understand it's their responsibility to have their health in order, and we have no guarantees. We have no way of being able to test or check health, and they all are responsible to get them fed and weighing enough weight to make it through the storage season and healthy. We just make darn sure that we've got the right climate inside the building to give them the best chance to survive.
And so these are all organized, so each beekeeper is in a long row, right? So there's not like one beekeeper behind these that you can't access now.
Exactly.
Right.
Exactly. So we do have a few where we've had to split a row, but we just leave a pretty good section between them. But you can see I've stapled names on, right? So we still have, we just finished up these the other night, so I still got to come through and I like to put a tag on the very end of the row.
Yeah.
Just so that we can tell whose bees. This is 20 pallets. Well, when they're in straight like this, they go 14. Sideways, they go 20. So that's the negative of going in straight, is I get six stacks less per row. But you can see there's lines on the floor. That's how we line up the pallets. There's 4 feet and then 1 foot and then 4 feet. And so when you flip the pallet sideways, they line right up on those lines, and it gives it a 1 foot airstrip.
Or these buildings, we space them 2 feet apart. So we've got, basically the hives are going in here like this, and they're 2 feet entrance to entrance apart, and we usually gap them about 2 to 3 inches apart side to side, and that way they're not touching anywhere side to side. If you give just a little bit of air, that really helps. They don't generate as much heat. And then we give 2 feet in the non-refrigerated, 1 foot in the refrigerated. This building will hold about 7,000 hives. We're on 5 foot, so there's only a foot between the entrance to entrance instead of 2 feet. So basically in the non-refrigerated, we're going 2 feet, and this one we're going a foot. There's still a foot between the entrances, and then we try to leave about 2 to 3 inches between each stack, so where they don't touch is ideally what we're shooting for.
The building is the air system, right? I mean, it's the way the whole building is part of the way it was designed and laid out is to move air. And so we stack bees in rows, and they actually help funnel the air past each other.
And they're stacked in, so the entrance is face away from each other, and the airflow blows across the front of the edges, not into the entrances. I guess is part of how they're stacked.
Yeah, and just really tall.
Yeah.
The taller the building, the cheaper the whole project gets. As long, you can only stack, we've stacked 9 high. I haven't ever stacked, yeah. Well, you still can go higher than that because you just pick more of them up, yeah. So you bigger forklift, the woodware, we're confident with 9, but stacks start to get a little bit wobbly. So at 8 is just our comfort level. With double deeps, with story and a half, so we go 9 high. And that's a little over 18 feet tall. So it's 18 and a half right at. They're stable at that distance as long as the beekeepers have good pallets and good boxes.
Yeah, if you got a rotten pallet or something on the bottom and
Oh, it happens all the time. Well, we learn, pick those out and put them on the top. Put your good ones on the bottom, yeah.
I've got a few in here, 8 high, just so we'd have a little bit of room right here. Just as a test more than anything. We could have came out, but I went ahead and put a couple stacks up 8 high to see. But everybody else stacks them 8 high. I don't know, we're chicken, I guess.
What really helps us is just the condition of the equipment. So strong pallets, not broken boxes, lids that are nailed down or have lips on the sides, things like that help us not have accidents. And after we're done filling the buildings, my days are spent watching them online. We've got computer controls so I can monitor remotely. A lot of it is coming and just checking on the refrigeration system. I just have to be 100% sure that we're never getting warm inside there, and that the climate is being controlled.
Make sure you put mouse poison out. It's important.
Lots of mice come in on the pallets, so they come in with the bees. The nice part is most of them go back out with the bees because they stay in the hives.
So this is just the control room for this storage. You have individual manual controls and shutoffs for each fan, along with our touchscreen system that monitors temperature, CO2, RH. Set points are showing the same. Everything that's happening inside the building is on the app, showing in real time. Any adjustments that are made here, we can be made on the app. So again, it's peace of mind that he can see and monitor wherever he wants to look at things.
Cleaning. So do you clean dead bees during storage, or you just once they're in, closed in, don't touch them, don't touch them?
No, we don't. No, we don't do anything. We sweep ahead of this forklift when we're loading out, but when we get these things full, I do not spend any time in here at all. It's better just to leave them alone.
It seems to be a lot easier on the bees if we just don't move them. Just leave them alone, stay out of there, just let them stay asleep, enjoy their vacation so we can enjoy ours.
Okay, welcome back from the break, everyone. Okay, and I'm going to play our last video. This one is about what you're doing while your bees are in storage and after they come out of storage.
I am Tom Browning. I'm a co-owner of Browning Honey Company. We are in Blackfoot, Idaho at our storage facility for the bees in the winter. It is mid-January. It's about 24 degrees outside today, and we are shipping bees to California.
Typically there's about 408 hives on a truck, and in our operation that means we're going to ship about 60 to 65 trucks to California for pollination.
Coming out of the building this year, it looks like we've lost between 12 and 14%, which is about average. We'd love it to be less, but it is what it is with the mites and other things that we deal with. Just have more loss. So.
Look on the screen, the brighter colors mean they're alive, and you go to this one, it's all dark.
Yeah.
So you can tell which one's dead.
How often do you find those?
It just depends. Maybe 1 out of 12, maybe sometimes.
No, we don't do any sorting. If we're like today, we're finishing up. We're sorting now. We don't do any pre-sorting. We just load them and go and pull the dead out. So we usually can keep it 10% or less on our, and so is what we call out for what we like. If I ship 10,000, I can usually put 9,000 in the almonds, and so it's just easier to deal with it down there. If I thought I had 30 or 40%, you might want to start sorting. But realistically, I should know that right now.
There's a decision in which we look at that hive and decide whether it's actually viable or not. It's not worth it to ship a hive that isn't going to be able to grow. But a hive that is going to be able to grow might be needed if there's a desperate shortage here for bees in the almonds. But more importantly, that's a resource that we want to continue to grow if we can. So we'll put them in an area where they're going to have the benefit of early sunshine, as compared to the Idaho desert that won't bloom until probably 1st of April. Here we can get them into a warm climate and start feeding them and nurturing them back to a more healthy state. Another benefit of storing the bees in the sheds is getting that broodless period that is a result of 90 days of darkness. It's a good natural varroa control, and often it means that we don't have to treat for varroa until maybe May or even June.
With this building, you have the temperature controlled, so there's really zero number of days where bees are flying. And so when the bees are flying, that's when they go into other hives to rob those colonies or to look for food in other hives, and they carry those kinds of diseases into their neighboring hives when they're stored in large holding yards outdoors, say in California, for example. So these situations where they're stored indoors generally reduces the transmission of diseases or the movement of varroa from one hive to the other. And I think that what we'll find is that the virus transmission is much lower in the buildings, in addition to the growth of varroa mites. Because the other thing is, like you said, when they're outdoors, a lot of that cost is feeding during the winter. And when you're feeding the bees, they're generating brood. And when you're generating brood, they produce more mites. And so in the buildings, they do not produce much brood at all, and so the mite numbers aren't growing during the winter, which is an additional, health and cost savings for beekeepers.
The way we have them laid out, bees from different beekeepers aren't touching each other. There's spacing between. A lot of that's simply for airflow, but the other part of that is because of that. We don't want any beekeepers to worry about who their neighbor is inside here. And after we're done filling the buildings, my days are spent watching them online. We've got computer controls so I can monitor remotely, but really we try and stay out of the buildings. We just leave things alone. We're not in cleaning or doing different things. We've learned that every time we walk in that building, even if it's with just our little headlamps, it disturbs them just a little. And when you disturb them, bees fly, and so there's that many less.
I don't like to mess around in here when they're full. It's better just to leave them alone. In my opinion, this is just my opinion, but you're just giving stress. I mean, they're gonna break cluster. If you flip, I'd flip the breakers. When we get these buildings loaded, we flip the breakers. You can't turn the white lights on. Sometimes I'll even flip the breakers where you can't turn the red lights on, so nobody can come in here and turn a light on or anything. So we come in with a flashlight, do a walkthrough every once in a while, just make sure. But I just don't like messing with them because it seems like if you just leave them alone, they don't break cluster. They just stay in there, do their thing.
In the middle of December, the California and Idaho State, their inspectors will show up and we'll go through a bunch of the hives and they'll pre-certify them, and they are looking for any signs of noxious weeds, hive beetle. It's still a pretty new program, so not all of our beekeepers are doing that. Mostly that's me trying to select the beekeepers that will pass, kind of doing my own pre-inspection. We've got 7 or 8 of them. You know, they've taken the time to get the weeds and the dirt and all those things off their pallets, done a good job of cleaning their equipment before it comes in here.
Yeah, we didn't do it last year. I was a little concerned with doing the pre-inspection because I didn't want to spend a week inside one of these buildings that was loaded with bees and lose the quality. Having said that, I guess they came in relatively fast and inspected them without any issues, and so I think I am going to have this building inspected this year, pre-inspected.
That's a good point. I mean, so, you know, as far as like the best management practices, or to call it that, you know, I mean,
Yeah.
that inspection service
Well,
probably happen maybe during the loading or unloading, because like you said, it seems to be really important to not disturb these
Exactly.
bees once they're set.
My concern is if we have 12,000 hives in this building and we spend 2 days in here trying to get pre-inspected so we don't get one load hung up at the border, what did we gain? You know, we screwed up 12,000 hives to gain not having. Now, how if I get one hung up on the border, you know, it's 400 or 500 hives, and it's an inconvenience, but it's not as big of an inconvenience as trying to find 12,000 good hives to make everybody happy. And so that's, but I was told that they came in and they were relatively fast and looked through them. So I'm gonna go ahead and at least probably get this one inspected this year.
We had Idaho and California bee inspectors come in December and inspect these bees here on the ground so that they're pre-inspected when they go into California. It's a new program that we started last year. California and Idaho Departments of Agriculture are cooperating with each other. I think North Dakota is also cooperating so that we can relieve the congestion at the border. You'll see that when you get down there. There will be loads that are not inspected. They'll be sitting there for a half an hour to 2 or 3 hours before they can get inspected. Our drivers will be able to go in with their paperwork, get the paperwork entered into the computer, and they're on their way in about 10 minutes.
Over the last 3 years, we've been experimenting with moving bees back into the sheds following almond pollination. The primary reason is because there are not enough good holding yards for the bees to go to after almonds. We are a tenant of the world that has been created for us, and the bees are too. So they've been moved to this environment that is a monoculture primarily, and there is not enough natural forage available to support the stocking rate of hives that these almond trees demand. So if we didn't take care of them, they would not be able to take care of themselves.
There's just a few little places left, but they're crowded now. I mean, yeah, where we used to run bees in North Dakota, I mean, you used to put 32 hives in a yard and there wouldn't be another yard for 2 miles. Well, now there's 64 hives in the yard and there's somebody across the street's got 64 and then there's somebody over here's got 128. I mean, there's bees all over. And the same thing in this valley, same thing in California. There's no place to run. I mean, there's no place to hide. There's just a lot of bees and there's just not enough forage for them.
Okay, so that was our last video. It's now time for our next panel. So I will turn it back over to Josette to moderate our next panel.
Thanks, Grace. Appreciate it. Or sorry, Kelly. So we have a final panel and we're going to focus more on best practices related to the physical facilities. So we'll call back Brandon Hopkins, who you've heard from this morning, Nick Noyes, who was in the video we just saw and was also part of our discussion yesterday, Anthony Molitor, who's the HVAC specialist, and then Jason Miller, if he's available, may join us. He is another commercial beekeeper. Many of you probably know his father, John Miller. And he has been using indoor storage in their operation. So another chance to get a beekeeper if Jason isn't busy taking care of his bees right now. So great, Nick and Anthony, just waiting for you to join us. And while Anthony, there we go. Before we go into this last panel, I just wanted to reiterate something that Kelly mentioned before the break. The whole goal of this 2-day conference is really to share the results of all this research combined with practical beekeeper experience to equip those of you who are considering the fit with your operations to have the information and answers that you need to make those decisions. And so really would be very interested to hear from folks in the audience, not just how this particular format worked, but if there's some specific things, some tools, practical guides, like there's this great indoor storage guide on the Project APSM website, but also, would it make sense to put together a decision tree that helps beekeepers around the country look at for their location and their combination of pollination and honey production? How do you think about timing of all these different nuances that indoor storage can help? So if it's that or more economics, understanding return on investment for different uses of indoor storage, for queening, for overwintering, for brood breaks during the season, anything like that, we'd love to hear from you, because our goal, speaking on behalf of Project APSM and the Almond Board, is we're not only just interested in funding research, we want to make sure that research is translated into really practical tools that you can use. So think about that, and definitely look forward to any comments in the chat or at the end of our day today. So going back into our panel here, this is really meant to be a discussion more than a series of presentations. So I'm going to kick it off with some questions, and love to see you guys enter some more in the chat. We've had a robust discussion so far today, so hope it'll continue as we come into the home stretch. Oh, Anthony Molitor, Anthony's apology. I've been reminded that you haven't joined us yet, so maybe I could just ask you to introduce yourself. And you've been in the videos, but maybe introduce yourself, and that will help us hone in on some questions for you.
Yeah, no problem. Thanks for letting me be part of this party. It's been informative for me, learning a little bit more each time I get to talk to Nick and to Brandon and everybody that's doing the research for this. So it's been good. My background, I've worked with industrial ventilation now for 10 years. Really kind of, as Brandon mentioned, a lot of this stuff has come about from potato and onion storages. And that's kind of what our company focus had been for 40, 50 years. And 4 years ago, Nick gave me a call and said that he had gone into an onion storage about a mile down the road from him, and said that he and his dad were looking to incorporate some different things from that facility based on also some of Brandon's research. And it's kind of turned into a whirlwind since then. We started working with a lot of different commercial beekeepers and also some smaller ones, just doing a wide variety of different facilities, from a brand new fully refrigerated storage like Nick has with a concrete air floor, to existing small buildings to accommodate 500 to 1,000 colonies. So I've kind of been full spectrum, doing a little bit of everything, but taking what we knew as a ventilation and refrigeration company and applying that to the information that Nick was able to give us and other beekeepers. It's been a good process, and I think we've been able to help a lot of people be more successful getting their hives out to California in January.
Great. Well, maybe I'm going to pick up on that, Anthony, and get the conversation started by asking any of you to weigh in on this repurposing of existing facilities. So there's loads of packing and storage for fruits and vegetables in the Western US. And while apples may stay in those almost year round, I happen to know that in California, we have some produce that doesn't sit around in these kind of facilities, whether it's, fresh market tomatoes or peaches, cherries. Oh, great to see you join us, Jason. Thanks.
guys.
I'll let you introduce yourself in a second, but just to kind of put out to the panel, is it just sort of hit and miss if people can identify potential existing facilities that can be repurposed? And then a second question, and maybe any of you could answer this, but particularly you, Anthony, sort of what is the difference if you're taking a produce facility and repurposing it for hive storage versus a new build from scratch? Is there major differences in terms of the cost or in terms of the availability of expertise to do that retrofit? If you could speak a little bit to that.
Yeah, so I mean, a big thing that you really got to think about is on an existing facility is what constraints you might have in the location itself. So if it's an old, let's say just an old concrete building that was once used for holding whatever, but now it's been, because of population growth, now there's houses and everything else all around it. You can only do so much remodeling in that because of now setbacks because of the population in that area. So you're limited on what you can put into that storage or that future storage in terms of airflow or possible refrigeration and things like that. And with that, power is going to be the biggest, probably one that I would look at. Is if it's been an old facility that was built 50, 60 years ago, it might only have single phase power available. And a lot of newer equipment is all 3-phase, and 3-phase power or equipment is a lot cheaper and a lot easier to come by. So those would be the first two things that I would look at if someone came to me and said, hey, I want to do something with this building, put X amount of hives in there. Okay, well, we need to go through and look at it, site plan, and get an idea of what we actually can do. If they say they want to put 2,000 hives in there, but they only have enough power for 500, well, it's either them having to spend the money to get more power there, which is not cheap in any state, or settling on saying, okay, I can only put 500 here, and I might have to look for another facility somewhere else to accommodate the other 1,500.
Great. So maybe honing in a little bit on power, and then I'm going to come back to Nick and Jason to ask some more questions about retrofit versus new build decisions. So how do you measure the electricity? Is there a way to understand like the kilowatts or per hour, per hive, or per square foot, monthly costs? Is there a way to give us a sense of what that range might be?
And that's exactly what it is, Josette. It's a range because it depends on what you're trying to do. If you're just looking at moving air and using an ambient storage, then it's going to be scalable based on your location. Everybody knows it's cheaper everywhere but California to do something. So I can't, Idaho, where we're at, is roughly 6 cents a kilowatt hour. So you're going to base things off of that. And then again, based on how many hives you might have, you're going to have a scalable measure of how much power it might be in order to keep bees around 40, 42 degrees in an ambient storage. You need X amount of air for X amount of hives. And so that line is going to be fairly linear as it keeps going. There'd be a point of diminishing return, but it's hard to give an exact number because it's so regionally and state based that and if you go some places like Washington State, it's county to county. So you can't give an exact number where it's, every state is that different.
Great. Nick or Jason, do you want to jump in on the electricity aspect or on the question of retrofitting versus new build?
I could talk about electricity. So yeah, we had to bring in 3-phase power, like Anthony was talking about. Because the current provider did not have it. We used the figure of 20 watts per hive. Somewhere in that 15 to 20 is kind of a rough number to look at. So we really did our calcs on 3 different factors. What is the airflow that our air handlers can push? And then what is the cooling in the BTUs that we've got? And then what is just the space of the building? And so we kind of ran those 3 numbers, and that gave us 3 different capacities for our building, roughly ranges. And we are most limited by the cooling capacity in ours. So using 20 watts a hive allowed us to narrow down what we were going to need in BTUs and do that conversion and come up with the capacity, the cooling that we needed. As far as costs, we're in North Dakota, it's similar. I think we're 7 cents a kilowatt. Our building, when we're running pretty much full refrigeration, we go in really early, I think earlier than most. October 1st is our goal for starting to load. We can't do that every year. This year, the weather was very warm, early October, so we didn't start loading till the 12th. But in that first mid-October to mid-November, we're pretty much running refrigeration most years, 100% of the time. And that costs us about $15,000 a month to store 15 to 20,000 hives, depending on the year. So just rough numbers, 15,000 hives cost us about $15,000 a month at full. That's when we're not able to utilize any ambient cooling. And obviously that gets way cheaper, down into less than $1,000 a month once we're utilizing the ambient air to cool.
Nick, you want to weigh in on this?
Not really. I don't have those numbers. Sticks in my mind that.
Sure.
Yeah, I don't have that.
Could you maybe talk a little bit about, if I'm correct, you actually retrofitted some older buildings from potato and onion storage, and if you encountered any challenges doing that, or if that was a great fit for your area versus building from scratch. And then I'll circle back on that to you, Jason, because you guys have a highly well-designed facility that you optimized. But Nick, want to talk about that?
Wasn't me. We built all ours from scratch, just
okay.
bee storages. So years ago, back in the 80s, late 80s, did use kind of before my time, I was pretty young. They did use an Apple facility, but I'm not sure if they did any retrofitting or just 2 or 3 winters we did. But I've been around them, but I've never actually retrofitted a potato shed or an onion shed. Anthony could probably touch on that.
Yeah, I've seen, we've had some different people that have used some existing potato storages, refrigerated and not refrigerated. And there's really not any on that type of thing. It's already a forced air system. There's not really any retrofitting that's done. It's laying out, and a potato storage, laying out the ventilation pipes between the hives and loading it very similar that you would a potato storage. We have one guy that he using an old chicken coop facility. Again, there's forced air though. There's fans that are available for moving air. So I think that's going to be your bigger thing. If, facilities that already have a forced air system of some kind, even if it's very old and it's not a lot of air, it's better than not having airflow at all. So that's where a lot of these retrofits, will come from, is finding places that no longer store potatoes or chickens or onions or whatever, and making use of that system that's already there. And like Jason said, if you got to bring 3-phase power because of the amount of hives and everything else, then you're bringing in power.
Another question from the audience. I don't know if any of you have looked at or any experience with use of solar as your power source. I'm thinking maybe some of the folks who have these facilities in California, that would seem like an obvious opportunity. But anyone have any thoughts on solar? Nope.
Those California guys, I think those storages have solar on there. I think it supplements a little bit, but yeah, that would have been a good question for those guys.
Well, and again, we've seen it in other storages where, it's a viable option. In most states, there are government rebates and incentives for putting on solar. And every state again is different. I know in Oregon, and it used to be in Idaho, if you included solar on a brand new build facility, there is a lot of money available immediately back for doing that. Now, again, like Jason said, there's a lot of power involved, and the amount of solar that you would have to put on there to try and offset that, I don't know if that's a viable option, but like Brandon said, at least cutting into some of those power costs, if all of a sudden 15,000 turns into 10,000 or whatever that number is. I mean, obviously that's money that can be used in other areas.
So
Yeah,
I
some of
see
that-
both Brian and Buzz are in the audience, and maybe I'll just pause for a minute and see if either of them wants to unmute and weigh in on this.
Good.
I got you, Buzz. You started there.
Yeah. I had to bring in a new service. I had already the three-phase powered, but I brought in a new service. So I was limited on how much electricity I have to use for 3 years, and then I can put up a solar project. That was my contract with PG&E, as they paid for half the cost of giving me that new service. So, but yes, I plan on putting solar to offset that electricity.
Yeah, and I will say that this is Bryan, that I did not put any solar in on our deal. Even though I think if you were to go much bigger and go, get more into it, definitely need to look into offsetting costs.
Great, thanks. Another question from the audience. Jason, you guys have operations in a few states. Did you compare at all the cost of locating your facility in California, Idaho versus North Dakota?
Yeah, we actually mostly looked at Reno because we're right near the border in California, in Northern California. So we looked at doing Reno, but really one of the biggest bottlenecks, California is just so expensive. And so we did briefly look at that, but felt like the warm temperatures when we wanted to go into the building were not going to lend themselves well to that. And then once you're on the other side of the pass, you're going to have a lot of the same difficulties. If we're going to have problems shipping, it's over the Sierra Pass and we'd still be on the wrong side. So North Dakota or right over the border in Reno was going to present similar obstacles during bad weather. We chose North Dakota. We used to do Idaho. Our old model was we shipped to the southeast region of Idaho, put them in potato cellars, and we've been doing that for over a decade. When we looked at building our own facility, a lot of what we weighed was this low touch beekeeping that we've gone to, where recently there was an article published about it, so I won't go too much into depth, but we have gotten rid of the hub and spoke model of holding yards and moving our bees a lot of times for various reasons. And so we wanted a model where we could go straight from the bee yard, touch them one time into our facility, touch them one more time into the almonds. So 2 touches from where they spent all summer out foraging to in the orchard placed where they are for pollination. We used to do approximately 7 to 10 touches under our old model. And we just found that equipment, queens, hive mortality, stress, frame counts, everything has gone up dramatically, not only in having this dedicated winter storage building, but then combining that with the low touch beekeeping that we do, really pushed us towards, we want to build it right where we are so that we can implement this model.
Thanks. Maybe if I can touch a little bit more on that, the number of times you move your bees, and ask both Jason and Nick. Brandon talked about things like a spring brood break or an August brood break as a potential way to further control varroa, maybe a little bit of cost containment on aspects as well. Given sort of where your operations are, could you just speak a little bit to the feasibility? I mean, I'm not necessarily asking if you've tried it, but what is the feasibility given where you are coming out of almonds and where they're going next to put them back in those facilities in between?
And microphone.
Ryan, you can be in there too, Ryan, if you want.
Come on over.
I didn't realize the camera was on.
What was the question? Sorry.
Sorry. So how feasible would it be logistically and financially if you were to try a spring brood break after almonds, because you have to get them back inside the facility. And so for your particular operation, coming out of almonds, trucking them back to put them inside the facility, and then wherever they go next, How feasible would that be logistically for either one of you, given your particular operations?
For us, it'd be real feasible on the stuff that was going back to Idaho, but the stuff that was going to Texas, obviously it wouldn't work at all. We would need to build another building in Texas to do that. So biggest thing I did is basically if I had a huge mite problem, then I would definitely want to use that brood break situation to solve it. But ideally, I won't have to use that. I mean, that's the ideal scenario. But it's kind of a backup plan is to use that as a plan B or C.
Great.
Brandon talked a lot about the high consumption that happens in the spring, and that's what we experienced. We have done some springtime, but the hive consumption is the honey consumption is so high that we have not had good success in any sort of long enough to really get a good brood break. So really our building, there's been a lot of discussion about other uses for the building. The only two other things that we utilize it for is in the spring when we're shipping and weather conditions are really poor for getting our bees out into the field. Again, in that low touch model, we don't want to unload in a holding yard and then move into larger pods and then move into smaller pods. We want to go straight from California into our end yard of North Dakota. So if we can't do that, then because it's rainy and muddy or, blowing super high winds, we'll pull semis into our building, let them sit for 24, 48 hours, and then move them out into orchards. Ironically, we hold a big landowner dinner in our building every fall we invite all the landowners. So beekeepers, you're familiar with paying your rents and taking honey around to your landowners. A few years ago, Ryan started this landowner appreciation event that we invite all the landowners into our building. We host a big dinner and give them their rent and do tours and talk about what we do. So that's something that hasn't been mentioned, but we do use our building for that as well.
Great. We have a couple of questions again about Varroa treatments before you put them in the building and then while they're in there. Is there anything that you can use for treating using Apivar strips or oxalic acid pads? And then kind of also related to this, Nick in the video yesterday showed that hives that had brood chambers were cracked open and were being sprayed. What were the beekeepers looking for? And what were they being sprayed with?
Basically cracking them in half. If that shallow was light at all, or that medium was light at all, they're giving them around a feed, and then they were spraying them all with oxalic acid. We spray them all right as late as we can wait in the fall, which is, we're done, got them all done. And then we hit them right when we hit the ground in California. After they've flown 3 or 4 days, we'll do the same thing, hit them with oxalic one more time. It'll only kill the mites on the bees, obviously, so it's not getting the ones in the brood, but we wait as long as we can in the fall and then try to hit them again right when we get to California. Ideally, hopefully knock back them mites.
Jason, do you want to comment on any Varroa treatment going in or coming out of? And then Brandon, if you have anything to add to that.
Yeah, it's been mentioned a few times that if your mite levels are high going in, it's too late. So we get them very low. We have found that with the building, the mites, what few that remain, because you're always going to have some either resistance or not uniform application or time, it got late in the season, you weren't able to complete your treatments as you would have wanted. There's a number of factors where you're going to always have some that have higher mites than others. And we have found that the building definitely helps keep those numbers really low coming into the almonds. They're super low. Going off of Brandon's research, we didn't want to run any sort of trials on our whole operation. But we were curious what the upper limits of CO2. Our building is very, very tight. And so we can achieve super high levels of CO2. And so the past couple of years, we've been experimenting with that, holding our bees at 50,000. So Brandon talked about 80,000. We hold our bees at 50,000 when it's warm and we're not able to utilize free cooling outside air. And we do that anywhere from a week to 10 days. at this 50,000 level. And again, no employees going in there, alarms going off, audible, visual, that you will sleep for a long time if you hang out in the building at these levels. So I want to make sure that's really clear, that those are not safe levels for humans. And we have found that our mite counts across the board this last year were all zeros. We've never had that. We've had low coming out, but when we did a bunch of trials coming into the almonds, they were all zeros. Unfortunately, we don't have a control to say that's what it was, right? So, it's not ready for scientific publishing, but we're doing it again this year. We've been at 50,000 for 10 days or so, and it's finally cooling off out there. So, how much of a factor that is, I don't know, but we used to always have some number of mites. And with this high CO2 that we've been running the past couple of years, we seem to be getting zeros across the board.
Yeah, that's super interesting. I mean, that'd be cool if that ends up being part of why there's zeros for sure.
Yeah.
I was just about the treatments, I was gonna talk a little bit about the treatment in the buildings, because that is while using in the buildings, it looked like part of that question. And so there was some work, now the name's escaping me, but it was out of Canada, and they fumigated these small chambers, kind of added maybe a couple hundred colonies experimentally with formic acid while they were in storage in the winter. And I think had some success. I think there's always the issue of queen losses and things like that with formic. I think the big part of that problem is that those products aren't labeled or registered for that kind of use, and explicitly, like oxalic acid is labeled, for not being used indoors or fumigated indoors. And it's, on the scale that most of these guys are at, it seems, almost impossible to imagine treating an entire building. But, that would be wonderful. I mean, like you just talked about labor costs. I mean, I can't imagine the savings there would be for labor wise if you could treat 15,000 hives in a single shot. So it would be great if there was something like that. I mean, I think the biggest thing again though is that they need to be cleaned by September, really. I mean, it certainly helps out the next season, especially when they come out. They're going to be producing a lot of brood and ramping up really fast. And so the cleaner they are in January and February, the better they're going to become honey production, and it all trickles down. But I think, I think it's tough. I think they need to be clean going in, and then like Nick said, maybe the next best thing you can do is give them a flash sort of treatment like the oxalic dribble coming out when they're generally kind of at that lowest brood level. We had a project with Project APSM looking at fumigating with formic acid kind of as they're being loaded out of buildings. I think and it had some success, but I think that you're busy trying to get truckloads out and trying to mess with them in the building and doing all that is, I don't know. I didn't really see the labor savings in trying to do that in the building while you're trying to hustle out of the building. But
right. Well, and I'm just struck by, the whole point of one of the benefits of indoor storage is this brood break and varroa control. So if you've done a pretty good job going in, you should be in decent shape coming out, and that's why you put them in. A follow-up question to you, Jason, was last year when you had zero mites coming out, when was it that you did your first treatment?
So typically when we're making splits in April, we start to really see that the mites are building up. And so we're usually pretty anxious to get treatments going in May. We saw very low levels while making splits, lower than we've ever seen. And so we did still treat in the spring, but it wasn't with nearly the mite pressure that we've had in the past. And we've been experimenting with the oxalic pads and doing some of that. So, again, it's hard to really draw a lot of strong, tight correlation to, well, it was, cause and effect. But because those counts were so low, they stayed very low. Now, it depended a little bit on the almond orchards that they went to. We're split up all the way from Chico in Northern California to Madera in Southern, Central. So depending on how close we were and where those bees landed, and we had different levels coming out of the almonds. And so we were surprised by how clean they were, though, still in April when we were making splits.
Great. Question over to you, Anthony. Jason talked about the putting into practice some of the research around getting the CO2 levels high as a Varroa control. Can you talk a little bit about the building itself and the HVAC system? How common is it that the buildings are sealed well enough to be able to do that? What kind of special or different HVAC considerations you'd need in order to be able to do that?
Okay. I mean, any new building anymore is going to be pretty tight. I mean, I think the only time you'd really have an issue with any sort of outside infiltration would be on an existing structure that you're trying to retrofit. Any new build, there's going to be plenty. I mean, it's going to be tight enough that as long as you have good seals around truck doors and man doors, just the respiration of the bees themselves are naturally going to build up to high enough levels that you could accomplish that. And it happens fairly quickly, especially if you have, at a commercial beekeeper's level. I mean, if you have that many hives in there, you can get up to 50,000 parts, very, very quickly, as long as no outside air has been introduced to purge it.
And then in terms of the monitoring systems that are used, can you easily monitor those CO2 levels? Are there warnings that could go off if they started getting too high and you need to vent the building? Is there any special equipment you would need in order to play around with CO2 level management?
Yeah, I mean, that would be built into the control system. So with ours, you can manage it with, there's several different CO2 sensors out on the market that you can go from 5,000 parts per million up to 80,000. That just costs money, and how high you want to let that go, and then that's tied into the control system. And then based on where you want to put those levels, if they reach too high, then you can set it up to set an alarm, and so that, or you could set it up to where when it reaches whatever level you determine is too high, the system would naturally purge itself and get that back down below that threshold level. So that's all going to be tied into the control system that you would put in that storage.
Great. We had a question before the break, and I see it's repeated here, about humidity levels. Is there an ideal humidity level, or how do you, any proactive ways that you've had to manage that?
I mean, based on what my discussions with Nick and Brandon have been, as long as it's, a cluster itself is going to create quite a bit of humidity just by itself. Just like if we're in a very small room and there's 1,000 people in there, just us breathing is going to create a very humid situation. It's no different with bees. Because we're looking to provide as much oxygen as possible in a lot of these scenarios, humidity never really becomes too much of an issue. I think as long as it's, below 85%, then you're probably pretty good. You start getting above 80% in any scenario, any sort of storage scenario, that's just a chance for high heat. With additional heat and high humidity, you're going to grow molds and different things like that in those scenarios. But again, I think, where Jason is in North Dakota and Idaho, and these places where overwintering occur on a commercial level, it's never an issue, I don't think.
It's pretty dry. Maybe a question to Brandon, Nick, and Jason, going back to something that came up this morning. If you could talk about the weight of colonies that went into cold storage and then to almonds versus those that went into cold storage and then didn't go to almonds. Do any of you not send yours to almonds? And is there a difference in the weight? If you if you put them in cold storage and then go somewhere else? I take it you all go to Almonds. It's good for me. So that would have to be an experiment, Brandon. I guess you said you send some to apples though. You did some experiments that went to apples first, not to almonds.
No, well, I might have said that, or if I did, I misspoke. They went to almonds first, then to apples, then to do that little indoor storage break. And those are the ones that, were too light to do that with. They needed to be heavier and that kind of stuff. But yeah, even our little research program goes to almonds, so I'm not going to be much help there either.
I'm not going to complain about that, since we want the best bees to come to almonds, and it seems like you all are given some very high quality bees.
Yeah, I mean, these guys know better about the weight though. I mean, they need to be heavy going in, just like even if you were wintering them outdoors, they need that honey to make it through. I think Jason might have some good examples of, I think there's some logistics to not having them be too heavy. But,
yeah, we do. So we have a hive scale in the building, and we record those weights over the time that they're in there. We found that even what we thought would be too light have still survived. Hives that are going in at just over 100 pounds for a 3 to 4 month period have been surviving at really higher than we would have expected rates. That 1 pound a week is a good number. I'm just pulling up our hive scale from last year, and we seem to average about 0.9 to 1 pounds a week. It's higher on the front end, and then it tapers. But we're storing for pretty long periods of time. And we'll go in 1st of October, and then some of those hives will be in there all the way till the 1st week of February. So a solid 4 month period. And we usually try to hit that 120 pounds in that range. But it is surprising how little, when you get them at that ideal temperature, I think that 1 pound a week is a pretty good number to shoot for. If you're able to hold them at, 40 degrees, obviously that's going to go up the warmer it is.
And do you, just as a follow-up question, Jason, in addition to the weight you're monitoring, what do the frames look like of bees? I'm assuming it correlates with the weight.
Yeah, so we try to take a broad spectrum of hives from different areas and get them all on this scale system. And so, yeah, we want uniform, strong colonies, but then we don't want to skew. So we just randomly select for our ones that are scaled, so that we know that it's just a random selection in the building. And it's a scale that can take many pallets worth, so we get a good average.
Great. Let's see, very practical question. What about repair? If something goes wrong, do you have backup power like a diesel generator? Have you ever had any challenges getting an HVAC person back out there if something goes wrong?
We run diesel generators on all the buildings. So basically just like a hospital generator, if power is to go out, they automatically kick on and start running the fans. And then IVI, they're an hour or less away. If there's a HVAC problem, they get notified and I get notified. Somebody gets there, gets it fixed.
Yeah, and I can tell you, from my experience that with these little refrigerated cargo containers, and I didn't have an IVI person, it was a nightmare. And I didn't really, and the way that these cargo containers are maintenance, it's like some kind of, they have their own little zones. And so trying to find somebody to come out and work on this cargo container it took a couple of days to get somebody out there. And it was a bit of a nightmare. So it's a major point to have a good partner, and have somebody locally who knows the system and is ready to come out. You got to have that person all lined up probably before you even build the building, I would guess.
Mm-hmm. Yeah, a good refrigeration guy is very critical, and we're very remote, so ours is over 2 hours away, but he will drop anything and come if there's an issue. We designed our building so that we could lose one of our 4 compressors and still feel like we have a pretty good margin. You know, temperatures may go up, but if it's completely dark and you can get fresh air in, then you're not going to kill your bees. You know, the problems are going to be if you got a bunch of light coming into that building, like you need to open up doors to introduce airflow, then you got problems because bees are going to be crawling out and those losses will get very high. But if you can keep it dark and still move air. So when we designed our backup generator, we don't have backup for 100% of our cooling. It's only about 30-40% of our cooling capacity is on our backup generator. And we factored in that if we can keep them with cool air coming in and keep them dark, we can withstand what is a typical 2 to 3 day power outage. Typically in North Dakota, those power outages come from ice storms in January where it's very, very cold. And therefore, we're pretty much cooling with just ambient air at that point. So we didn't size ours to run 100% of our refrigeration.
Anthony, are you getting, you have a pretty good relationship, I presume, with any of the folks that you maintain their systems?
Yeah, and that's kind of, you know, again, that's, I think one of, like Brandon said, I think that's, as you're going through this process of if you're building a new storage or even an old, you know, retrofit is looking how stable the power is. And like Jason and Nick have said, you know, having someone that's relatively close is a big deal. You know, we designed the storages that at very least, like Jason said, we're gonna have airflow. I mean, these overwintering storages are, you know, the majority of the time we have cool enough air that, yeah, you're not going to kill the bees. As long as there's enough, you know, you have a generator that's going to keep airflow going and getting oxygen to a living animal, they're not going to die. But that being said, you also don't want it to get it to 60, 70 degrees. And then, you know, bees start waking up and they're ready to go to work. That's not, you know, in the middle of December, that's not the point. So, you know, time is of the essence. And so getting somebody there as fast as possible. And for us, it's been fortunate because in all of these areas, we actually, for us, we have, you know, sales and service offices in all these locations. We have them in North Dakota, we have them in California and Washington and Idaho. So we end up being able to service a lot of these areas just kind of by default now because of, again, doing other vegetable storages for so long. So it ends up being beneficial for, you know, whether it's our stuff or somebody else's or, you know, people, I mean, a farmer's a farmer. I think whether it's a beekeeper or a farmer, they've built stuff on their own and we can, you know, if it gets to the point where people need help, then we can come and help. But that's definitely a consideration is making sure that, you know, you get things fixed in a timely manner.
Right. Can any of you talk about experience wintering 5-frame nukes indoors? See a lot of heads shaking. No one's tried that one yet.
But yeah, we've done singles. We've done what we call mods, where it's a deep and a shallow. We've done, most of ours are double deeps. We had good success with all three. Probably one of the best are the mods with the deep and the shallow, but the double deeps is what we run. And so those work very well as well. The singles can be a little bit tricky, having enough weight to make it, but then not pinching down that queen to where she doesn't have room to have enough of brood hatching off going in, getting that weight up enough. Singles were a little trickier for us to overwinter, but we have not done any 5-frame nukes.
Do either of you?
There's a few folks in New York or Vermont and up in Canada that have success with wintering 5-frame nukes. So I think people do it, but
yeah, have any of you found a sort of sweet spot for the size of the hive, the number of frames that's most economical, or the number of frames per, I say actually size, meaning probably not frames per hive, but number of hives?
Yeah,
has
maybe
anyone looked at that?
I saw one question about the frames of bees going in, but I mean, for us, we want them as big and strong as possible, really, as long as they're heavy enough.
And coming out, they're pretty fat and healthy, right, Brandon? That's what your research has shown. They're not going down in size.
I saw that question and I was gonna see what these guys thought as far as, how many frames of bees going in compared to how many frames of bees coming out. And I feel like I'm gonna screw it up if I share my screen, but that was one thing, that was interesting from our partnership with that project with Bee Informed Partnership. And that I was just looking at the numbers here again, and this is 2 different operations, but it looked like, say, right before they went in October, it was an average of 12 frames of bees going in, and then post winter in January coming out, the indoor storage group was like 12 and a half frames of bees coming out. So there's almost no change really in what they look like going into coming out. And then in the second year is a little bit different, look like close to 12 frames of bees going in October, and then 11 or 10 frames of bees coming out. So they don't seem to change much, I mean, they go backwards a frame or two. I don't know, what do you guys think?
I would agree with that. I don't think we lose much, if we lose any at all. There's usually enough brood in them going in to make up for any bees that died over the winter.
Yeah, it's really the weak ones that tend to, so if it's a 6 framer for us before it goes in, we try to cull most of that out, because those are the ones that tend to lose 2-3 frames. And then you get it out here to the almonds, you put all that money in, all that shipping, and you got a 3 framer for pollination, and it just doesn't pencil. So the big stuff hardly loses, is able to maintain, but those small ones that are on the bubble 5 frame hives seem to be the least economical to overwinter.
So Jason, you screen your hives before you put them in then, and take the ones that are weak and not bother to carry those forward? Or are you doing that screening when you're taking them out?
We're doing that going in. So I think most people, they're going through their bees. It's that one last time that you're able to go through your bees in the fall and see how the weights are and how the mites are. That during that last checking is when we're pretty hard on them. And if they're not meeting grade, why are you going to dump all that money into overwintering them, shipping them, placing them, and then picking them up when now they're a 3 framer in January? It just doesn't pencil. So that's been hard, because it's been mentioned a lot during this conference that you can't put those weak ones in and then hope to get something better out. It never goes that way. And the weaker they are, the worse they seem to decline over winter. At least that's been our experience.
Similar for you, Nick?
Yeah, we cull hard in the fall. We don't put a bunch of small ones in. They just double them up, triple them up, whatever we got to do in September, October to get them big, or just knock them out on the ground. It doesn't pay to put the junk in there.
Yeah, and that's like what I hear both these guys saying, is that it costs just as much. Well, really, it probably costs more for those little ones, but it costs just as much to haul a 3 framer to almonds as it does to haul a 12 framer to almonds, right? But only one of those pays you money back. So
right. Kind of picking up again on the bees that go in, Danielle had a question to you, Brandon, that you once were considering studying whether it's best to move hives indoors with or without field bees. And did you ever do that or conclude anything from that?
Yeah, it took me a second. I think what that is related to was this putting bees in at times other than the winter. And so I think it was the fall one, the beekeeper we were working with, just the way it worked out, wanted to move them in the middle of the day, and that caught me by surprise. Normally these things get moved at night because they're flying during the day, and this is August, it was hot. And so I think what that is that I think that's maybe not a bad idea, really, because those field bees aren't going to survive. If you're putting them indoors for 18 days, they're already foragers, they're old. They're not going to really contribute much to raising brood and things like that. All they're going to do is, for the week or so that they live in there, they're going to consume some of that honey and things like that. And so I do think, this is, again, these sort of little details that if someone was going to go for it, this is maybe on the line of like fine tuning, but it maybe wouldn't be such a bad idea to take those bees out of the field and put them indoors while the field force is out foraging, and just lose those bees, or you only take half the yard or something, and then those go into hives you're leaving in the field. So that might be a minor thing, but you have a few thousand bees that aren't sucking down the food reserves and not really contributing to what, those end up just dead on the floor of the building anyways. So you really only care about the brood and the young bees at that point. So
interesting. I know I've seen videos, Jason, of a lot of sweeping of dead bees in your facility.
Yeah, it's pretty shocking the amount of dead bees when you go to ship out. I remember the first year we thought perhaps we'd killed like everything in the building, as you see what's building up, and it's a lot of bees that get kicked out of that entrance, but don't be shocked.
Yeah, maybe if those were the foragers, maybe it's not worth putting them in. It's an interesting question. So a few really broad questions to you all. Looking back on having a purpose-built bee storage, is there anything you would do different if you had to do it again? So I think any of you could answer that. Jump right in.
Not really.
What's that? Nick, why don't you talk first?
We're pretty happy with what we have. Yeah, I maybe would have built it a little bigger to store the same amount of bees, so we had a little more room for loading and unloading. But other than that, I don't know if that's feasible, or if we would have just continued to fill it fuller. The problem.
Kind of like your house, filled to
garage, just like the garage. Yeah.
We made a few changes to ours over the years, and still have a few things that if I could do differently, I guess I would. One thing that's different, we load our bees at 20 degrees. So when we're loading the building, we actually have it at 20 degrees, and that causes them, it's that fight that someone was mentioning yesterday where they're wanting to be big and active and you're wanting them to shut down and realize that this is the end. And so we put our building at 20 degrees, and we weren't able to get anywhere near that with our first iteration because we didn't have heated defrost in the system. And so we really could only keep that building at 40. And when you pull in a hot truck, so you opened up the doors at the beginning, you've pulled in a hot truck, you've got forklifts running in there, you've got employees running around, you're in the hottest part of the year, you've got the most brood, the biggest colonies, everything's working against you. And so those bees start crawling and coming out, and it's just a hassle to work with. So we found that by going to 20 degrees when we're loading, and that's partially because we're coming in straight from the field and we're coming in earlier than I think most others, but we redid a lot of our evaporators to be able to achieve this 20 degree, and everything's worked a lot better for us. Once we get the building loaded, then we bump it up to that 40, 42 degrees for the storage period, but it helps shut them down really quick and not have bees, out and crawling. One of the things I think would be really nice is if we had in-floor scales so that we could perfectly load our semis to 80 or 86,000 pounds, depending on, where you're going. We didn't do that, and we looked a little bit at a retrofit, but the cost of installing that post looked high, and then the maintenance of them. So we didn't look into it a lot, but I think scales in the floor would have been a really nice, we'd utilize that a lot. Mice is a consideration, that there's probably a lot more mice than what you might anticipate. Same with, like I said, with the dead bees. So how are you going to control those mice? How are you going to keep them from running rampant in your building and chewing on things? I want to say last year we were catching over 50 mice a day for a while on the front end. So other areas may not be so bad, but I don't know. Our bees are very attractive for mice, apparently. So I bet we pulled 200-300 mice out of our building, last year.
I wonder, Jason, and somebody mentioned this too, is that especially now with the first couple weeks where the CO2 goes up quite a bit, is that reducing your mite population in that building at all, you think? I mean, because 50,000, for a mammal, like you just said, for humans is deadly. I wonder if it's killing mice in the building at 5% CO2.
Yeah, we did push that up earlier this year. One of the things is we have two modes for the building. So normally it's running to be optimal power and efficiency until it gets to that 50,000 threshold. then we're going to vent for safety of the bees. But when our employees are in there, we have it in like human occupancy mode. So we hold the building at 8,000 at that point. And most of that, because we're loading that building over a 2-week period, we're setting mice traps. And so every night on the front end, that's when we're hauling out those 50 mice a day. And the CO2 levels aren't high. Right. Once all the bees are in and loaded, that's when we turn off the human occupancy mode and let those numbers rise. And I am kind of curious because we did that sooner this year. So like as soon as we got it loaded, that ramped right up. And I am curious to see if we have dead mice in the hives, more so the past years. But I don't have an answer yet. Yeah, cool.
Hopefully not rotting away and causing some sort of problem.
Yeah, and is that better or worse, right?
Right.
Are they cold frozen, or are they turned into this liquid goo that's run everywhere and they've chewed up frames and yeah, so we'll find out, I guess.
It sounds like getting the bees into the facility is a little bit like when you have young children and you're trying to put them to bed and they're running around and coming up with a lot of excuses. Kind of a follow-up question there. As you're doing that, do you not plug? It sounds like you must not be plugging the entrance to each hive. That was a question. As you're bringing them in, so they can escape and run around like little children.
Yeah, that's a good point. I mean, just for those beekeepers that are out there, I remember when I first started doing bee stuff, we had a lab manager that was doing a lot of stuff with wrapping hives and things like that to protect them from the cold and all that stuff. Bees are amazing in that they don't need a lot of that kind of care. And so when she was doing that kind of stuff, those hives ended up being the worst off. And I think it was because of ventilation issues. So I think the bees are much better off with lots of ventilation, which seems counterintuitive. Like your home, you're trying to seal your house up to keep it warm and to keep this drafty air from coming in. But I think bees, they do better with lots of ventilation. So it's not a good idea indoor storage or outdoors in the winter or whatever to seal those hives up too much. They need to breathe and ventilate. They need to move air for moisture control and all kinds of stuff. So you don't want to plug entrances. In most cases, you want to give them an upper entrance and a bottom entrance too.
Another question, have any of you looked at whether it would be better to have several smaller buildings versus one large one so that you could manage each building a little bit separately, maybe even use them for slightly different purposes throughout the year at an economy of scale? Like if you want to do queen banking, for example, you might not need a huge building, but you can do temperature control. Has any of you looked at that?
We have 3 buildings and I think it's beneficial. I can put certain guys in certain buildings, and then we can also, like we have one that's full that we're done with, and we're going into the other 2 and 3 right now. So I think it's beneficial to have them in separate buildings, and then also your eggs aren't all in one basket. It's cheaper to build a bigger building per square.
Yeah, I'd agree with that. I wish we had 2. My business partner had looked into doing like partitions, insulated partitions that we could close off sections. We haven't done it, but I know we've had some discussions about doing that.
So that's maybe a lesson for the future. There was another question about technology. Is there any technology that you all might see on the horizon that would make this a more effective or more cost-effective system? One I'm thinking of is in the video that we last saw, some folks used infrared to look at their hives as they're coming out. That would be one example. Anything that comes to your minds?
Not right offhand. We have infrared camera. I haven't had the best luck. Maybe we don't have good enough ones. I don't know, but we haven't had the best luck grading hives with an infrared camera, getting a true grade on them. Sometimes they show big and they're small, and some of them show big and they're vice versa. But that's just been my experience.
Yeah, we've had the same problem where the honey is such a thick insulating wall that it will block out that thermal, so it looks dead, and really it just had more honey than the neighbors, and so we've had a tough time getting anything reliable with the thermal cameras. But I have hope that someday, as we talked about, there's a varroa control that we can introduce through the ventilation system. And I think that'd be a complete game changer where you could pull in your load of bees, treat everything in, a matter of hours and pull that load out and know that they're clean and you got it uniform, you applied it, nothing got missed. The environment in which it was applied was very tightly controlled, because a bee yard is not a very good controlled environment. So I think that someday there's a lot of potential in that disease, whether that's mites or foul brood or chalk brood or whatever the current disease we're battling, being able to treat inside a building. I think there's a lot of potential there. And, perhaps some sort of sensor technology. When you've got all your bees in there, you've got a place where you have reliable internet, network connectivity, that it's easier perhaps to have censored hives, or at least some sensors in there to have a general feel than it is out in the field. So I think there's potential with technology to integrate some sensors into hives and know more real time what's going on in there. But
yeah, I like the idea of being able to treat hives before they get to California, because we talked a little bit yesterday about the drifting and things like that when they get to California. So even when they're spread out, and you have, no matter what, you generally have these mite bombs, the 1 in 10 colonies or something like that have high mite levels, and then those mites get spread around. Especially, you got to let them fly a little bit before you're going and treat and feed once they hit the ground. So it'd be, and the more that happened, or the more folks that did that, the cleaner neighbors would be, and within your own outfit when they hit the ground in California and start flying. The cleaner, the better, for sure. It'd be cool.
Brandon, I got a question for you, just because we do the same type of things for vegetable storage, fumigations and things like that, for sanitizing. So you mentioned that formic acid is pretty harsh if you are in killing queens and things like that. And then you said oxalic acid is not labeled for fumigation or anything like that. Is it, if it was something that you could thermal fog in, and like Jason said, we use the ventilation system like we would in any other vegetable storage, is that an option? Is it just labeling that is holding it back, or is it just not a viable chemical that could be used in a fogging situation?
That's a good question. And I should say, oxalic is labeled for fumigation. It's just specifically labeled to not be used indoors, or you can't fumigate it indoors. So you can take it outside and use oxalic fumigation. So that is a little bit of a label issue. I don't know, I think part of it is just a need for more research. What I hear some people saying, and it's a good, theory, is that it's tough to get that whatever compound you're fumigating inside the hive when bees are ventilating, and into the cluster, right? They're clustered real tight, and they're not fumigating material through the whole tightly clustered ball of bees in the center of that thing. So, but that's, I think hasn't been explored fully yet by any means. So I think that there is still potential there.
Taking note of that as potential follow-up opportunity for us.
Yeah, for sure. Or I think John Miller had, the idea, maybe it's you tent the loads before they go out or something like that. Instead of trying to fumigate 15,000 hives in a building, you do it 400 at a time.
And so, kind of a follow-up on that, Anthony, to you, the HVAC systems that you're typically installing can handle fumigants in them?
Oh yeah. We'll use on potato and onion storages. We use PAA acids to sanitize, and both wood, and it's industrial grade equipment. It's that type of acid. It'll chew through anything. On your body, but once it's fumigated, because it's being mixed 1-to-1 with water, then a lot of its damaging properties aren't necessarily as harsh, I guess, for lack of a better way to describe it. So that's where my question was with the oxalic acid, is that's, if that be an option, but, is it says not for indoor use because generally there's people present. So is it, something that you go and you talk with, the chemical company? Because we've done it's happened before, where if you just sit there and they talk with labeling with, USDA and everything else, and it's just able to change the wording because it's already been an approved chemical, then that's where I don't know. I'm just kind of spitballing out here, and
I think it could be. I don't, and one thing I wondered though too is about how do you safely vent that kind of stuff? So what do they do in potato storages? I mean, as far as like when
so
they're
with
done,
with the PAAs, we have, label says you have to have a certain amount of contact time, whatever, for the volume in there. So whether it's 3 hours, 4 hours, 6 hours, whatever that is, and then you purge it out just like you would do a CO2 purge. You open the doors and you purge that out into atmosphere, and then it's gone. And there's usually a re-entry interval in those things, whether it's 2 hours, 4 hours, again, whatever labeling is said. But in those scenarios, you can go right back into the storage very soon. And so and those type of things, it's going in as a pure vapor, and there are no residuals left on product. So
right. I mean, we fumigate nuts in the processing step when in order to reduce insect damage. So there's very well established protocols with regulatory agencies on how to fumigate foods in a safe and effective way. Some other points about whether it would corrode the surfaces and so forth. So that's just, it looks like this could be a fruitful area for some additional investigation of a variety of sorts. It's good topic. Okay. I am not seeing any new questions, so I'll give it another minute or so. And again, I've sort of been taking some notes on things that could be good follow-ups to further the developing tools that are practical to help implement the system. The idea of some kind of calculator or worksheet to look at costs and returns associated with different types of beekeeping operations from different parts of the country, really honing in on any guidance and considerations for a retrofit versus a new build, some of the sentiment about multiple smaller facilities versus one large one could be part of that. Maybe interesting to look at this question of getting rid of the field bees by putting them into storage during the daytime rather than the nighttime. That might have some cost return implications. The idea of fumigation and potentially this idea of putting hive monitors. No end of companies I've talked to that all have new versions of hive sensors and artificial intelligence algorithms to help you tell all sorts of things, but potentially a role there.
And I was just going to mention, Josette, is kind of like what Brandon said. I mean, he gets a lot of his research from the beekeepers, and that's where we get a lot of our crazy ideas potentially with ventilation systems. Is, I mean, it's a computer program to run things. And so if someone has an idea, I mean, it's literally as simple, we can adjust something by, if Nick comes and says, you know what, I really want to try this, then okay, we can write a program and implement it. So that's, I mean, anymore, there's sensors and technologies that are being created so fast on, a year to year and even a month to month basis that things can be adjusted and switched pretty quickly. So that's, I mean, I would say in general, I mean, no idea is too crazy to at least, remotely think about or look at. So, I mean, if there's, like Brandon said, I mean, if there's ideas about something on that, then throw them out. And whether it's viable in the end and cost effective, I think that's the other side of it. Is all of a sudden, like Jason was saying, if we could put sensors in all these, in the hives, and you could get real time data about what's happening inside the cluster and things like that, but each one of those sensors is $5,000, then all of a sudden that makes no sense. So
right, there's some sweet spot of the value of the information and the how much you can sample, because no one's going to put one in every hive. And we've been approached by a couple companies about funding the testing of those. So that might be something kind of across the board we consider. And Danielle and I talked a little bit about that with Bee Informed Partners as another option. Okay, how to figure out one. Just a couple of other things here. So George is weighing in again, and this might be part of this calculator worksheet on how long does it take for the building to pay for itself? Have any of you, Nick, Jason, or Brandon, looked at that in terms of the time to return on investment?
10 years, that'd be my guess. If nothing goes wrong, we don't have to replace anything.
Yeah, I mean, it was costing us a lot the way we were doing it, and we really didn't we just kind of looked at what's better for the bees and how much of an improvement do we think we can make, and we felt like that improvement to bee health was going to be so drastic that we were willing to pay, whatever. So it's just so hard to quantify. Our bee health has improved greatly, but what would it be? Things change quickly in the industry, and how much is that due to each factor? But I think ours probably penciled for us maybe more in the 5 to 7 year time frame. And I did see Tim had a question about special protections that I'll just mention on shipping bees in the winter, because we were highly concerned that we're going to be shipping these things in January, and for such a large distance. We used to do Idaho to California, then we went to North Dakota. We felt like, man, that's going to be a really cold blast of air for a long time. Some days it's still negative 20 degrees when we're shipping out of North Dakota. So we were putting tarps on the front of the semis, kind of as a wind block, and wrapping those around a little bit. I think we've completely abandoned that. Yeah, I mean, we have them, but we just haven't seen, we've run them both ways, and we haven't seen that we're killing those front hives like we had thought. So that was a concern. We don't have the horror story to share with you, Tim. So.
Yeah, thank you.
Good. We have enough horror stories on bees. We don't need any more.
Yeah, and I think the other thing too that makes it complicated to figure out how, the cost recovery thing is that, like we heard from Bryan and Buzz yesterday, is that there's things that are even harder to calculate, like the labor savings maybe, or these ways that you end up using buildings that you didn't even plan on, or the not even directly labor savings, but like the happiness of their employees to work, or that they're more efficient because they could start work right there and they didn't have to drive out to the yards. And so I think depending on exactly how the building gets used, that calculus changes quite a bit.
Yeah, and on that, I guess this is where really sitting down with a few beekeepers is really good, because I know in production ag, sometimes the labor isn't so much that you have one less person for that task, as so much as you can deploy those people for other tasks, and the whole operation benefits, because people aren't doing just one thing usually when they're employed, and so you kind of have to look at holistically. All right, another question about the CO2 levels and the value of getting the CO2 up to 5%. Is it possible to reach that without a tightly closed ventilation system or tightly closed system? My guess is not, but Anthony, you might be an expert on that.
I guess it's what's your definition of tightly closed? If it's you got a gaping hole in the wall, then no. But I think if it's relatively tight, again, without, bunches of holes and things like that, if you got that many holes, like Jason said earlier, then they're probably, that light's coming in and they're probably going to want to go to that hole anyway, and you've got bigger issues on your hands. So if it's relatively sealed up, I think you could probably still achieve that given enough hives. If it was, you have to have a load to create the load. So, unless, I don't think you could do that if you had a larger facility and only a couple thousand colonies. I don't think you're going to be able to do that.
Right.
So,
I was surprised, that they were able to get it, like Jason, and you have to vent it, right? Like, what you think it would continue to climb if you didn't vent it? Okay.
So, absolutely. Yeah. So we had an issue where we suspect we could probably go to about 100,000 would be about where our building would sit if we didn't vent it at all. when it's really windy, so our building's spray foamed and, insulated on all the doors, just like all the things Anthony was talking about. It's very, very tight, complete pitch blackness, can't see your hand, your finger an inch from your face. And then infrared cameras and infrared lighting in there so we can see everything, even in that pitch black online. But when it's really windy in North Dakota, we have the vent louvers that are double insulated vent louvers. It will somewhat blow those open and the building will quickly decrease down to even 20,000 after 5-6 hours of wind blowing. But yeah, it absolutely is. It will get higher than that because our logic hits at 49,500. It hits and then it vents down and then it hits. So our graph looks like this little peak where you can see it bumping up against that 50,000. And I don't, 5% is nothing magical other than I said to Brandon, I don't want to experiment with our entire company. I'm going to come up there and strangle you if I kill all my bees. So what do you think we can do safely? And he said, well, I'm comfortable with 50,000. And I said, a lot of people I talked to are like, yeah, I'm opening up all the doors every night. I got to 7,000 and, was super worried. And I've talked to other guys and one of them hit 10,000 and I'm just thinking 10,000 and we hit that in a couple of hours. Like what, I think we were limiting to 30. And then when Brandon felt confident at 50, we pushed it up to 50, but we don't really want to run any experiments on our bees. And so far, 2 years now and Brandon's still alive, our bees are still alive. So, but I don't think that's a magic number. Maybe Brandon can speak a little bit more to why he threw that one out.
No, I don't think it's a magic number. It was like I think a safety thing, so I didn't get beat up, so I think, we had the bees survive, at 80,000 or 8%, for a couple months, without really any ventilation. And that was even pumping CO2 into those incubators to keep it at that level. And the bees survived. So, I felt fairly comfortable at 50,000. And because of the research showing that cluster naturally can sit all winter at 6%. So, I think that 5% has a good level of, safety, a margin of safety. And like you said, if they were safe at 8% and then something goes wrong and it climbs to 10%, and that's when they start really suffering. You don't want to be playing anywhere near that line, because things can go wrong. The sensor goes bad and the sensor says it's at 5%, but really the building's at 10% or something. So, you don't want to mess around too close to that line, I don't think, especially with that kind of value in that building. It is amazing.
We don't want to stress you out too much, Brandon. It sounds like some of your research already does that, working with queens and real beekeepers assets. So want to keep it manageable. Well, I think we are petering out on questions for the panel. So I'd like to really thank all of you for joining us. Jason, for jumping in at the last minute. It's great to hear the practical experience as well as the good science that all of you bring to this equation. So thank you very much. Maybe I'll invite Danielle back or to help me wrap up the event here.
Thank you.
Yeah.
Thank you.
Thanks, everybody.
Thank you.
So I'll just say again, from my part, really, this truly exceeded my expectations in the sense that the level of questions we've had throughout these 2 days shows both we've had great experts, whether they're scientific experts or beekeeper experts, as our for the content, but that also all of you are engaged and really interested in looking at this as a potential management tool for your business. So that level of engagement is exactly what we hope for. And again, very open, whether you want to contact Brandon and Kelly or the folks at Project APSM or myself. We're all interested in figuring out what other tools we could bring to the fore that would help improve adoption of this. So with that, I'll see if Danielle, you have any concluding remarks, or Brandon or Kelly or Grace.
I'll just say that I think this went really well, and I really thank everybody that participated. Coming together and hearing from each other, I think, is really valuable. You know, we've got beekeepers and almond growers and researchers, and that's what we do. So thanks also to the film crew and the guys at Nick. You opened up your work at a pretty critical time and gave us a great tour. So I think it was so valuable to see and hear from everybody in the real world of practicing this indoor storage of bees. And I think everybody's pretty open to talking more about it. So it was nice to e-meet and virtually hear all of this. And we hope that more connections will continue. And maybe we'll, you know, maybe this will be an event where we update you all about this science each year. So I think this was a great success, and thank you, everybody.
Yeah, thanks a lot. It's really good.